With more and more companies moving to cloud, the popularity of cloud computing and its exponential growth is no longer a surprise to anyone. We have seen many cloud service providers making hay in these times. However, AWS or Amazon Web Services, as we all call it, still holds the market lead by a large margin. With that, we have seen many people wanting to make a career in this domain. Hi all, we welcome you to this full course on AWS services by Edureka, where we are going to talk about the most popular AWS service domains you must learn. And what follows is hopefully everything you need to know to get started with Amazon Web Services. But before we begin, let's take a look at our agenda for today. First of all, we're going to start with AWS Fundamentals, where we will learn why cloud, what is cloud, features of cloud computing, what is AWS, AWS Global Architecture, and AWS Domains. Secondly, we will discuss the most popular compute service in detail, that is EC2 Service, AWS Elastic Beanstalk, AWS Lambda, AWS Lightsail, AWS ECS, AWS Fargate, AWS Autoscaling, and load balancing. Moving on, we will cover popular storage services like AWS S3 and AWS Glacier. Post that, we move on to database services that AWS has to offer to us, namely AWS RDS, AWS DynamoDB, AWS Redshift. Next up, we will discuss some popular AWS management services like AWS CloudWatch, AWS Config. Then we will discuss AWS Security Services like IAM. Then we will move on to discussing networking services, where we'll learn about AWS VPC. In the final bit of the session, we will discuss some popular AWS DevOps services. With all of this said, we come to the end of the agenda for this session. Also, kindly take up some time to go ahead and subscribe to us, and do not forget to hit that bell icon to never miss an update from the Edureka YouTube channel. Also, to learn more about AWS, do not forget to check out our certification training, the link to which is given in the description box below. So, without much ado, let's get started.
Today we are going to get started with AWS, that is Amazon Web Services. But before we do that, let's quickly take a look at today's agenda first. Well, I would be starting things off with why cloud and what it is. I would also discuss its different features. And why are we doing this? Because AWS is a secure cloud service provider, and it is important we understand what is cloud first. Once we've understood this, then we would get into the nitty-gritties of AWS, that is, what it is, why it is needed, what is its global architecture, and how to choose a region in AWS. I would also talk about different AWS domains. Finally, I would finish things off with the demo part. I hope this agenda is clear to all of you. So let's not waste any time and get started then. Well, this was the scenario before cloud computing came into picture. In order to host a website, you would be obviously needing some space, so there was a need to buy a stack of servers. Also, keeping the peak traffic in mind, the servers, as in whether to buy them more or buy less servers, was considered. And monitoring and maintenance of your servers was another thing that was considered. Now, what did this situation give rise to? Well, there were following disadvantages. One, the cost. Now, servers are very costly, and if you're buying a stack of servers, it is going to cost you a fortune. Now, imagine you have to buy, say, 2 to 3 petabytes of memory or servers rather. So what you do in order to buy this space, you invest money upfront, and say for example you need this space for 2 years. There's a high possibility that you might be using only 10% of these resources. What about the remaining 90%? Well, they are kind of underused for maybe 6 months, 1 year, or whatever it is, and after that they come into use. So in this case, you're wasting a lot of resources, that is your space, plus you're also investing a lot of money. So this was one disadvantage. Again, troubleshooting these problems, as in taking care of servers and all those things, was another tedious task, and that kind of diverted people from their main business goals, and that wasn't convenient. Apart from that, this traffic, it varies. Now, there might be some hours in the day where the traffic is very high, and in remaining hours, your website or your server is idle and is doing nothing. So say for example, you invest in 10 servers, and those 10 servers are fully utilized only for 3 hours a day, and remaining 21 hours, the traffic is very less, say only 3 servers are required. So you're actually wasting 70% of your resources. So you end up paying more, you end up underutilizing or at times overutilizing your resources, and that can be a problem. Apart from that, there is another important factor which one needs to consider: the amount of data that is growing these days. This data is huge, and the fact that people are using internet so much, it's understandable that people would be referring and using this digital data. And it is expected that this traffic is going to rise 3 times in coming 2 or 3 years. So yes, there's a lot of data and there's a problem. Where do we store this data? How do we keep it secure? How do we manage it? What about the hardware issues, the maintenance issues? And there's so many questions. And what is the solution for all these things? Well, it is cloud. You can move your data from your local systems to cloud, which has infinitely huge amount of space which you can use. You can dump, store all your data there on cloud and let the cloud providers take care of all your issues. What this does is this kind of helps you solve a lot of problems. One, you are paying only for the services and resources which you are using. This payment which you do in most of the cases is on timely basis. That is, you pay only for the time duration for which you use these services. Also, it is highly affordable. So you do not have to worry about your upscale, downscale. You do not have to worry about the time for which you would be using the resources. And you do not have to worry about the other hardware and all those issues as well. So this is where cloud comes into picture, and it helps you almost all the problems that were there before cloud came into existence. So what exactly is this cloud and how does it help us solve all these problems? Well, you can imagine cloud as nothing but a connection of networks, servers, and computers basically. And these servers and computers are basically owned by some third party and they reside somewhere on the globe. What organizations do is they just go ahead and keep and buy these huge stacks of servers, and you're only expected to go ahead and rent these services so that you can make optimal and proper use of these services. It actually lets you manage, store, process, and access your data. And all you need is internet. You can sit anywhere in the world and you can have access to these resources or your resources which lie on the cloud. So this is where cloud computing is so effective. So what exactly is this architecture and what does it do? Normally the applications these days which people use are multi-tier. So what you do is you are sitting at some place on the earth somewhere with your internet services and you want to access your data or your resources. What do is you just have your interface and your internet. You type in your request and there is something called as a middleware which takes in your request and forwards it or sends it to the backend where your data resides. Now, this is a collection of servers and different computers which are kind of in a network. So what happens is your request is sent there, your data is fetched, and it is sent back to you where you can easily refer it. And you do not have to worry about any complications whatsoever because your data is residing on the database or on the cloud, and there are people who take care of your data, your hardware issues. You do not have to worry about the hardware issues, as in, are my resources getting updated? Are my applications getting updated? Is there sufficient space to use this data? How is this data getting stored? Who is taking care of it? What about the security issues, the compliance issues? Well, everything is taken care by experts, and all you have to worry about is just consuming these resources. And this is where I feel cloud computing or cloud has solved a lot of problems that was related to data, websites, and online applications. So this is about the basic architecture as far as the cloud computing goes. Now let us go ahead and take a look at different features which cloud computing has to offer. Now we've discussed quite a few of these already, but let's try to put little more light on these points. Now, what cloud computing does is it provides you with on-demand provisioning. When I say this, I mean you can ask for whatever you want, whenever you want, and in the amount you want. This means when you talk about scalability, it can happen in minutes and you can upscale, downscale depending upon your requirements and your business problems basically. Then what you do is you only pay for those resources which you are actually consuming. So it is very cost effective. And when I say you pay only for those resources, even the amount you pay is again very less. As I've already mentioned in the beginning, servers, buying those can be very costly. But when you rent those using these cloud service providers, they are very, very affordable. And the amount that has been invested these days is very less compared to what it was invested back in 2000s or early 2000s. So yes, even the cost for cloud computing investments or the cloud has dropped down a lot in last 10 to 15 years. And whatever you pay these days is very, very, very less. Abstract resources. Now you have to stop worrying about, as I've already mentioned, what happens in the background, the hardware and all those things. You just focus on your business goals and that's it. Plus, you can focus on the things which you are efficient at, and the experts will take care of the remaining problems that we just discussed. Apart from that, whatever you use is measurable. So the time factor, the cost factor, and the money factor, everything gets optimized here. So these are the features why cloud computing is so valuable. Now that we've understood what cloud computing is, what cloud is, let us go ahead and see what are the different cloud service providers. To be honest, there are quite a few service providers in the market. We have IBM Cloud, Microsoft Azure, we have Google Cloud Platform, Dropbox. All these service providers are great, but AWS leads the way. Now, why is that? Well, there are quite a few reasons why AWS is so popular. Let's move further and try to understand these reasons. First of all, the cloud computing market share. Well, AWS has the highest share, and when I say that, it is 69%. That is, it is twice the amount if you compare it with all the other global cloud service providers combined. That is, which is just 31%. Now, if you compare it with Microsoft Azure, which is the second best, it is less than twice the total amount which AWS has to offer, and that is a huge amount. Now, if you talk about server capacity, similar is the case. Actually, it is even better for AWS here. How? If you talk about server capacity, all the other competitors combined, they provide you with a server capacity of X, whereas AWS would provide you with 6x of server capacity, and that is again huge and huge by huge margins. If you talk about pricing, Amazon Web Services, highly flexible. It provides you with two options. One is pay only for what you use. That is, you'd be paying only for those services and only for the time duration you use them for. Say, for example, I'm using maybe 2 petabytes of data for 2 hours a day. I would be paying it for only 2 hours of day and 2 petabytes only. Plus, it also provides you with a feature called as pay less as you use more resources. That means the more the resources you use, the more the services you use, you'd end up paying a lot lesser. So when you have such flexible pricing, such great share in the market and server capacity, no wonder you would be the best tool in the market or the service provider. And that is what AWS is. Now let us try to understand what exactly AWS is. Well, it stands for Amazon Web Services, which I've already mentioned. What it does is it gives you a platform, or it provides you with cloud computing capabilities. It is a remote computing service. It gives you storage abilities, provides you with bandwidth to do all the things you want to, and it has great customer support and huge customized approach to your APIs or application protocol interfaces. All in all, a great tool to have when you talk about the cloud services. So who are the companies that use AWS? Well, there are quite a few companies in the market that actually use AWS, and to be honest, almost every company has its foot into AWS in some way or the other because everybody needs cloud services. To name a few, we have Netflix, we have Adobe, we have Reddit, Amazon. Now, all these companies, the amount of traffic which they handle every day is huge, and they're being used globally. So it's understandable how powerful Amazon Web Services is. And if you're using AWS, you'd be sharing space with these companies, which is a wonderful thing to have. So what does AWS do? As in, how does it go ahead and provide you with all these services and all those things? Let's go ahead and try to understand its architecture or its approach towards providing cloud services. Well, basically its architecture or its framework is kind of divided into regions, zones, and edge locations. Let's try to understand these a little more. Well, the structure is basically divided into regions and availability zones. I would also come back to edge locations, but let's stick to these two first. Well, what AWS does is it kind of has its multiple data centers across the world in different globe locations. What this does is it helps AWS expand its reach. Now, if I'm sitting in India, I would be wanting a resource that is close to me or the cloud service provider that is close to me. So if there are data centers in India, and if I'm in India, it would be easier for me to access this AWS platform. So what AWS does is it does exactly that. It has its data centers all across the globe, and these data centers are called as your regions. And each of these regions will have multiple replications, and these replications are called as availability zones. Say, for example, the one in India, which is in Mumbai, has two availability zones. Now, this is how the architecture looks like, or this is how the reach is when you talk about AWS. Now, you can see their centers almost everywhere. You talk about Oregon, you talk about California, Virginia, Sao Paulo. Now, Sao Paulo, for example, it has three availability zones. That is indicated by the number in the circle which is there. Now, again, if you go to Mumbai, as I've already mentioned, it has two data centers, or rather two availability zones. So this is how the infrastructure or the global infrastructure of AWS looks like. So what are these edge locations which I mentioned about a while back? Well, say for example, I'm based in India and I do not have a data center here. I'm kind of forced to use a data center which is in maybe Virginia. So I have to have my data in Virginia and I have to access it from India, which might cause a lot of problems. The latency issues and all those things. What if there was a center which was there in the interim or in between, or maybe a bridge or a platform kind of a thing that helped me connect these two places? Well, that connector is called as an edge location, which helps me overcome these problems of latency and all those things. So yeah, this is how the infrastructure basically looks like, and I believe it is fairly easy and simple to understand. So let us move further and try to understand the next topic then. How does one choose the right region? Now, yes, if we have so many regions, there would obviously be a question. If I'm based in India, what are the things I need to consider? If I'm based in London, what are the things I need to consider? There's so many points. To start with, we have something called as pricing. Now, these pricing, they vary from region to region. For example, the one in London would be costlier than the one that is based in Ireland, that is in Dublin. So you might want to consider that as well. Other issues are customer and user location. Also, where are you based? Since you are based in maybe on the eastern end of the world and you want to access something that is on the western world, that might be little inconvenient for you and also for the service providers. So it is wise you pick a region or choose a region that serves your purposes. Apart from that, we have latency, which I've already discussed. Depending upon the latency, you would also want to choose the region so that your services are provided to you at a faster rate. Security and compliance requirement. Now, these might also vary from government to government. Different countries have different laws, and accordingly, these compliance requirements may also vary. Service availability. Now, this is also another important point because not all the regions will have all the services which you need. So depending upon that, you might also be forced to choose a region differently. So these are the features, or these are the reasons rather, why you need to be careful when you choose your service provider or your region. So based on these reasons, you can always go ahead and pick a right region that meets your needs. I hope this is clear to all of you. So let's move further and try to understand the next topic. So yeah, next what we have here is different domains in AWS. And there are quite a few domains which provide you with different kinds of services. And we have something called as compute. Now compute has various services like we have EC2, Lambda, Elastic Beanstalk, Autoscaling, and etc. Now EC2 is a very popular service. It is called as Elastic Cloud Compute. You can think of it as a raw server using which you can basically host your websites, applications, etc. And in simple words, it's a clean slate. Say for example, you buy a new laptop where you start from the very beginning, where you install the OS which you like, you install the applications you like, and you start using it. It is that kind of a thing. And it is highly flexible. It is highly resizable and customizable, to be honest. Then we have other services like Lambda. It is something that cannot host websites, but it takes care of all the background tasks that are there. One more application similar to it is Elastic Beanstalk, but yes, it can host websites. And how is it similar or dissimilar to EC2? Well, in Elastic Beanstalk, yes, you can go ahead and host your websites and do all these things which EC2 does. But EC2, as I've already mentioned, it is more of a clean slate kind of a thing. Whereas Elastic Beanstalk, think of it as a place where you already have libraries. Say, for example, you have to use Java. So your Elastic Beanstalk is something that will have all the Java libraries and you can just go ahead and use Java there. So this is the difference between EC2 and Elastic Beanstalk, where Elastic Beanstalk will support the defined applications, whereas your EC2 is more clean slate kind of a thing. So yeah, these are the compute services which AWS provides you with. Then you have something called as migration. Now, this is where you move or migrate your data to and fro from your applications or the place where you reside to your cloud. Now, this migration happens online as well as offline. Yes, there is something called as Snowball. What it does is this service actually lets you physically move your data. Now, why do you need to move your data physically? Well, say for example, you need to move your data from XYZ place to your data center at AWS, which is at maybe ABC place. So, and if this data is huge, it is wise to move it physically. It is similar to sending a mail to one of your employees. Now, if you're just supposed to send him MOM or minutes of meeting, what you do is you just go ahead and type a mail and send it to him. But what if you had to send him, say, maybe 10 or 15 movies or video clips? You would instead give him the hard disk in person and ask that person to use it, right? Similar is with the data which you have. If the data is in huge amounts, it is affordable and advisable to transfer them physically, and that can be done by using one of these services which is called as Snowball. Next we have security and compliance. Now there are quite a few services again that come under this domain. We have IAM, we have KMS. Now IAM is basically nothing but identification and authentication management tool, where users are identified, they are validated and authenticated to use the services that AWS provides. Then you have something called as KMS, which is more of an encryption kind of service, as in where you can create your public and private keys. But it is very important to understand that the private keys which are created are kind of risky to use. That is, you have to be very careful with it that you do not lose access or use of these keys. So yes, KMS and IAM are the security and compliance services which AWS has to provide you with. Then you have something called as storage and database services. Now, storage and database services are little different from each other. We'll discuss those. First, let's stick to storage. Well, under the storage domain, there are quite a few other services. We have your standard object-oriented file system called as S3. Now, what S3 does is it basically deals in objects and buckets kind of a scenario. Now, what do I mean by this? Your files are treated as objects, and your root folder is basically a bucket which holds your data. Now, when you dump these files or when you store these files into your bucket, you have to make sure that it is on the root folder, and you kind of store your data using or in the form of objects into this root folder. So this is what S3 does. Then you have something called as CloudFront. Now what CloudFront does is it basically provides you with content delivery network. We talked about edge locations in the past, and that is what CloudFront helps you do. It provides you get rid of all the latency that is there in your system. Then you have something called as Glacier, which is again a storage service. It is a very good data archiving service basically, and the best thing about it is available to you at a very low price. Next on this list we have something called as networking and content delivery. Now this domain basically has services like VPC, Direct Connect, and Route 53. Now what VPC does is it provides you with virtual networks for better networking and traffic management basically. Then you have something called as Direct Connect. You can take a look at Direct Connect as an internet service basically, which is more secured and more in line with your AWS service provider. And then you have something called as Route 53, which is nothing but a domain naming system. So all these services, they come under your networking and content delivery domain. Next, you have messaging. Now this is like the simple messaging which we do. Yes, there are quite a few services under this domain as well. We have our CloudTrail and CL3. Now your CloudTrail is something that is a bulk messaging system, whereas your CL3 is more of a buffer or queuing service. Then we have database. Now, as I've told you that both storage services and database services, they kind of deal with storing data, because what is a database? Database basically holds your data, right? So what is the difference between these two? Well, you have to understand one thing. Database will not hold executable files. So if you have to store your executable files, they have to be on your storage and not on your database. So this is the difference between the two. So what are the different database services that AWS has to offer? You have Aurora, which is again a database system basically, but it is claimed by Amazon that it deals with SQL data and deals with it 5 times faster than what SQL has to offer to you. So if you're using this service and you have to deal with the SQL kind of thing, this is a very good tool to have, or a service to have rather. Then you have DynamoDB. This deals with non-relational or maybe unstructured kind of data, or is a service that helps you deal with these databases. There are quite a few unstructured databases. I won't be talking about those. That is a discussion for some other time. But your DynamoDB service basically helps you handle these kind of databases. And then finally, we have the management tools basically. And the management tools are something that help you manage your resources and data much better. Say, for example, we have our CloudWatch, which is a very powerful monitoring tool. And then you have CloudFormation, which is again a great tool when you talk about templatizing your applications or your infrastructure basically. So these are the different domains which AWS has to offer to you. I hope you all have understood this. In that case, we can just move further and get started with the next topic of discussion. So next, what I'm going to do is I'm going to go ahead and give you a demo of how to sign into AWS free tier, because yes, AWS has a lot of services to offer to you which are at free of cost. And normally people hesitate to log into AWS, and there are reasons for it because they have few constraints which AWS put you into, and when you sign in, you have to give in few details like credit cards and all those things. And this is where people think twice before signing into AWS. But let me quickly give you a walkthrough as in how do you do it, or how do you sign into your AWS account. So bear with me till I switch back to my browser and we can move further with the demo part. So there you go. What you do is you just go ahead and go to AWS's free tier basically, and you can just have access to the website. Yes, there you have it. This is how the free tier or the web page for the free tier looks like. You can just go ahead and click here and create your free account. But before we do that, let's go down and take a look at the other details which the free tier has to offer to you. Now, first thing you need to understand is this free tier is available to you for 1 complete year. Now, what does this mean? Basically, you can use few of the resources or almost all of the resources for free for first year, but there's certain limitations on its usage. And when I say 1 year, it starts from the day you first sign up for AWS. And when you do that, you have all these things at your access. Say, for example, Amazon EC2, which we just talked about, that is Elastic Cloud Compute. And what it does is it gives you 750 hours of access to the server node for the first year. And when you say 750 hours a month, that is a lot of amount to have. And you can do a lot of things using this much amount of time. Secondly, you have Amazon QuickSight. Now what it does is per spice capacity, it gives you 1 GB. Now I won't get into the details of what this thing is. It is something that is used for analytics, and let's stick to the main discussion. So I won't get into the details of analytics and what exactly does you provide with, or does the software or service provides you with. Then you have the database capabilities or the services, that is your Amazon RDS, which we talked about. And again, it gives you the database space for again 750 hours per month, and the instance is T2.micro instance. This is something that we would again be seeing in the succeeding sessions or the following sessions that would follow this session. So yes, we'll be talking about these things in detail again. As you can see, we have Amazon S3, which again provides you with 5 GB of standard storage, and AWS Lambda. Now what it does is it helps you process 1 million requests per month for free. And again, this is great to have. Then we have these things where it gives you step-by-step solution as in how to sign in and how to learn about the basic capabilities which AWS has to offer to you. So these are more introductory kind of video, basically 10-minute sessions which talk you through or walk you through the basics of AWS, as in the ones which we discussed in the video or we have discussed till time in this session is what I'm referring to. You can also go ahead and get into the advanced things as in how to build applications and all those things. So in order to create a free account, what you have to do is you can just go ahead and click on this icon, and your AWS website will redirect you to a page where you can go ahead and create your own account as in a free account. Now, I being an existing user, I have an access to getting into AWS and signing in for free. So that is not what I would be doing. I would be coming here and I would be saying, say I log into say I create a new account. So this is what I would be having at my disposal basically. I'll have to go ahead and put in my email address, my password, and I have to confirm that with the account name. Now, once you do this, what it would do is it would just ask you for your credit card details. Now, people fear that AWS might charge you for services. But then again, they've specified the limits very clearly, and as long as you stay in the limits, nothing would be charged from you. And before you do sign in, it asks you whether you want to use the services for free. And when you click on it saying yes, what it does is it makes sure that you are updated as an amount of access which you do out of this website and how many services do you use. It would keep you updating on those things. As I've already mentioned that it has great measuring capabilities and it keeps you updated with all the resources which you use so far. Yes, the only thing that happens is when you enter your debit card or credit card details, I've actually gone ahead and entered my debit card details and it did accept those details as well. So yes, you can go ahead and use your debit card details as well. Credit card is something that is preferable. When you do that, what AWS does is for the verification purpose, it would initially kind of deduct $1, that is $1 from your account. And once the verification is complete, which is a 5-minute process, that amount is refunded back into your account. So when that $1 gets deducted, you need not worry because that is just for the security or the authentication purpose. That's it. And once you do go ahead and create this account, what you can do is you can always go ahead and log into your account and you'll have all the services which are available for your access. Now, I would be going ahead and logging into my account, which I already have here on AWS. And once you do that, this is what the console would look like now. You have all the services available here. Yes, there you go. You can build a solution, that is you can launch a virtual machine, you can build your own web app, you can host a static website, connect to an IoT device, get into development projects, and even register for a domain. We talked about DNS and all those things. So yes, it helps you do that. There are other services provided by AWS, which is DevOps, which is very trending and highly trending in the market. This is something that combines our developers and operations point of view and gives you something which is a combined approach and helps you overcome various problems which both developers and basically system admins face. So yes, this is a great tool or resource to study or the tutorials to attend basically, because that would help you unravel various other concepts again. As far as the AWS services are concerned, we have all these services which are available here. You have your EC2 management tools, mobile services, AR and VR, which is augmented reality and virtual reality basically, application integration and all those things. You can just go ahead and click on these icons and you'll be redirected to those services. That is, you can go ahead and create your own EC2 instances and all those things. So for now, I don't think I've created any instance. Yes, see that 0 running instances. No sooner you go ahead and launch an instance, you'd be getting the updates here as in, okay, this is the running instance and all those things. To do that, you have to come here and you have to say launch instance, and there you go. The perfect guides available for you, whether you want to launch it on your Linux environment and all those things. So you can go ahead and select that. You can select the machine and all those things, and you can just launch your instances and get started with AWS. So this is fairly easy and fairly basic to get started with. I hope you all have understood whatever I've talked about till time.
Instances in AWS. This is a simple yet a very important topic. So let us just get started and first take a look at the offerings of today's session first. So guys, I would start this session by talking about what is an instance. We would understand what is AWS EC2 service, which is core for understanding instances in AWS. Then we would talk about different types of EC2 instances. We would understand how instance pricing models work, and we would take a look at a use case, which would be followed by a demo that walks you through all the stuff that we have talked about. So it is a fairly good content and a lot of stuff to study today. So guys, let us just quickly move further and take a look at these things one by one. So first and foremost, guys, we would be talking about an instance. So when you talk about an instance, we have this definition here. Let's try and understand what does this definition has to say first, and then probably I would throw in some light on that. So as far as this definition goes, it says An instance is nothing but a virtual server for running applications on Amazon EC2. It can also be understood like a tiny part of a larger computer, a tiny part which has its own hardware, network connection, operating system, etc. But it is actually virtual in nature. So there are a lot of words here and a lot of stuff has been said. Let me try and simplify this particular definition for you people. So guys, when I say a virtual server running on your application, not on your application, a virtual server that basically hosts your application is what I should say. So what do I mean by this? What do I mean by a virtual instance, a virtual presence of a particular device? Well, guys, when you talk about software development, application development, what you do is you're supposed to build in applications and run those on servers, right? But at times there are a lot of constraints like the space that you use, the resources that you want to use. Say, for example, certain applications run on Windows, certain run on Mac OS, and certain run on your Ubuntu OS, right? So in that case, I cannot always go ahead and have different systems, run different operating systems on them, and then run my applications on top of that, right? Because it is time consuming, exhaustive, and also consumes a lot of money that you invest into it. So what is the solution for that? What if I could have a single device and on top of which I could create virtual compartments in which I could store my data differently, store my applications, run my applications differently? Wouldn't that be nice? Well, when you talk about an instance, that is what it exactly does. You can think of it as a tiny part of a computer. Well, that is what it is trying to symbolize. I mean, you have a system on top of which you can run different applications. And how it works is if you are running an application A in part 1 and running an application B in part B of your server, these applications have a feeling that they are running individually on that system and there is no other system running on top of it. So this is what virtualization is. It creates a virtual environment for your application to run. And one such instance of this virtual environment is called as an instance. So when you talk about virtualization, it is not something that is very complicated. As you can see in the first image, you can see a man surrounded by various virtual images, something that you see in an Iron Man movie. When you talk about virtualization, it is very simple. It can be a simple computer which is shared by different people, and those people are working quite independently on that server. That is what virtualization is. That is what an instance is. In this image, the second image, each one of this individual would be using a different instance. So this is what an instance is when you talk about virtualization. So guys, let us move further and take a look at some other pointers now. We've understood what an instance is, what virtualization is, to some extent at least, guys. So guys, let us move further and try to understand EC2 now. Now, EC2 is an Amazon Web Services compute service. It stands for Elastic Compute Cloud. Now, what do I mean by this? When you say an Elastic Cloud Compute, that means basically it is a service which lets you actually go ahead and carry out computation practice. And when I say elastic, it means that it is fairly resizable and fairly reusable. Once we get into the demo part, probably you'd get a better picture. What do I mean by elasticity? Because it is highly flexible, highly scalable, it is very cost efficient, and it serves a lot of purposes. Now, these are some of the features that I just mentioned, right? Let me throw in some more light on these pointers as well. What do I mean by scalable? Now, when you talk about a cloud platform, one of its best features is it gives you high amount of scalability. That means your applications can scale up and down depending upon the data that you want to use on top of it. So if the traffic increases more, you need more performance. So your application should be able to scale to those needs, right? So that is what cloud computing provides you with. And that is what EC2 also provides you with. When I say an instance, basically what you're doing is you're launching a virtual machine. It is called as instance in terms of AWS. So this virtual machine should be scalable. That means it should scale up and scale down, both in terms of memory, storage, and even in terms of the computation that it is providing. So when you talk about EC2, it is highly scalable. Once we get into the demo part, you would see this. Now, it being scalable and it being cost efficient makes it highly flexible. So that is the third point. Let us try and understand the second point as well. What makes EC2 cost efficient? Now, when you talk about cost optimization, what EC2 does is it lets you scale up and down. I just mentioned that, right? So instead of buying n number of instances or instead of buying n number of services, you can actually go ahead and scale this instance up and down with minimal cost changes. So you're saving money. Plus, apart from that, there are burstable instances. There are various pricing models that EC2 boasts of, using which you can actually save a lot of money. As we move further, we'll be talking about those models as well. So meanwhile, just bear with me. So EC2, well, it is a service which is a computation service, and it takes care of following pointers. I mean, it is easily resizable, it is cost efficient, it is highly scalable, and all these features make it highly flexible as well. So guys, let us move further and take a look at some other pointers as well. So what are the types of instances? Now, when you talk about EC2, it is one of the oldest AWS services. So if you talk about the type of instances that are there in the market, well, there are quite a few types of instances that you can deal with. And these are some of the popular ones. Again, once I move into the demo part, I would maybe talk about other instances, but to keep it simple, basically these instances, they have different families. I mean, you have the T series, you have the M series, the C series. Well, basically these series consist of different kind of instances that serve different purposes. To simplify this process, what AWS has done is it has gone ahead and categorized these instances into following types. The first one is your general purpose instance. Now, it is basically suited for applications that require a balance of performance and cost. That means places where you require quick responses, but it is still cost effective. I mean, say for example, the example shown here, email response systems. Now, you require a quick response and there will be n number of responses or n number of emails that would pop in, but you do not want to pay a lot of money for this kind of service. So in this case, you need cost optimization as well, and you need a quick response as well. So this is where your general purpose instances come into picture. Next on this list, you have your compute instance. Now, what are compute instances? These are for applications that require a lot of processing. Now, when you say computation, they have better computation power. That means if there is a lot of data that need quicker computation power, you can use these kind of instances. What is an example? You have your analyzing streaming data. Now, if you know what streaming data is, it is the data that continuously flows in and flows out. That means you are streaming that data. Say, for example, this session, it is being streamed, right? I mean, the information or whatever is happening here, it is going live. So in order to process this kind of data, you need systems that give you good computation power, which are very active and very good in nature. So when you talk about compute instances, they provide you with these kind of services. And that is why if you are dealing with streaming data, if you wish to analyze this kind of data, you can definitely go for compute instances. So next on this list, we have memory instances. Now, what are these instances for? Now, these are the instances that are required for applications that require more memory, or in better terms, more RAM, right? Random access memory. So these are for applications that require good computation power, again, like the previous one. But when you talk about RAM, it is something that resides in your local system, right? So you need instances which have good memory capacity. And what kind of application it serves? Well, you can think of applications that need multitasking, multiprocessing. Say, for example, I need a single system that does fetching data for me as well, process it for me as well, dashboard it for me as well, and then gives it to the end customer as well. So these kind of applications require memory instances. Moving further, guys, we have the storage instances. As the name suggests, these applications are, or these instances are for applications that require you to store huge amount of data. Say, for example, you have large size applications like your big data applications, where the amount of data is huge in number. So you'd be requiring more storage flexibility. In that case, you can opt for instances that are specifically optimized for storage kind of requirements. And then you have your GPU instances. If you know what GPU is, you would understand what it serves. That means if you are interested in graphical kind of work where you have basically heavy graphics rendering, in that case, you can opt for GPU kind of instances, which basically help you serve purposes like 3D modeling and stuff like that. So guys, this was about the different kind of instances. Now let us try and understand what are the different instance pricing models that are out there. So guys, when you talk about pricing, EC2 or AWS in general, it ensures that you can save a lot of money. But normally what people do is they are under the imagination that if you just go ahead and take in cloud, probably you'd go ahead and save a lot of money. Yes, cloud does support applications in such a way that you would spend very less amount, but it involves a lot of planning, guys. So each time you use a particular service, it is very important you understand how does that particular service work. And if you actually plan in the services in that manner, you'd actually end up saving a lot of money. So guys, let us try and understand how the pricing models work when you talk about EC2 in particular. So guys, these are some of the pricing models that EC2 has to offer to you. You have your on-demand, dedicated, on the spot, and reserved instances. Now, let me try and simplify what these instances are and what do I mean by these. Now, when you say an on-demand instance, as the name suggests, it is an instance that you demand and you get it. Now, these instances are made available to you for a limited time frame. Say, for example, I need a particular instance for an hourly basis. So I would be wanting to use that instance for only that duration. So to use that instance for that particular duration, what I do is I actually go ahead and demand this instance. So AWS would give me that instance, but it would work for an hour only. So my prices for that instance would be fixed on that manner. I mean, the fact that I would be using it for one instance or for an 1 hour basically. So I would be charged only for that 1 hour. And once that hour is complete, that instance, it gets terminated on its own. It's similar to renting a flat for 1 month. Suppose if I move to a new city and I'm looking something temporary. Say for example, I'm looking for a hostel or a paying guest kind of a living system, right? So in that case, what I would do is I would upfront go and tell the owner that I would be staying here for a month. You can charge me for a month only. If it is 1,000 more than normal charge, it is fine. But once the month is over, I would like to leave, right? So that kind of service or that kind of instance demand is called as on-demand instances, basically. Dedicated, now guys, these instances are kind of given to a particular organization so that their security is defined better than other. Say for example, if I need to protect my data, I need my data to be privatized. Now understand this thing, AWS or the other cloud platforms are highly secure. Your data is secure no matter whether they are on dedicated instance or not. But what happens is you normally share your space with someone else, data remains private. But there are companies that deal with highly confidential data, and in that case they want that extra assurance as in, okay, I am using a space which is not shared by anyone. So in that case, you have dedicated instances which basically serve your needs like high security and basically an isolation from the other vendors as well. So that is what dedicated instances do. They are costlier, but yeah, they give you that isolation on spot. Now, guys, when I say an on-spot instance, it is like bidding. Say, for example, I am buying a particular share. So I have a particular budget, right? So I might have a budget of $300. So what I do is I go ahead and buy that share. And I set in a cap as in, okay, to the max, I can bid for $300 for this share. So if the price goes above $300, I'm not taking that share, right? So if there is a particular instance, you can bid for that instance as in, okay, this is the maximum price that I pay for this instance. So if that instance is available at that price, it is given to you. And if after a particular duration, the price of this instance can change, so it is available to you for a limited period of time. So if you are dealing with data that is volatile and you want to work on that data in real time, so you can opt for this instance, because after a while the price of this instance might change and this instance might be terminated and you might not be able to use it for a longer while. But the thing it does is it is available to you at a cheaper price and at a pricing bid that you put on it. So that is why it is more affordable. But again, it is good for volatile data only. Finally, you have the reserved instance. It is like renting an apartment on a lease for a longer period, right? I mean, suppose if I'm getting a flat on an agreemental basis where I sign an agreement for a year, that means I am reserving this flat for one complete year, right? So nobody else can come and say that, okay, you have to vacate this flat, right? So that is one benefit. And the other thing is you have a fixed set of rent. So if you're taking something for a longer duration, there's a chance that you might end up paying lesser money for that as well. Now, what happens here is when you talk about it from the instance perspective, suppose you know that you would be needing this much configuration for this duration. you can rent that particular instance for that duration, and probably you end up saving a lot of money. Now, when you talk about AWS, it gives you flexibility where you can actually go ahead and upscale, downscale your instances to your needs. You can kind of terminate stuff and move to the next stuff. But if you are certain about certain things, as in, okay, I have to use this no matter what happens for a longer duration, in that case, you can opt for reserved kind of instances, and those are more affordable to you. So guys, these were different types of instances based on the pricing that is there. Now we've talked about general clusterization of instances like the general purpose, the GPU, that was based on their functioning, right? Then we learned about their pricing models as well. Now there is one more type that we need to understand, or one more classification that we need to understand. Let us try and take a look at those as well. So we are classifying instances based on their general functioning. Now what do I mean by this? Well, these are the types. Let us take a look at those one by one first. So when I say burstable instance, we've talked about general purpose instances, right? So what happens is there is a category of general purpose instances which start with a base utilization power available to you. That means if you want to utilize your CPU for a certain amount, burstable instances are good here. Let me throw in some more light as in what am I talking about exactly. Suppose I need a CPU utilization of 20% and I know that. So I can go for burstable instances. What they do is they start with a functioning of 20%. But in case if I'm dealing with data that is not constant, that might change with time. Say for example, if my website experiences more traffic, so I might need more performance, right? So in that case, what burstable instances do is they burst out of their current performance to 100% CPU utilization so that you can get more performance. Now, what happens here is you are charged a particular amount for these instances, and you have certain credits for which you can use the burstable performance. Now, if you do not use the burstable performance, those credits can be used later as well. So you are getting optimized performance as well, and you are saving some money as well in case if there is an urgent traffic that you experience. You have something called as EBS optimized. Now, when you talk about EBS optimized, now these are the applications where basically you are processing data at a higher speed. Say, for example, there is some application where the data is flowing in continuously. So I need quick response, right? So EBS backed up or EBS optimized instances, what they do is they give you high input output processing. And that is why these are good instances to opt for these situations. Cluster networking, basically they form clusters of instances. Now a particular cluster, what it does is it serves one kind of purpose. Say for example, in my application, what I want is I have different sections, and in different sections my first section requires to be processing data at a faster rate. The other one I want it to be storage optimized, so I can define different clusters of instances that serve different purposes here. And then I have the dedicated one. We've already talked about dedicated one. It is more related to the data security part. So guys, these were the different types of instances. I know I've talked about a lot of stuff. Once we get into the demo part, probably this would ease up a little more for you people. I believe you people are with me and you are following this session. So guys, now let us move further and take a look at the use case so that we can just move further and take a look at the demo part as well. For this use case, I've considered Edureka itself. Let us try and understand what could be the possible problems that can be solved by using these instances. Now, imagine that if Edureka used AWS as their cloud partner and they used the EC2 service. So what kind of problems could be solved by these instances that we just talked about? Suppose we have the first problem where you have to analyze the data of the customer. So what kind of application would you use? Can you guess that for me? I won't be looking at your answers. Let me just quickly go ahead and give you other examples as well so that we can discuss these one by one. Suppose you also have an auto response email system. Now compare these two and let me know which one would you believe would be served better by these instances that we've just talked about. So when you talk about the performance here, guys, when you talk about analysis of data, for the customer's data, it is never constant, right? At times the data is huge, at times it is less. So in this case, I would need burstable performance. So my general purpose burstable performance instances would serve me better, right? Auto response email system, I need quick response, but I do not want to invest a lot of money. EBS optimized instances with IOPS would help me better. Search engine and browsing, I believe it is fairly clear. I'm talking about browsing and search engine, two different things I want to do. I would be opting for clustered network instances, right? And confidential data, well, I would be opting for the dedicated instances here. So guys, this was a very simple use case. So let us move into the demo part and try and understand EC2 a little more, shall we? So guys, what I've done is I've gone ahead and I've signed into my AWS management console. Please forgive me guys, I have a lot of cold today and that is why my voice is little jiggly and echoing. So I hope you people are not offended by that. Moving further guys, this is the AWS management console. You can sign into AWS free tier account and probably avail these services. You can practice a lot of stuff by signing into your free tier account. How do you do that? Just go ahead and look for AWS free tier and sign in with your credit card or debit card. You won't be charged. You have these services for free for 1 complete year and you can practice most of the services that are there. There is some free tier limit on these services, so check the upper cap as in what those limits are so that you don't get charged. So guys, this is how the console looks like. We are going to go ahead and learn about EC2 here, that is the instance service in AWS. So let's search for EC2 and you would be redirected to this page guys. Now when you talk about EC2, there are a lot of things that you can do. You have Amazon Marketplace where you have AMIs. I will tell you what AMIs are, do not worry. You can just go ahead and launch your instances. You can attach volume to it, you can detach volume storage from these instances. And when I say AMIs, those are Amazon machine images. That means once you create an instance, you can create an image of that instance as well. That means a template of that instance as well. Suppose you have certain applications running on top of that instance, certain specific settings that you've done for those instance, and you do not want to do those settings again and again, you can create images of that instances as well. So let us see what all we can do with these instances. So let us first launch an instance. So guys, once you click on that launch instance button, you would be given n number of options to choose from. You can launch Linux instances, Ubuntu instances, Windows instances, and you can choose the EBS backed up, non-EBS backed up. So there are a lot of choices when you actually go ahead and launch these instances. You can see there's Ubuntu, Red Hat, Microsoft Windows, and there are specific instances specialized in deep learning, some of our server specification. You can see that there are quite a few instances, but ensure that if you are practicing, choose the free tier eligible one. For now, I'm going to go ahead and launch a simple Windows instance. Let's not get into the Ubuntu one because it requires a partition to sign in for that. So let us not do that. So guys, once you click on launch an instance, you can see that you are redirected to this page. Now, if you take a look at the information here, it talks a lot. Now, this instance is general purpose. We've discussed the other families, right? This is one. This one is T2 micro. There are T2, T3 micro and medium and bigger instances as well. The sizes vary, guys. The T2 micro one is free tier eligible. You have T2 nano, you have small, right? So you have medium and other large instances as well. So when you say a micro one, it has one vCPU and 1 GB of memory. Instance storage, it is EBS backed up. And what kind of network performance it gives you? Low to moderate. So I would say configure further. These are some configuration details, what network it is following, what subnet ID it is following. That means it falls under the cloud network, guys. That means your cloud would have a network and under that network lies your instance so that its access policies, security policies can be managed. So let it be basic for now. Let us move further. Storage. Now guys, this is the storage. It is your root storage and 30 GB of space. You can change it if you want, say 100, but let us stick to 30 for now. And guys, you can see these are the types. You have your general purpose, you have your provisioned, magnetic. Now there is one more type of instance, guys, that is HDD kind of an instance. But guys, when you talk about root storage, you cannot attach HDD to it, right? Because root storage is something that is constant. If you wish to have HDD kind of storage, it has to be attached secondary. So if I add new volume here, you can see, and if I search for this, now it gives me an option of cold HDD, right? So that is what, guys, I mean, in order to have this kind of HDD kind of a volume, you need to use secondary storage for it. So let us cancel this for now and just go ahead and say next. You can add in tags, guys, for the simplicity of namesake. Say for example, sample today, and let's just say next. Security group, guys. Security group, what do I mean by this? Well, basically, you have a set of policies, as in who gets to access, what kind of traffic do you want to your instance, what kind of traffic do you want to flow out of your instance. So you can create a security group and you can use customized as well. When you create one, this type is RDP. That means it can allow traffic from a desktop or a remote desktop app, and through which I can log into my system. I can add other rules as well. I can add TCP, HTTP kind of rules, and these are the port ranges. You can specify those. For now, I'm allowing traffic from everywhere through RDP, and I can say review and launch. Improve your security, it says, but this is a basic one, guys. You can add in more rules, as I've already mentioned. So let's not do that. Let's say launch. Generate a key pair. Now, a key pair is something that lets you log into your instance. It is a double security for your instance. You do not want your instance to be left insecure, right? So in that case, you need to generate a key pair. You can use an existing one or you can create a new one as well. So let's just say that I want to create a new key pair. So I say create, and let us say Vishal 34121, and let's just say download. So guys, once you download this instance, what you do is Control X, cut it from here, and I'm gonna go ahead and paste this instance to the desktop, guys. And let's just say paste. Here it is. So the reason I'm doing this is because basically we would be needing this thing, guys. If you lose this key, there is no other way to access your instance. So make sure you keep it safe. And I say launch. So guys, now this process, it takes a minute or two to go ahead and launch your instance. So meanwhile, you'd have to bear with me. So what happens is once you do actually go ahead and launch this instance, it involves a couple of steps, like basically it does some security checks, some status checks. And while these status checks happen, it takes a minute or two. And once the instance is up and ready, we can actually go ahead and take a look at this instance. So meanwhile, guys, what I'm going to do is I'm going to go ahead and take you to the EC2 part. Now there are 3 instances that are running, guys. Now this is somebody else's account, so there are quite a few other instances that are running. You can see that there must be some instance here which basically is initializing. So this is the one that we are going to use. This is the ID. Let's not remember that. We know that this is getting initialized. So guys, these are the other instances. This one is stopped. Let us take a look at this instance as well to understand as in what happens. So guys, these are the options that I have, right? So you can actually go ahead and get the password. You can create a template for your instance. What you can also do is you can start, stop. Now this instance is already stopped, so you do not have these options, that is stop, hibernate, and reboot. You can start this instance and probably you can go ahead and do that. Now when you stop an instance, if you want to actually make snapshots, you want to take snapshots, you want to create Amazon machine images out of it, what you do is you stop that instance so that you prevent any activity from happening on that instance, so that you can take an exact snap of it. So that is why you stop an instance when you wish to do these kind of operations. Once you start it again, you can make it function normally at it was functioning. If you are done using an instance, you can terminate it there and there, guys. So these are the options. Instance setting. Okay, so guys, these are the options. You can add tags to it. You can attach, replace IAM rules, that is access management policies, guys. So you have a user access management policies here. You can attach roles to it as well. You can change the instance type, guys. You can click on it and you can go ahead and do that. You can change it to higher versions as well. Now, why do you need to do this? Suppose I'm experiencing a particular traffic and my instance supports that need. But if I move further and in future I need to cater more traffic, what do I do in that case? In that case, guys, I can actually go ahead and update it to a larger version. Unlike your other applications, your on-premise infrastructure, where you have to actually go ahead and have new servers, new data on top of it. Here, what you do is you just click on this thing and it happens in a couple of seconds. Your instance gets optimized or upscaled to a better level, and that is why it is highly scalable. Guys, what you can also do is you can change termination protection. Now this is for data security. Suppose if I am using a particular instance and in that case I accidentally delete it. my data would be lost, right? So what this thing does is it changes or turns my termination protection on. That means if I have to delete this instance, I have to get into the instance, I have to change the policy and then delete it. I mean, I cannot delete it unknowingly, right? So that is why this service helps. Now, while talking about these things, guys, our instance is up and ready. Let us just launch it. I say connect, and it says download remote desktop file, the RDP path that I talked about, right? And I need to get in my password as well, guys, to log in. How do I do that? I click here, I choose the file. For that, I'm gonna go to the desktop, I'm gonna scroll down. There is a file called as Vishal. I open it and I decrypt it, and there you go, guys, my password is here. I can just copy it. So if this is copied, I can launch this remote desktop file. It would ask me for the password. I would say take this and okay. Do you want to log in unsecurely? Yes. And guys, a Windows instance would be launched. It is just like your Windows operating system, but it is running on my existing system, guys. There you can see personalized settings. It is setting up personalized setting for me, and in half a minute or maybe in 10 seconds, my Windows app would be up and running. So just like my Windows device, I have one more Windows device. So I can do something in this device and something else in my normal Windows device as well, guys. So this is what your instance does. It basically creates an instance, a virtual machine for you to work on. I believe by now you've understood what a virtual machine is. So guys, we are done with this part. So let us just close it for now. Let us see if there is anything else that we need to talk about. Now, if I come back here, I've mentioned that you can take snapshots, right? So these are AMIs. What AMI is, it is an image basically. So I can actually go ahead and launch an AMI for an instance that I already have. I can create an image of it. There is a volume here. So my instances are EBS backed up, right? So there is a block storage attached to it. Can I add another storage to it? Yes, I can remove the previous storage and attach a different storage to it. Say for example, this is the storage that I have with me. If I click on it and I go into actions, I can create a snapshot out of it. Once I create a snapshot out of it, I can attach it to the existing instance. So we just launched an instance, right? So if I want to replace the volume that is already attached to it, what I do is I actually go ahead and detach the volume that is already attached. So I would be stopping my instance first. Once I stop the instance, I can come to the volume. Assume that this volume is attached to some instance. So I need to detach it from here. And the snapshot that I've already created, or if I have created one, I can select that and I can attach that to the existing instance. All I have to do is I have to go ahead and create an image here. Once I create an image, it would ask me what can I do with it. It would ask me to actually go ahead and given the region in which the instance was created. Now my instance that I just used was created in a particular region. I'm working in Ohio region for now. What do I mean by these regions? Well, basically what happens is AWS has different data centers in different regions of the world. So you can choose the region that is convenient to you, that suits your business needs, right? So I can create instances in those particular regions. So if my instance was in particular region, I need to create a snapshot in that region and then attach that snapshot or that volume to my instance. So guys, I believe by now you've understood a lot of things. You've understood what instances are, how to launch those, how to create those, and how to make those work. So as far as this session goes, guys, I wanted to talk about these pointers. One more important point that I would like to mention here is make sure that you terminate your instances so that to avoid any charges if there are any. Now, this being a free tier account, I don't think there would be a lot of charges, but still I would request you to actually go ahead and terminate the instances even if they don't charge you a lot, because that is a good practice, because there are certain services that might charge you a lot more, guys. So I'm gonna terminate my instances, the ones that I have created today. So let's just say terminate. And in a minute or two, guys, these instances would be terminated from end to end.
Elastic Beanstalk, a web application hosting platform offered by Amazon. So without any delay, let me give you a brief overview of what we will be discussing today. Firstly, we will see what Elastic Beanstalk exactly is, and then we'll discuss certain salient features of Elastic Beanstalk. Moving on, we'll try to understand Elastic Beanstalk a little deeper by taking a look at its components and then at its architecture. And finally, we'll try to deploy an application on Elastic Beanstalk for practical understanding of the concept. What is Elastic Beanstalk? If I have to define Elastic Beanstalk in Amazon terminology, then it is a platform as a service where you can deploy your application, which you might have developed with programming languages like Java, .NET, PHP, Node.js, and many others on familiar servers such as Apache, Nginx, Passenger, and Tomcat. The definition which I just mentioned seems to have a lot of technical terms, isn't it? Well, let's try to figure out what Elastic Beanstalk is in simple terms. Alright, let's say you need to build a computer tonight. Well, you have two ways to go at it. First, you can go to a computer warehouse. Computer warehouse is a place where you have different components of computer laid out in front of you. Like you have CPU, motherboards, router, disk drive, modems, and many other components. You can choose whichever component you need and assemble them and form a brand new computer. This is similar to a situation when you try to deploy an application without using Elastic Beanstalk. When you try to develop an application by yourself, you'll have a list of tasks which you need to do. Like you might have to decide on how powerful you want your EC2 instance to be. Then you have to choose a suitable storage and infrastructure stack for your application. You might have to install separate software for monitoring and security purposes as well. Moving on to option B, you can always visit an electronic retail store which has pre-configured computers laid out in front of you. Let's say you're a graphic designer and you want a computer which has a modern graphical user interface installed in it. All you have to do is specify this requirement to a salesperson and walk out with a computer of your choice. Well, I personally prefer this option. This is similar to the situation where you're trying to deploy an application using Elastic Beanstalk. When you use Elastic Beanstalk to develop your application, all you have to do is concentrate on your code. Rest of the tasks like installing EC2 instances, auto-scaling groups, maintaining security and monitoring, etc. is done by Elastic Beanstalk. That is the beauty of Elastic Beanstalk. So let's go back and take a look at definition again and see if we'll understand it this time. Well, Elastic Beanstalk is a platform as a service where developers just have to upload their application. Load balancing, auto-scaling, and application health monitoring are all handled automatically by Elastic Beanstalk. Now let's try to understand how Elastic Beanstalk as a platform as a service is beneficial to an app developer. I'm sure most of you know what platform as a service is, but let's try to refresh what we know. Platform as a service is a cloud computing service which provides you a platform where you can deploy and host your application. Elastic Beanstalk makes the process of app development much more fun and less complex, and I have 5 points to prove that to you. Firstly, it offers quicker deployment. Suppose you're developing an app by yourself, then you'll have to do a lot of tasks by yourself. Like you might have to decide on EC2 instance, choose a suitable storage and infrastructure stock, as well as install auto-scaling groups as well, and then you might have to install separate softwares for monitoring and security purposes. Well, this will take quite a lot of time. But if you have used platform as a service to develop your app, then all you have to do is develop a proper code for your application. Rest will be handled by platform as a service or Elastic Beanstalk in this case, which makes the entire process of app development much more faster. Secondly, Elastic Beanstalk simplifies entire app development process. Like I said, all developers have to do is concentrate on developing a code for their application. Rest, like monitoring servers, storage, network, etc., and managing virtualization, operating system databases is done by Elastic Beanstalk, which simplifies the entire process for a developer. Using platform as a service to deploy application makes entire app development process more cost effective. If you're trying to deploy an app by yourself, then you might have to install separate softwares for monitoring and security purposes, and I'm sure for that you'll have to pay a lot of money, extra money. But if you're using an Elastic Beanstalk to deploy your application, it will provide you all this additional softwares as a package, and you can avoid paying unnecessary operating costs. Also, Elastic Beanstalk offers multi-tenant architecture. By that I mean it makes it easy for the users to share their application on different devices, and that too with high security. When I say high security, Platform as a service will provide you a detailed report regarding your application usage, different people or users who are trying to access your application as well. With this information, you can be sure that your application is not under any cyber threat. And finally, platform as a service provides you an option where you can know if the user who is using your application is getting a better experience out of it or not. With platform as a service, you can collect feedback at different stages of your app development, like during development stage, like testing stage, production stage, design stage. By doing so, you'll have a report regarding how your application is performing at every level, and you can make improvements if needed. So this is how platform as a service like AR and Elastic Beanstalk makes it easy for developer to develop an all-around perfect app. Guys will be able to relate to this point when we try to deploy an application using Elastic Beanstalk in the later part of this session. You will understand how Elastic Beanstalk is beneficial to an app developer. In market, there are quite a lot of application hosting platforms which are providing platform as a service. Let's have a look at a few of them. First, we have something called OpenShift. It is a web hosting platform offered by Red Hat. Then you have Google App Engine, which we all know. Autoscaling. It is a platform as a service where you can deploy your application in just 2 minutes. Apparently, it will provide you a production-ready environment where all you have to do is deploy your application code. Then you have Python Anywhere. It is an online integrated development platform and web hosting service as well, but based on Python language. Then you have Elastic Beanstalk offered by Amazon. Moving on, we have Azure App Services by Microsoft and many others. But today, our main focus will be on Elastic Beanstalk, which is a web hosting platform offered by Amazon. Now that you have basic understanding of Elastic Beanstalk, let's go ahead and take a look at a few of its features. Mostly, all these features are similar to the ones which we discussed earlier. Like Elastic Beanstalk makes an app development process more faster and simpler for developer. Moreover, all developer has to do is concentrate on developing code. Rest of the configuration details and managing and monitoring details will be handled by Elastic Beanstalk. Also, Elastic Beanstalk automatically scales up your AWS resources which have been assigned to your application by Elastic Beanstalk based on your application specific needs. But there is one feature which is specific to Elastic Beanstalk. Suppose you have deployed an application using Elastic Beanstalk, but now you want to make changes to the configurations which have been already assigned to your application by Elastic Beanstalk. Though Beanstalk is a platform as a service, it provides you with an option where you can change the pre-assigned configurations like you do in infrastructure as a service. Well, if you remember, if you're trying to use infrastructure as a service to deploy your application, you will have full control over AWS resources. Similarly, Beanstalk also provides you with full control over your AWS resources, and you can have access to the underlying resources at any time. Let's try to understand Elastic Beanstalk a little deeper. First, we'll be discussing a few components of Elastic Beanstalk, then we'll have a look at its architecture. Let's see what we have here first. We have something called application. Suppose you have decided to do a project. So what you do, you go ahead and create a separate folder on your personal computer which is dedicated to your project. Let's say your project needs Apache server, SQL database, and a platforming software like Eclipse. So you install all the softwares and store them in the folder which is dedicated to your project. So that will be easy for you to access whenever you need all the softwares. Similarly, when you try to deploy an application on Elastic Beanstalk, Beanstalk will create a separate folder which is dedicated to your application. And in AWS terms, this folder is what we call an application. If I have to define folder or application in technical terms, then it is a collection of different components like environments, your application versions, and environment configuration. Let's try to understand each of these components one by one. We have something called application version. Suppose you have written a code, stored it in a file, and deployed this code on Elastic Beanstalk, and your application has been successfully launched. But now you want to make certain changes to the code. So what you do? You go ahead, open the file, make changes to it, save it, and then again deploy it on Elastic Beanstalk. Elastic Beanstalk again successfully launches your application. So you have two versions of your application now. It's just a copy of your application code, but with different changes. And Elastic Beanstalk will provide you with an option where you can upload different versions of your application without even deleting the previous ones. Then we have something called environment. Environment is a place where you actually run your application. When you try to launch an Elastic Beanstalk environment, Beanstalk starts assigning various AWS resources like EC2 instances, autoscaling groups, load balancer, security groups to your application. The point which you have to remember is at a single point of time, environment can run only a single version of your application. But Elastic Beanstalk will provide you with an option where you can create multiple environments for your single application. Suppose I want a different environment for different stages of my app. Like I want an environment for development stage, one for production stage, and one for testing stage. I can go ahead and do that, create a different environment for different stages of my application. And suppose you have same version or different version of your application installed on all these environments, it's possible to run all these application versions at same time. I hope that was clear. Well, you'll understand them practically when we try to deploy an application in the later part of the session. Then we have something called environment tier. When you try to launch an Elastic Beanstalk environment, Elastic Beanstalk asks you to choose among two environment tiers, which are web server environment and then you have worker environment. If you want your application to handle HTTP requests, then you choose web server environment. And if you want your application to handle background tasks, that is where a worker environment comes into picture. I'll show which to choose, either web server or worker environment, and how to work with them when we'll try to deploy an application in the later part. And lastly, we have something called environment health. Based on how your application is running, Beanstalk reports the health of your web server environment, and it uses different colors to do so. First, gray indicates that your environment is currently being updated. Let's say you have installed one version and now you're trying to upload different version, but it's taking a lot of time. So that time it shows gray color. It means your environment is still under updating process. Then you have green, which means that your environment has passed the recent health check. Then you have yellow, which means that your environment has failed one or more checks, and red, failed 3 or more checks. Moving on, let's try to understand the architecture of Elastic Beanstalk. Like I said earlier, when you try to launch an Elastic Beanstalk environment, Beanstalk asks you to choose among two different environment tiers. Firstly, we have web server environment. Web server environment usually handles HTTP requests from clients, and it has different components. Firstly, we have something called environment. You know what environment is? It's a place where we actually run your application, and Beanstalk provides you with an option where you can create multiple environments. And the main point is, at a point of time, this particular environment can run only one version of your application. Moving on, we have something called Elastic Load Balancer. Let's say your application is receiving a lot of requests. So what Elastic Load Balancer does is, it distributes all this request among different EC2 instances so that all the requests are handled and no request is being denied. What actually happens is, when you launch an environment, a URL is created, and this URL in the form of CNAME is made to point Elastic Load Balancer. CNAME is nothing but an alternate name for your URL. So when your application receives request, all these requests are forwarded to Elastic Load Balancer, and this load balancer distributes these requests among EC2 instances of Autoscaling group. Then we have Autoscaling group. Well, if your web server is trying to handle a lot of traffic and it's having a scarcity of EC2 instances, then Autoscaling group automatically installs few EC2 instances. Similarly, if traffic is very low, then it automatically terminates underused EC2 instances. Then we have EC2 instance. So whenever you try to launch an Elastic Beanstalk environment, Beanstalk will assign your application with a suitable EC2 instance. But the software stack, like the operating system, the servers, and different softwares which are supposed to be installed on your instance are decided by a device called container type. For example, let's say my environment has an Apache Tomcat container. So what it does, it installs Amazon Linux operating system, Apache web server, and Tomcat software on my EC2 instance. Similarly, depending on your application requirements, it installs different software stack on your EC2 instances. Then we have a software component called Host Manager, which runs on every EC2 instance that has been assigned to your application. This Host Manager is responsible for various tasks. Firstly, it will provide you a detailed report regarding performance of your application. Then it provides instant level events. It monitors your application log files as well, and it monitors your application server. You can view all these metrics, log files, and create various alarms on CloudWatch monitoring dashboard. Then you have security groups. Security group is like a firewall to your instance. Not anybody can access your instance. It's just for the security purposes. So Elastic Beanstalk has a default security group which allows client to access your application using port 80. You can define more security groups if you need. And then Elastic Beanstalk also provides you with an option where you can define a security group for your database for security purposes. Moving on, we have something called worker environment. First question that comes to our mind is, what is worker? Well, suppose your web server has received a request from client, but on the way, while it's trying to process the request, it has come across tasks which are consuming a lot of resources and taking a lot of time, because of which it's quite possible that your web server might deny other requests. So what it does, it forwards these requests to something called worker. This worker handles all these tasks on behalf of web server. So basically, worker is a process that handles background tasks which are time intensive and resource intensive. And in addition, if you want, you can use worker to send email notifications, to generate metric reports, and clean up databases when needed. Let's try to understand why we need worker with the help of use case. So I have a client. He has made a request to web server, and the web server has accepted the request, and it starts processing the request. But while it's processing the request, it comes across tasks which are taking a lot of time. Meanwhile, this client has requested or sent another request to web server. Since web server is still processing the first request, it denies second request. So what is the result of this is, the performance and the number of requests accepted by your web server will drastically decrease. Alternatively, let's say a client has made a request and your web server has accepted it and it starts processing the request. And again, it comes across tasks which are taking a lot of time. This time what it does, it transfers or it passes all these tasks to worker environment. And this worker environment will handle all these tasks. And request 1 is successfully completed. Meanwhile, if it receives a second request, since it has completed processing request 1, it will accept request 2. I hope the scenario was clear. Well, all we are doing by installing worker environment is we are avoiding spending a lot of time on single request here. Now you know what web server environment is and worker environment is, and why do we need worker environment. But there has to be some way so that this web server environment can pass on this task to worker environment. Let's see how. So you have your web server environment. It has received a request, and while processing, it has encountered tasks which are taking a lot of time. So what it does, it creates an SQS message. SQS is a simple queue service offered by Amazon. And this message is then put into SQS queue. And the different requests are arranged based on priority in the SQS queue. Meanwhile, when you're trying to install worker environment, Elastic Beanstalk installs something called daemon. What this daemon does, it pulls SQS message from SQS queue. And then it sends this task to web application which is running on worker environment. As a result or as a response, this Beanstalk application handles all this tasks and responds with an HTTP response option. So this is how the entire process of handling tasks, transferring and then handling tasks goes on. So you have a client. He has made a request to web server, but the web server is encountered with tasks which are time consuming and resource consuming. So it passes this request to SQS queue. And when you try to install worker environment, there's a daemon which pulls out all these messages or tasks from your SQS queue. And then this daemon sends all these tasks to your application. Application resolves all these tasks and then it responds with a HTTP response option. So this is how your two applications communicate. I think that was a lot of theory. Don't worry, we have arrived at the fun part of session where we'll be trying to deploy an application using Elastic Beanstalk. Here, by creating an application on Elastic Beanstalk, practically, you'll understand different concepts, its architecture, and different environment ties and all this. So let's go ahead. So this is my AWS management console. And if you want to take a look at all the services, then you have all the services here. But we're mainly concerned with Elastic Beanstalk, which I've recently used. So it shows the all recently used resources or services here. So I'm going to choose that Elastic Beanstalk. And this is my Beanstalk console. If you're trying to deploy an application for first time, this is the page where you land. When we scroll down, it says that I can deploy an application in 3 easy steps. All you have to do is select a platform of my choice, then upload an application code if I have one, or use a sample application code and then run it. Let's see if it's as easy as it says here. So go ahead and click on create new application option here. It'll ask you for application name and description. I'm going to name my application as Tomcat app. Then description as my new web app. And then I'm going to click on this create option. See, when I try to create an application, it has created a separate folder which is dedicated to my application. And in that folder, we have different components. As you can see here, I have my environment, then I have application versions, and if I've saved any configuration, it will show all the saved configurations here. Now let's go ahead and create an environment. On the right side, you see an actions option, and you click on that, you get different choices. You can just select create environment here. So again, it's asking you to choose among two different web environment tiers. You have web server environment and worker environment. In web server environment, your application handles HTTP requests from clients. Then you have worker environment, where your application will process background tasks like time intensive and resource consuming tasks. In this demo, I'm going to work only with web server environment. You can go ahead, explore and create worker environment once you understand how to deploy an application on Elastic Beanstalk. So I'm going to click on the select option here. It will take me to a page where I'll have to give a domain name, or in technical terms, a URL to my application. You can give any URL of your choice and see if it's available. So let's say my Tom app, and let's see if it's available. It says the domain name is available. Then description, I'm going to give it the same as before. So my new web app. Then when I scroll down, it asks me for a platform of my choice. There are different options. You have Go, then you have .NET, Java, Ruby, PHP, Node.js, Python, Tomcat. And if you're trying to deploy an application on the platform which is not here, you can configure your own platform and deploy it on Elastic Beanstalk. It provides you an option. Here you can see there's a custom platform here. So I'm going to choose Tomcat platform for my application. And since I'm not any kind of developer, I'm just going to go ahead and use the sample application provided by Amazon. But if you have any application code, if you have created or developed some code, you can store that in a file and upload here. It says you can upload your code. Then you have a zip. You need to convert your file to zip or WAR file and then upload it here. So I'm going to just select sample application and then click on create environment here. So it's going to take a while for Elastic Beanstalk to launch my environment. Though it's not as much time as it would have taken me to develop entire application by myself. While Elastic Beanstalk is trying to launch environment, let's discuss some points. In the earlier part of the session, we discussed some benefits of Elastic Beanstalk. Firstly, I said that it fastens your process of developing an entire app. So it's true, doesn't it? All I did was select the platform of my choice. Rest is done by Elastic Beanstalk itself. So thereby it's saving a lot of time. Similarly, it simplifies the process of app development. Again, all I did was select a platform of my choice, like installing EC2 instances, security groups, autoscaling groups, and assigning IP addresses. Rest is done by Elastic Beanstalk. I even mentioned a point where I said that it will provide, Elastic Beanstalk provides you with an option where you can change the pre-assigned configuration. We'll explore that once the environment is created. Let's go ahead and see what Elastic Beanstalk is doing. It says that it has created a storage for my environment where S3 bucket, so that all my files where I have my application code are stored there. Then it has created a security group as well, an Elastic IP address. Then it says it's launching an EC2 instance. So you see, it's as easy as that. All you have to do is select a platform of your choice. Rest is handled by Elastic Beanstalk. And later on, if you're not satisfied, if you want to change some configuration, you can go ahead and do that. Here, look at this. This is the IP address, which or domain name, which I assigned to my app. It says new instance has been added. And in addition, it's showing each task while it's doing. Isn't that cool? You'll know what your environment is currently doing. So it's still taking a while. So it says it has installed and added instance to my application, and my environment has been successfully launched. It has finished almost all the tasks. It should have taken to environment page now. So this is my environment page, or you can say a dashboard. First, you have environment health here. It says green. It means that my environment has successfully passed the health check. Then it shows the sample version of your application. Since I've used the sample application, it's saying sample application here. Since I've chosen Tomcat as my platform, it has installed suitable infrastructure stack like Amazon Linux, and you have Java 8 programming language. Let's go ahead and explore this page. First, we have something called configurations here. Like I said, though it is a platform as a service, it provides you with an option where you can change configuration. So you will have full control of your resources. First, we have something called instances here. When I click on modify option, you can see that Elastic Beanstalk has assigned micro instance to my application. If I want, I can go ahead and change it to different instance based on my application requirement. Scrolling down, I have CloudWatch monitoring. If I want detailed monitoring, then I can go for 1 minute. If I want basic monitoring and not so detailed monitoring, then I can choose 5 minutes here. Then I have an option of assigning storage to my application as well. It says we have magnetic storage, general purpose, and provisioned IOPS as well. When we scroll down again, we see different security groups. I can just click on that and the security group will be added to my application. So once you've made the changes, you can click on apply option here. Though I haven't made any changes, I'm just going to click here. So now Elastic Beanstalk is trying to update my environment. So it's showing gray color here. If you recollect, I mentioned during the earlier part that gray indicates my environment is being updated. Okay, let's go back to configurations. We did have a look at instances. Then you have something called capacity. Apparently, Elastic Beanstalk is assigned a single instance to my application. If I want, I can go ahead and change to auto-scaling groups. You have an option called load balancer. You can click on that here. And you can set the minimum and maximum number of instances that your auto-scaling group can install as well. Then if you have chosen a load balancer option earlier, then a load balancer would have been enabled here. Then we have monitoring details, which provides you with two options, enhanced monitoring and basic monitoring. And when we scroll down, you can see a streaming to CloudWatch logs option here. So if you want your log files, you can view them on CloudWatch dashboard as well. You can set the retention period according to your choice. And suppose you want your application for some private purpose, then you can generate a private VPC for your application. Similarly, you can add or decrease the amount of storage as well. So by explaining all this, what I want to say is your hands are not tied. You can make changes to configurations if you want. Then we have logs option. If you want to have a look at the last 10 lines of your log files, then you have an option. It says last 100 lines. Then if you want full log files, then you click on that. It will provide you a file in download format. You can just download it. Then we have health option here, where it provides the health of your AWS resources. Basically, it shows EC2 instance here. It says it's been 7 minutes or 6 minutes since my EC2 instance has been installed. Then you have monitoring, where it shows different monitoring details like CPU utilization, network in, network out. If you want, you can go ahead and create an alarm with alarm option here. Suppose you want the notification to be sent to you when the CPU utilization or when the number of EC2 instances are scarce in your auto-scaling group. Then you have events here. Events basically are nothing but it's a list of things which has happened since you started launching an environment. When I go down, it says we have seen earlier on the black screen, the same things are applied here. So it says create environment is starting. Then we saw that EC2 instance has been installed, security groups, elastic IP address. So basically it shows all the events that has happened from the time Elastic Beanstalk has started to launch your environment until the time you terminated the environment. So that's it. Then you have tag files. You can assign different key values as well. Let's go back. This is a sample application which I've tried to use. Now let me try to upload and deploy a new application version here. Okay, I'm going to go to documentation here. I'm interested with Elastic Beanstalk. I'm going to select on that and then developer guide. Click on getting started here. When you scroll down and deploy a new application version here, based on your sample application, you have different versions of your application. Since I've selected a Tomcat as my platform, I have a Tomcat zip file here. I have already downloaded that. So I'm just going to upload the file there. So let's go back and it says upload and deploy. But let's go back to our folder. Then there's an application versions option here. So it gives you deploy and upload options separately here. I'm just going to upload first, then we'll deploy it. Version label, new version, and upload the file. I have it here, zip file. I'm just going to attach the file and then click on upload option. The new version of my application has been uploaded, but it's not been deployed yet. So when I go back here, you can see that I can still see the same version which was there before. Now let's go back and deploy it. Okay, I'm going to select this and then I'm going to click on deploy option and select deploy here. Let's go back to environment and check. So my environment is being updated. So again, the gray color here. Once it's updated, it will show the new version name here. It is uploaded. So as you can see, it's showing the version name of my new version, application version. Like I said earlier, both my application versions are there. I haven't deleted any. You don't have to delete your application versions when you create a new one. Similarly, you can upload multiple versions of your application. Going back, actions option. Then you have load configuration, which will definitely load your configuration. Then you have save. You can save this configuration. Suppose you want to create an application with same configurations. Again, you don't have to start from the beginning, from creating application, environment, all that. You can just save the configuration and use for the other application or other environment of your application. Then you can clone your environment as well, rebuild the entire environment and terminate as well. So here I have saved configuration. If I have saved this configuration, the configuration would have been listed here, and like that configuration I can use when I'm creating a new environment. Okay, just let's see if I've explored all the options. Environment. Well, I forgot to show you one most important thing. When I click on this URL, it takes me to a page where it shows that my application has been successfully installed. Well, that's it. So now you know how to deploy an application using Elastic Beanstalk. Though I've used the sample application here, you can go ahead and upload a code of yours if you have any and try it out. Well, all the options here seems to be user friendly, so you will know what to do. It seems to be easier process. You will understand it better when you try to deploy an application by yourself.
AWS Lambda. So we'll start off by discussing the main services in the AWS Compute domain. After that, we're going to see why AWS Lambda is as a separate service. We're going to discuss what AWS Lambda actually is, and then we'll move on to the part where we'll see how you can use AWS Lambda using the AWS SDKs. Once we're done with that, I'll teach you guys how you can integrate your SDK with the Eclipse IDE. And in the end, we'll be doing a demo. So let me quickly show you guys how we'll be using AWS Lambda in today's demonstration. So guys, this is a website that I created which is hosted on the local host. Now what this website does is it uploads a file onto the S3 file system. Now once the file is uploaded, it sends me a mail regarding that. Now that mail is generated by AWS Lambda. Now let me quickly show you how that mail actually looks like. So let me upload a file over here. So let file be this. I click on open, and before uploading image, I'll show you my inbox. So as of now, I don't have any emails, as you can see, right? So what I'll do is I'll click on upload image. Now it says S3 upload complete. Now what this website does is it will upload my file. It will rename the file according to the system time so that there is no conflict in the name of the object. Right, so whatever file that I've uploaded right now will be uploaded in this bucket. So if I refresh this, you can see that there's a file over here, right? So this file has now been renamed, right? And I also have an email over here which says AWS SES test, right? So if I click on this email, I can see that I have got a mail from this address saying that an object has been uploaded. The name of the object is this, the size of the object is this, the bucket name is this, and it was last modified on 12/31 UTC. All right, so let me quickly compare whether this file name is the same. So it's 748 and it says 748 here as well. Awesome. Now the next cool thing that you can do over here is you can move this file to some other folder. So all you have to do is you will reply to this mail by saying move. You click on send. Now when I send move to this email address that I've configured in my code, what it does is it will basically move this file from this bucket to some other bucket. So let me quickly refresh it and see whether my file has been moved. So as you can see, my bucket is now empty. Now let me go back. So basically my file was there in Edureka demo. Now it will be there in quarantine demo bucket. So as you can see, 748 file has now been moved to the quarantine demo by simply writing a mail over here which says move. So we'll be creating this demo today, AWS Compute domain. So the main services under this domain are EC2, Elastic Beanstalk, and AWS Lambda. Now among these three, the most important service is EC2. So EC2 is basically just like a raw server. It is like your personal computer that you're working on remotely, right? So it can install any kind of operating system of your choice, which is supported by the AWS infrastructure. And then you can use it in any manner as you want. You can configure it to become a web server. You can configure it to become a worker tier environment, anything. Our next service is Elastic Beanstalk, which is an automated version of EC2. So with Elastic Beanstalk, you don't get the access to the operating system, but you still have a control over the configuration of your system. So you can choose what kind of instance you want to launch, right? So Elastic Beanstalk is used to deploy an application. So basically you just upload your code and your application is deployed on the AWS infrastructure, right? So this is what Elastic Beanstalk is all about, AWS Lambda service. So the Lambda service is again an automated version of EC2. wherein you don't get the access to the operating system. With AWS Lambda, you don't even have the choice to choose what kind of configuration you want with your server, right? So with AWS Lambda, you just have to upload your code and it executes. It's that simple. But then why do we have an AWS Lambda service when we have Elastic Beanstalk? So let's understand that. So AWS Lambda, like I told you guys, it is an automated version of EC2, just like Elastic Beanstalk. But then with AWS Lambda, you can only execute background tasks, right? You cannot deploy an application. So AWS Lambda is not used to deploy an application. It is used to execute background tasks. Other than that, like I told you guys, you don't have to choose the configuration in AWS Lambda. You don't have to choose what kind of servers you want. Depending on your workload, the kind of configuration, the server configuration is assigned to you, right? So this is why we use AWS Lambda. But then let's go on to the definition part and see what AWS Lambda actually is. So according to its definition, it's a serverless compute service because you're not choosing the servers, right? You're not choosing what kind of configuration you want in your server. It's a serverless compute service. You just upload your code and your code is executed. It's that simple, right? And also, like it's mentioned in the definition, and I told you guys again and again, it is used to execute background tasks. It is not used to deploy an application. Guys, this is the main difference between Elastic Beanstalk and AWS Lambda. So as an architect, you should know what the use case is and which service will suit it better. So moving on, now we've understood what AWS Lambda actually is and why do we use it, right? So let's move ahead to see how you can use this service. So you can use this service using the software development kits which are provided by AWS. So before moving ahead and understanding how you can use these kits, let's understand what these kits are all about. So the software development kits are basically APIs which are used by developers to connect to the desired service that they want. So it makes the life of the developer easy because he can now concentrate on the logical part of his application rather than wasting time on understanding how he can connect his code to the service which is there on AWS. Right. The other part is that these SDKs are used with IDEs, right? So currently we have only two IDEs which are supported. That is Eclipse and Visual Studio. So today in this session, I'm going to teach you guys how you can connect your SDKs with the Eclipse IDE. So let's do that. So before that, we're going to configure or we're going to code our AWS Lambda function in Java, right? And that is the reason we are using Eclipse. Now, first of all, you have to install Eclipse on your system. Once you do that, this is the Eclipse screen, guys. This is how your Eclipse dashboard will look like. So for installing AWS SDK on your Eclipse, you have to click on Help, and then you'll go to Install New Software. Once you have reached here, you'll enter the website name, that is aws.amazon.com/Eclipse. Once you have entered that, just hit enter and it will list you guys all the SDKs which are available, all the tools which are available. Select all the tools and click on finish, and then it will take some time to download the SDK, but then it will integrate everything into your Eclipse. And then you'll have a button like this over here, right? So with this button, you can actually deploy a new server which is configured according to AWS. So guys, this is how you install SDKs with IDE. Alright guys, so it's time for the demo now. Enough of theory. So what we'll be doing is, our aim is to create an application which will be uploading our files onto the S3 file system. And what our Lambda function here will be doing is, so like I told you guys, Lambda function basically executes your background task, right? So that we don't want to burden the server on which the website is hosted with this task. We want some other server to execute this task. What is this task? We basically want to get an email with all the details of the file which has just been uploaded on the S3 file system. So that email will be sent by the Lambda server. Now once we get that email, if we reply to that email that the file has to be moved, Lambda will pick up that email, it will read that email, and it will perform the necessary operation. So if we specify move, what it will basically do is it will pick that file, move it to some other bucket, and store it over there. So this is the project that we'll be doing right now. Sounds simple, right? But let me show you the architecture. Let me explain you what the architecture tells you. So basically this is our website. So what our website will be doing is, it'll be uploading a file onto the S3 file system. At the same time, it will also be making an entry into the SQS, which is nothing but a simple queue service which queues your data, right? So as soon as your file is uploaded onto S3, S3's bucket is configured in a way to invoke the Lambda function. Now, as soon as the Lambda function is invoked, now Lambda functions are stateless. They don't know anything about what file you have uploaded or what you have done. You have to feed them information. And that is the reason we have updated the entry in SQS of the file which has recently been uploaded, right? So what AWS Lambda will do is, it will read this queue and will get the file name and will actually retrieve all the properties from that file name from S3. Now once it has retrieved all the file names, all the properties of that file, it will actually mail me with using the SES service in AWS the details of that file. Now once I receive the details of that file, I have an option to reply to that email, right? Now how will I reply to that email is like this. So I will open the email client on my computer and I will reply to that email. That email will actually go to that address which is actually pointed to my DNS server, and that DNS server will actually redirect that email to SES. Now SES on receiving that email has been configured to invoke the Lambda function. That Lambda function will be invoked. Again, the file will be read from the SQS. That file will be moved to a new bucket, and in the end that message will be deleted by SQS. Now my SQS has been configured like this, that in case I don't reply to that email within 2 or 3 minutes, that message will automatically be deleted from the queue. And in that case, if you try to move that file, you will not be allowed to do so because that file is no longer available in the queue, hence you cannot move it, right? So this is what our project is going to be all about. Now, I have already showed you how the project works. So let me quickly delete the project and again show you how it can be configured from scratch, right? So give me a moment. All right, so everything is set. Now the first thing that I'll be doing is I'll be configuring my S3 to interact with my Lambda function, right? So what I've not done is I've not deleted the Lambda function because there's no point. You just have to click next and your function will be created. What matters is the code. So as an architect, your job will be to architect this architecture, not the coding. The coding part has to be done by the AWS developer, but it is a good to know knowledge. Okay, so like I said, I have to configure my S3 so that it can interact with AWS Lambda. Now my website's code is like this, that it'll upload the file to a bucket in S3 called Edureka demo, right? So what we'll be doing is we'll be going to the Edureka demo bucket, which is here. I'll click on the Edureka demo bucket. I'll click on properties. I'll click on events, and let me delete this event right now, right? So I will be adding a notification now. Now let me call this notification as AWS-Lambda, right? Now what I want it to do is whenever the event is a put event, that is an upload event, I want it to send a notification to my Lambda function. So I have to select the Lambda function. So my function should be this one, and I'll click on save. Let me check if everything has been filled. Yes, it has. So let's click on save. All right, so I have one active notifications now. Now you might get an error over here saying that you don't have sufficient permissions. So if you get that error, on the right hand side you'll have a button called add permissions. Just click on that button and everything will happen automatically. Basically those permissions are for your Lambda function. Your Lambda function may not have permissions to get notifications from S3, but once you click on that button you'll get the proper notifications automatically, right? So this is how you will configure your S3 bucket. Now let's go back to our slide to see what other things we have to do. So we have configured our S3 to invoke our Lambda function once a file is uploaded to S3. Now our Lambda has already been configured to interact with SES through the code, which is, so through the code it will be calling the SES service and will be giving in a mail. Now the next function or the next thing is to configure SES, or before that, let's configure our SQS, right? So our SQS is basically our simple queue service. So we have to create a queue in SQS in which our website will be uploading our files, right? So let's do that. Let us go back to our dashboard. So this is our dashboard, guys, and we'll go to the SQS service. We'll click on create new queue, FIFO queue, and that queue has to be named as hello-lambda. And since it's a FIFO queue, you have to give the extension as .fifo. All is done. Let's click on quick create queue. Okay, so my queue has now been created. Now I have to configure this queue so that whenever the message comes in, it gets automatically deleted after 2 minutes, right? So let us configure it. So we'll click on configure queue and we'll set this to 2 minutes. All right, all is done. Let's click on save changes. All right, so my queue has also been configured. Let me go back to my slide. All right, so my SQS has been configured now. So let me configure my SES now. Now this might be a little tricky, so hang on with me. We'll go back to the dashboard. We'll go to the SES service. Now first of all, in the SES service, you actually have to add the email addresses. Now how will you add the email addresses? You will actually have to verify a new email address. Now you have to verify the recipient as well. So since I want to receive the email from the SES service, I'll have to type in my email address, which is hemant@edureka.co, and we'll have to verify this email address. Now I'll receive a verification email on hemant@edureka.co. So let me quickly go back, click on inbox. Now I've got a verification request, right? So I'll click on this verification link. Okay, so my email address has now been configured, has now been verified. So it says congratulations. Awesome. So let me go back to my SES. It says pending verification. Let me quickly refresh it. All right, so it says verified now. Now let's go back to our slide. All right, so guys, we have configured the recipient of SES, but what about the sender, right? So we have to configure the sender as well, because and why do we have to configure the sender? And the sender has to be a domain name that you own, right? You have to own that domain name so that you can send emails via that domain name. Now what I mean by that is, you may say that, okay, why not use the recipient address only? Why not use hemant@edureka.co for sending the email? But our application also receives email, if you would have noticed, right? So for receiving the emails through SES, you have to actually own the domain name. Now, since I'm an employee, I don't own edureka.co, right? So what I've done is, I have actually created a domain name. I can get a free domain name from this website, which is my.tk. You can go on this website and create a domain for yourself for free. So basically, you will be getting this domain name free for 3 months. All right. I am almost on the expiry date, so I might have to renew it. Okay, but since this is a demo, let me quickly show you. All right, so I have actually created this domain name, and I can use this domain name to send or receive emails. Now, what I'll have to do, or how do I configure this in my SES is like this. So you will go to your SES, you see this tab which says email receiving, right? So you'll click on rule sets, and you'll have to create a new rule set. Before that, you have to actually verify a domain. You basically have to verify that the domain is actually owned by you. Now how you will do that? You'll click on verify a new domain, and you will give your domain name here, which is edureka.tk. click on verify this domain, and you will get these two records over here. Now where will you enter these two records is actually in the DNS server. So the domain name edureka.tk has to point to a DNS server, right? And in that DNS server, you will be putting in these two records. Now how will you point edureka.tk to a DNS server? So DNS server is basically Route 53, right? So we'll be configuring Route 53 with edureka.tk. Let me show you quickly how you can do that. Let me open my Route 53 service. So this is my Route 53 service. I don't have any hosted zones as of now. So let's click on get started now. Click on create hosted zone. So my domain name is edureka.tk, right? Click on create. All right, so I have created a hosted zone now in my Route 53. Now what I'll have to do is I'll have to connect this domain to my Route 53. Now how will you do that? You will click on manage domain, and you will click on management tools, and you'll click on name servers, right? So these name servers have to be updated with the name servers provided you over here, right? So let me quickly show you. So you will copy this, paste it here. Remember guys, don't include the dot in the end, otherwise it will give you an error. So without the dot, copy the name server, right? So I'll first save to and see if it's working. Click on change name server. All right, says changes saved successfully. All right, so it's saving the servers now. So let me copy the rest too as well. All right, so I've copied my name servers. I'll click on change name servers, and fingers crossed. Okay, so it says changes saved successfully. All right, so my domain name is now pointing to Route 53. Awesome. So now in Route 53, I have to include these records. Now how will I do that? Let me quickly show you. So you'll go to Route 53 and you will click on create record set. Now you don't have to type anything here. Just in the type, click on MX, and in the value, so as you can see there's a value for MX over here. Just copy this value and paste it here, right? This is it guys. Nothing has to be done here. Click on create. Awesome. So I have a MX record now. Now we have to create one more record set, and that name has to be like this, right? So I'll copy this part, paste it here. As you can see now the name is underscore Amazon ACS dot edureka dot tk, and as you can see the name over here is the same, right? So this name has to be the same, and the type of value is txt. We'll select txt from here, and then you have to enter the value. So the value is this. Enter this value over here and click on create. Awesome. So my Route 53 is now configured to actually receive the emails from the edureka.tk domain. Cool. So we'll go back to our SES now, close it. It says pending verification, refresh it. Alright, so as you can see, my domain name is now verified. Alright, so let's just go to the rule sets now. So email receiving we have to configure. So I'll click on view active rule set. There is no rule set, so I'll create a rule. Now I have to specify a recipient, so let me specify hello@edureka.tk. Right, I'll click on add recipient. So my verification status is verified because my domain name is verified now. We'll click on next step. Now what action do you want it to do? Right, so if you receive email on this email ID, what do you want to do? So what we want to do is we want to invoke a Lambda function. Now what Lambda function do you want to invoke? I want to invoke my function 2, and we'll click on next step. So everything seems fine. We'll click on next step again. So it is asking me the role name. Let me give the role name as lambda-demo. Click on next step and click on create rule. Okay, so my rule set has now been enabled. Awesome. So I have configured my SES as well. So let me go back to my slide. All right, so I've configured my SES. I've configured my Route 53. I've configured my AWS Lambda. I have configured my SQS. I've configured my S3, and my website is also configured. Right, so we created a SQS queue, so we may have to change the URL in our code. So let's quickly do that. We'll go back here, go to the dashboard, click on SQS. All right, so this is our queue and this is our URL. So basically I have named the queue same, so if you do that, sometimes the URL don't change. So let me see if I have to upload the code or not. So I'll go to my Lambda function handler, go to the part where my queue is saved. Alright, let me anyways paste the queue over here. I think it is the same. Yes, it is the same. Anyways, let us save it. This is my function 1, so let me upload the code now. So it's my function and click on finish. Alright, so it is uploading the function right now. So meanwhile, let me go to my function 2 and configure in the queue address, which is this. Paste it here, Control S, save it. And once this process is complete, I will upload this code as well. So while this is uploading, let me change the address in my index file as well. This is my website's index file. So I'll go to the queue URL, which is this. I will change it, save it, and close it. All right, so my website's address has also been done. All right, so my code is uploaded for this function. Let me upload the code for function 2 as well, because we have made change. Upload function to AWS. So it is my function 2, that is my function 2 in Lambda. Click on next and click on finish. Alright, so my code is being uploaded. Let's wait a while so that my code gets uploaded and then we can proceed with our demonstration. Alright, so my code has now been uploaded to both my Lambda functions. Now what I'll do is I will go to my localhost website, click on refresh, and I will upload a file. So let me go back and see what is there in my bucket right now so that it becomes easier for us to verify that a file has been uploaded. So as of now, my bucket is empty, right? There's nothing in my Edureka demo bucket. And my other bucket is quarantine demo. This is the place where my other file will go, right? So let me empty this as well, so that we are clear that some object has been added. All right, so this bucket has also been cleared. So we'll go to our local host, we'll choose a file. So let's upload some image. So let it be this image, right? I'll click on open and click on upload image. All right, so it says S3 upload complete. All right, so let me check if a file has been added in my Edureka demo bucket. I'll click on refresh. Awesome, so one file has been added and it's called 14925460997. Let me check in my email. So let me check if I got an email. So yes, I've got an email. Let me click on it. All right, so this is the name of the file that I got, which is the same, right? So let me see if there is something in my quarantine demo bucket. So there's nothing there. I'll come back. Now I'll reply to this email as move. So this basically means move my file to some other bucket, and I'm replying it to hello@edureka.tk, right? So now we'll hit on send. So my message has been sent to route 53, which will be sent to SES, which will invoke the Lambda function, which will move my file to the other bucket. So let us check if that is done. So first, let us check if our Edureka demo bucket has been emptied. So we'll click on refresh. All right, so my Edureka bucket has now been emptied. Let's go back and check if anything has been added in my quarantine demo bucket. All right, guys, so my file has successfully moved to this bucket. Let us verify the name. So this is 149.254.6097. Let us check that in the email. So the email that we replied to had the object name as 149.254.6097. So this is the same file, guys. All right, guys, so we have completed our demonstration successfully.
Amazon Lightsail. Let's go ahead and explore Amazon Lightsail in detail. So before we dig in, let's take a look at the scenario. Let's say you have decided to get a dream home for yourself. Based on the type of person you are, there are two possibilities. Suppose you're a meticulous planner and you love planning things. The first thing you do when you decide to buy a home for yourself is you do research. You research on the type of homes that are available in the market. You research until you find the one you like. Once you're done with your thorough research, you start planning. You start deciding on interior designing of your house. You start deciding about the type of garden you want, or the type of kitchen you want, or how you want your house to look at. So once you're done with your research and planning, you hire people to execute this plan. So in simple terms, on your journey to build a dream house, you make a lot of big decisions. Alternatively, let's say you're someone who finds this do-it-yourself approach a waste of time. You're just interested in the final results without having to make any decisions along the way. So you go ahead and buy a house of your choice which is already furnished. As you know, this doesn't involve any kind of planning or research. The concept of Lightsail is very similar to this scenario. Let's say you want to build an application and you've chosen Amazon EC2 as your platform. As you already know, when you're trying to launch an Amazon EC2 instance, you have the freedom to decide the underlying infrastructure. You handpick the individual AWS components like storage, server, security groups, IP address, VPCs, and many other components. Once you've chosen all the components you need, you put them together and host your application. Well, that is one way. But if you simply need a system that's pre-configured and pre-assembled, as in you just want to run your application on a built-in platform, the best option would be virtual private server. So with virtual private server, you have a handful of options. You have fixed storage, you have fixed network configurations, you have fixed infrastructure stack. Since all these components are already provided by virtual private server, you can concentrate on developing code for your application. But the problem with virtual private server is, if later on, if you want to expand your application, you find that in virtual private server, the options for scaling are very limited. This is where Amazon Lightsail comes into picture. Amazon Lightsail is very similar to virtual private server, but unlike virtual private server, it provides you with an option to autoscale. So you get simplicity of VPS, backed up by reliability and security of AWS. As your need grows, you will have option to autoscale and connect other AWS resources like database and SNS services if needed. So with Amazon Lightsail, you can run a simple application. You don't have to bother about the underlying infrastructure, and you have an option to autoscale resources according to your application need. If I have to define Amazon Lightsail in a single sentence, Amazon Lightsail is a virtual service that's cost-effective, fast, and reliable with an easy-to-use interface. So now you know what Amazon Lightsail is. But the question here is, when we have so many other compute services, why use Lightsail? Lightsail is best choice for developer if he wants to spend his time in application rather than deciding the underlying infrastructure. Also, if you're someone who are trying to understand the cloud concepts such as virtual machine, storage, network, and all these details for the first time, then Lightsail is the best option. So Amazon Lightsail provides you with everything you need to jumpstart your application. Well, to begin with, it provides a virtual private server that you can launch within just few clicks. And you don't have to worry about underlying infrastructure like network and storage. Well, you have two options. You can create an instance image with just base operating system, or you can create an instance image with application or development stack along with base operating system. Well, if you're not understanding what I'm saying here, you'll understand it perfectly when we deal with it in the demo part of the session, so don't worry. Moving on, suppose you want your application to integrate with other external application, or you want to extend your application, then Amazon Lightsail provides you with a simple and flexible API, that is Application Programming Interface. It also provides you with highly available storage. So with Amazon Lightsail, we have high performance storage in form of SSD blocks. And the storage is highly available, it's easy to manage, it's scalable and very secure. Amazon Lightsail also provides you with speed and secure networking connections. When you try to launch an Amazon Lightsail instance, all the network configurations are taken care by Amazon Lightsail in the background. But later on, if you want to make any changes to this network configurations, you can go ahead and do that. Amazon Lightsail provides you with an option where you can change the security groups, assign rules, and you can even deal with DNS as well. And suppose your application needs additional features like managed database, content delivery network, or any other features, you can connect to other additional AWS services using Amazon Lightsail VPC peering option. I'll show that to you as well in the demo part of the session. And finally, we have load balancing. Let's say your application is handling a lot of traffic, and because of which the performance of your application is going down tremendously. So you can enable load balancing, because of which the load that your application receives is equally distributed among different instances, and therefore the performance of your application grows. So to summarize all that we've learned till now, Amazon Lightsail is very fast and easy to use. It's fast because, like I said earlier, with just few clicks, you can launch a VPS. And it's easy because the Amazon Lightsail console is made in such a way that even the beginner would easily understand and will be able to use it. And the second thing, Amazon Lightsail grows with you. As in, later on, if your application needs additional resources, then Amazon Lightsail provides you with an option to autoscale. And the best part about Amazon Lightsail is its pricing plans. I'll try to explain you the different pricing plans in the demo part of the session. So for now, let's skip that part. And finally, Amazon Lightsail provides you with 1 month free usage. Suppose you are here just to explore what Amazon Lightsail actually is and what you can do using Amazon Lightsail, or say you just want to host a simple application or website using Amazon Lightsail, then you can make use of this free month usage provided by Lightsail. And if you like it, you can continue using it, as the pricing plans provided by Lightsail are really the best. So guys, that was all about the theory part of the session. Now let's try to deploy a WordPress website using Amazon Lightsail. But I'll have to let you know something. The purpose of this demo is not just to deploy a WordPress website, but to understand different features we discussed earlier of Amazon Lightsail. So let's go ahead and do that. So guys, this is my AWS management console. And as you can see, there are quite a lot of services. We have compute services, storage services, media services, analytics services, and mobile services, and many others. And within compute services, we have many as well. We have EC2, we have Lightsail, Container Service, Lambda, and Elastic Beanstalk. And if I'm just a beginner in this AWS cloud technology, the number of services when I see here might become a little too much for me. So I'm going to choose this Amazon Lightsail here. So it takes me to Amazon Lightsail console page. As you can see, this console or the Amazon Lightsail console is very simple compared to my AWS management console. I have very few options here. I have instances where I can create different type of instances. Then I have networking, storage, and then snapshots. So just 4 options. So let's start with a demo. I have an option which says create instance. I want to click on that. And the first thing is I'll have to choose the region and availability zone. So let's say I'm going to choose Mumbai here. And based on the region I chose, the availability zone varies. We'll have zone A and zone B in Mumbai region. I'm going to pick zone A. And then comes the OS part. As you can see, we have different blueprints of applications and operating system. As for the operating system, we have 2, Linux and Microsoft. And like I said earlier, you can create an instance image with just base operating system, or you can create an instance image with application or development stack along with base operating system. So let's say I've chosen Linux. As for the OS part, I have different Linux distributions here. I have Amazon Linux, I have Ubuntu, Debian, and many others. And as for the application part, I have WordPress, LambStack, Nginx, GitLab, and many others. Then going to Microsoft Windows, as for the OS part, we have Windows Server 2016 and 2011. And application part, I have SQL Server with Windows as a base operating system. For the purpose of this demo, I'm going to choose WordPress app with Linux as base OS. And suppose you want to know all the information there is regarding all these applications and operating systems, you have a link which says AWS Marketplace. You can go there and verify the information. And when I scroll down, suppose you want an action to take place when you launch your instance for the first time, you can add the script here. And just like in Amazon EC2, when we launch an instance, we create or we generate a key pair. Similarly, we have an option where we can create a new pair or upload one if you have one already. And but the best thing with Amazon Lightsail is it provides a default key. So I'm going to use default key for this demo. Moving on, we have pricing plans here. The best thing about Amazon Lightsail, if you search in the documentation part of Amazon Lightsail, it says that they have no nonsense planning, and it's according to their word. Well, as for the Mumbai region, the basic plan starts with $3.5. Every Lightsail plan has a fixed amount of memory, as in RAM, and compute resources like virtual CPUs, and then the storage disk in the form of SSD blocks, and then the data transfer rate. Well, if you look at the first plan, it says $3.5. As for the memory, it's 512 MB. And for the compute resources, one virtual CPU. And then we have 20 GB SSD storage, and the transfer rate is about 512 GB. Then when you go for the next plan, the transfer rate is 1 TB, 1.5 TB, 2 TB, and it varies. So this data transfer rate is basically refers to the amount of data you transfer from your Lightsail instance to other Lightsail instance or other AWS instances. So if you try to transfer data, the amount of data is within this 512 GB, then the data transfer rate is free. But the moment it goes above this 512 GB, you will have to pay the cost. But one thing is, in data transfer, you have data in and data out, as in the data that you receive from other AWS resources or other Lightsail instances, it's always free. But for the data out part, if you're trying to transfer data from your device to other devices, then if it's within 512 GB, then it's free. Otherwise, you'll have to pay, as I said earlier, as in you have to incur other extra cost. And then moving on, it asks for a name when you can give the name of your choice. And you have the number of instances you want of same type. Well, you can choose 2, 3 according to your choice. But for this demo, I'm just choosing one. And the single option, I'm going to click on this create. Like I said earlier, with just one click, I launched a virtual private server here. So like I said earlier, the purpose of this demo is to explore different features of Amazon Lightsail. And I'm going to do just that. Okay, so the WordPress is being deployed in the background. Tasks like creating virtual private servers, security groups, assigning rules to the security groups, and setting up storage, etc. will be done by the Lightsail in the background. So let's give it a few seconds to finish and move on to our next step. So it's done. And I'm going to click on this. And the first thing you see is you have two options. You can stop the instance or reboot it. And then you have private IP address and public IP. The point is this public IP keeps changing every time I launch this instance. So the one solution for that is to assign a static IP. And we'll see how to do that in the later part. Let's go ahead and explore a few other details. So I have an option which says connect using SSH. This Amazon Lightsail provides you with a default terminal using which you can launch your instance. And suppose if you want to launch this instance using your own terminal, then you have the IP address and the username here, and you need a key if you remember. So when I click on this page, it takes me to a page where I can find the key to launch an instance on my terminal. All I have to do is just download this. Okay, then going back, I'm going to go to my console, Amazon Lightsail console, and in the networking part, I have a create static IP option. So I'm going to choose an instance for which I want to attach the static IP. And as you can see, this IP has a name and click on create. When I go back to my instance, you can see that in place of public IP, we have static IP. So suppose you relaunch your instance later, this IP address won't change. So let's go ahead and launch this instance. Suppose you want to view this WordPress blog on your browser. All you have to do is copy this IP address. And the same thing. I'm just going to copy this and paste it in the browser. So as you can see, it's as easy as that. With just one click, I've deployed a WordPress website. And when I scroll down, I have a login option here, but I need username and password to log in. As you can see in the right corner, I have a Bitnami image. When I click on that, it takes me to a page where I can get my username. But as for the password, we have to launch an instance. So I have this option which says connect using SSH. I'm going to click on that. So the default terminal provided by AWS opens. Well, I've successfully launched. I have a file called Bitnami application password file where the password is stored. Okay, so as you can see, this is a password. I'll have to copy that. So in the right corner, you see an option. I click on that. I'm going to select this data. Well, this is kind of text editor. I'm going to select this password from here, copy. And as for the username, we already know which is user. So let's go ahead and log in. User. And as for the password, we just copied it. I'm going to paste it here and then click on login. So I've successfully logged into my WordPress page. And now if I want to post some new blogs or anything, I can go ahead and do that. Suppose let's do that. So I have add new. So I have this poem. I'm going to attach that here. And for the media part, it's there in the downloads. It should be in the first div. So it's here. Open into the post and a little bit editing. Let's say full size. Update. And publish. So let's go and take a look at the preview. So as you can see, before it was in there, I just posted a new blog. So that's it. It's very easy. And let's go back and explore other features. Okay, now that we've used default terminal to launch an instance, let's go ahead and use other terminal. Well, I have this Git terminal on my PC. Well, here. So cd, I need to come out from the desktop part. Then using SSH option, I need to connect to my instance. Okay. Before that, I need to download the key. Okay, I have this link here. And since I'm using default key, I have a download option here. It's downloaded. Let me go back to downloads and check if it's there. So this is it. This is the key. I'm going to rename it so that I can access very easily. Let's say SSH key. That's it. Let's see if it's stored as a .pem file. Properties. As you can see, it's stored as a PM file. Okay, then let's go back to our terminal. Here, SSH key. So .pem. Was the name right? Let me check back. SSH key. shk.pm. And as for the IP address, and here you can see a username. Since WordPress is Bitnami application, I have to use Bitnami as in my username. Suppose if you're launching some AWS instance, you have EC2 user as your username. Here I have to copy the IP address of my instance. So let's go back. This is the IP. I'm just going to copy it and paste it over there. It should work. Yes. So as you can see, I've successfully connected to my Amazon Lightsail instance from my own terminal. Okay, we have done that. Going back, we have for the storage part. And suppose you just started with a basic application, but later on you have expanded your application and you need additional storage. So you have an option where you can create or add new disks. Well, this is the disk or the storage which has been assigned to my application when I chose the plan. Then I have metrics part. Just like you have Amazon CloudWatch in the AWS management console, you have a default monitoring tool here. It shows all the CPU utilization, network details, and you have status check as well. Moving on, as for the network part, as you can see, I've assigned a static IP, so it's been showing here. And then I have private IP address. If you remember, all the security groups are by default launched by Amazon Lightsail when I launch an instance. So I have all the security groups. And if I want to customize this, I can go ahead and add new security groups. If I want to assign new rules to the security groups, I have an option here as well. And then suppose if my application is handling a lot of requests and I want to distribute the traffic to make my application performance great, then I have an option. I can just enable this load balancing. And for the snapshots, okay, so here are the concept. Like the pricing concept is Amazon Lightsail and Amazon EC2 is mostly similar, as in you'll be cost according to the hour usage. But the problem in Amazon Lightsail is if your instance is not running, as in it's just stopped, even then you'll have to pay. So you have to stop your instance or create a snapshot of your instance and delete the instance. Only then you won't be cost and you don't have to pay the extra cost. But if you remember in Amazon EC2, you'll have to pay only if your instance is running. If your instance is stopped, then you don't have to pay. So that is where the concept of snapshot comes into picture. You can take a snapshot of your instance and you can delete your instance. In the later on, if you want the same instance with same features, then you can use the snapshots to create an instance. We'll see that later. Then as for the history part, it's just a list of events that has been occurring since the time you've launched your instance. As for this instance, I've created it and then attached the static IP. That's what it shows here. Then delete with just one click, you can delete an instance. So let's go back to management console. We have explored everything there is regarding our instance. Then going for the networking part, you have an option to create static IP, which we already did. Then you have DNS zone. Suppose you just don't want to refer to your instance using the IP address, you want to give it a proper name, then you can use this DNS zone. Then we already have touched the load balancer concept. Then I have storage thing. Similarly, if my application needs additional resources, I can go ahead and create a disk and attach it to my instance. And we have discussed the snapshot as well. So that's about in the Amazon Lightsail console. Well, for the account part, let's go and explore. I have profile, which is similar to my AWS profile. Then I have SSH keys, which we already discussed earlier. As for this demo, I've used default key, but if you want to go and create your own key, you can do that, or you can add an already existing key as well. And then for the advanced details, well, suppose you want to extend your application or you want to integrate your application with other applications, then you have API. It's very simple and user-friendly. And suppose you want to interact with other AWS services. Earlier in the theory part, I mentioned that you have something called VPC peering. All you have to do is click on this enable VPC peering, like whichever the region you want. All the underlying details will be thoroughly handled by Amazon Lightsail. So that's it. As I've already said, the purpose of this demo was just not to launch a WordPress website. I've used it as a means to explore all the features. I hope you're clear with Amazon Lightsail console and all the features and all that. So go ahead and explore it. Try to create new instances, new SSH keys, attach storage as well.
So what is Docker? Let us start with the basic definition. Now, Docker is a tool which is designed to make it easier to create, deploy, and run applications using containers. Now, Docker containers are lightweight alternatives to virtual machines, and it uses the host operating system. You don't have to pre-allocate any RAM in containers. Now, guys, do not worry. I just did not go ahead and read the definition. I wanted you to kind of probably listen to it and realize that how many technical terms are there. I mean, I just mentioned terms like Docker. I mentioned terms like virtual machines, host OSS, and pre-allocation for RAMs and stuff like that, right? So for people who are completely new, they might be wondering as in, okay, what are these terms and what am I talking about? Well, let me simplify these things for you. Before we understand Docker, let's take a look at what virtual machines are and what containers are. Now, guys, when you talk about virtual machines, basically we are talking about software infrastructures where we run a number of applications on top of particular infrastructure. So if you talk about having a hard-coded or a proper infrastructure that is on-premise, normally what happens is the fact that you're running so many applications, at times you are software dependent or maybe an operating system dependent, where you need particular configurations for that particular software or application to run. So you cannot run those applications anywhere else. So that becomes a difficult task. To give you a very simple example, consider your laptop, right? I mean, if you have an application that works on Windows and does not work on Linux, so in that case, you would be bounded or forced to run that application on a particular operating system, right? Or you'd be forced to install a particular operating system on your basically your laptop or your system, whatever it is. So in case when you're talking about, or if you're looking at it from a business perspective, you might be required to use multiple operating systems. You might be required to use multiple applications that are there. And again, getting back to the laptop example, what I can also do here is I can probably have multiple operating systems in my laptop, right? I can have a Unix or a Linux operating system and also a Windows operating system. And probably I can run different applications if they require to run on different operating systems, right? So that serves that purpose as well. When you talk about virtualization, what it basically does is it lets you create a virtual environment on a single baseline hardware or a single baseline infrastructure on which you can actually go ahead and run different applications, different operating systems. And when you're switching between these different applications or operating systems, you would feel that you're actually moving from one machine to the other, but that is not happening. There is one single machine, and on top of that you have different operating systems. So you're basically creating a virtual environment. What purpose does it serve? It actually simplifies your needs of running different environments on a single machine. So that is what virtualization is. Now, what are containers? Now, containers are simplified forms of virtual machines. Now, it won't be true in all aspects. I mean, if you just go out there and say that containers are simplified versions of virtualizations, there would be quite a few people who would disagree. The reason for that is the applications of virtual machines in certain cases are different from what containers are, and in certain cases, virtual machines might be more useful to you. Let's try to understand the difference between the two first so that we can probably relate to the stuff that I've just mentioned. Now, virtualization, basically what it does is it has a middle layer called as a hypervisor, and it runs on top of that hypervisor. So you'd be having your server, your guest or your host OS. On top of it, that you'd have your hypervisor, and on top of that, you'd be running everything. I mean, on that middle layer or middleware, you'd be running your guest OS, and on top of that, you'd be running all your applications. So still there is that middleware that is there in the between. So you would be dependent on that particular thing when you talk about virtual machines. What containers do is that they actually take away that dependency as well. What containers do is they actually go ahead and package your applications and all the other dependencies inside a container. And if you have a Docker agent running somewhere, or an agent basically that lets you run this container. Now Docker is a containerization agent. We'll get back to that later. But if you have a particular agent installed on your PC or there on your infrastructure, you can actually run any kind of container that is there with you, and you do not have to worry about any dependencies. So it takes your virtualization approach to a next level. But there are certain applications which require more secure environments and more structured or structurized applications where they would basically prefer using your virtual machines over your containerizations or containers basically. So the applications are completely different, but for quite a few applications, your containers serve much better and faster means. Why is that? Because the fact that you have this piece of container which runs on top of any container agent. So all you have to do is get all those things inside that container and make them run on any possible machine or your infrastructure basically. So that is what Docker is. I mean, it is a container agent that lets you create these containers and run these containers in which you can package all your applications and their dependencies and thus save a lot of time and thus create these virtual environments as well. So by now, I believe you've understood what Docker is, right? Now, why did I talk about AWS and why am I talking about Docker? Yes, we are here to discuss what Docker is, but the reason I discussed AWS was we would be talking about ECS, which is Elastic Container Service provided by AWS, which makes basically running your Docker images a lot more easier. So let us move further and talk about ECS a little more. As I always do, let us start with the definition first. Now, to keep the definition simple, now this is what the definition says. It is a highly scalable, fast container management service, which makes it easy to run, stop, and manage Docker containers on a cluster, which actually lets you host your cluster on a serverless infrastructure. So let us talk about these terms as I always do. Let us discuss them, decode them, and break them into smaller chunks and try to understand them a little more. It is a highly scalable, fast container management service. So basically, it lets you manage your containers. As I've already mentioned, when you talk about Docker, you're talking about containers. So this service basically lets you manage those containers, those Docker images, and lets you deal with them a lot better. And the fact that it is highly scalable and it is fast, it meets in the changing needs of the applications that are there. I mean, if you wish to scale up, scale down, have more RAM, have more space, and stuff like that, it lets you deal with those because AWS is highly adept in providing you with the needs or actually providing you with the requirements that you actually have. So, yep, it is highly scalable, it is very fast, and it lets you manage your containers. What it does is it makes it easier for you to run, manage, and stop your containers whenever you wish to. And the fact that these containers, they run on top of a cluster. So you have a cluster, which is nothing but basically think of it as, again, a bigger container that lets you manage your containers better. What a cluster is, what do these things are, or what do these things mean? I would be talking about those in detail as we get into the demo part. But meanwhile, that is what the definition says. And the important part here is, and the important part in this definition is, it basically lets you host your clusters on top of serverless infrastructures. What is a serverless infrastructure? Basically, it is a place where you never get to know. That would be a wrong term to use, never get to know. I would say you are never required to worry about your servers. You're upscaling, downscaling, maintaining and monitoring your servers. Somebody else does it for you. So that is not your concern. And that is why we call these infrastructures as serverless infrastructures. Your AWS EC2 is a very common example for that. So guys, let us move further and try to understand some of the other terms, or let us just actually go ahead and move into the demo part. So probably we can understand these terminologies and the topics that I've been talking about in a better way. So guys, what I've done is I've actually gone ahead and I've switched into my AWS console, and this is how it looks like. This is what I tell in all my sessions. For people who are completely new to AWS, they can actually go ahead and create a free tier account, and they can have access to this portal for free for 1 complete year, where most of the services are free under certain limits. I mean, if you basically cross those limits, you would be charged, but if you stay in those limits, you would not be charged, guys. So if you're interested in practicing AWS, definitely those limits are enough, and I would suggest that you create a free tier account. How do you do that? Go to AWS free tier or search for AWS free tier on your browser, and then probably try to sign up or create an account. They would ask you to enter in details like why do you want to use this account, who are you, and some other details. And then they would ask you to give in your credit card or debit card details. Yes, these are mandatory, guys, because if you exceed those limits, you would be charged, but that happens very rarely that you would exceed those limits. Plus, you can have certain alarms set that tell you that, okay, you're crossing a particular limit. If you wish to know more about that, you can take a look at our video called as AWS CloudWatch, which talks about these things in a lot more detail. So once you do have an account, you can join me back here and we can get started with this session. And the fact that I was suggesting you a video, one thing that also reminded me that I should suggest you is the fact that you can actually go ahead and take a look at one more video that we have, or 2 more videos that we have. One is, I think it is called as Virtualization or Virtual Machines tutorial by Edureka, which basically talks about virtualization in general. And you can also take a look at one more video called as Docker on AWS, which talks about quite a few terms, that is containers, virtualizations, in a better depth or in more depth, so that you can probably understand those concepts in little more detail in case if you've not understood those in this session. Having said that, guys, now let us just go ahead and try to understand how you can actually go ahead and run your Docker images on top of ECS, which is Elastic Container Service. So how do we go there? We searched for it. We type ECS and it would take you to your ECS service. Again, guys, if you are completely new, this is how the console or your first page would look like. So if you've created more applications here, those would be visible. So the fact that this is a fresh account, let's just say get started. So guys, this is what we are going to do here. We are going to go ahead and create a container definition, task definition, service, and cluster. And then we are going to run our container on top of our cluster. When I say a container, you can think of it as your Docker image basically. So guys, what am I doing here? I'm basically actually going to go ahead and choose an image for my container. There are quite a few options. You can use your Nginx. You can actually use a Tomcat web server. You can actually go ahead and configure as well. If you click on this configure, you would be entering quite a few details manually. If you wish to skip that, you can actually go ahead and use this image in general. Now, let's just go ahead and do that. It is a sample app. It says HTTP 2.4. Memory is half a GB, and that is the CPU details. So I select this and I scroll down. What is a task definition? It is a blueprint for your application. It describes one or more containers through attributes. Some of the attributes are configured at the task level, but majority of them actually get configured as per the container. So these are some of the parameters that are at concern. That is your definition name, network mode, your execution role, compatibilities, memory, and the CPU. So I say next. The number of desired tasks, I would say 1. And security group, well, let that be created automatically. And load balancer, guys, if I'm experiencing more traffic, I would want to balance it better. So your load balancer does it for you. Listener port is 80 and HTTP. Now these are networking details. I hope you are aware about it. And then I say next. So guys, by now we have our container definition and task definition. We now actually need to go ahead and configure our cluster as well. So let us just go ahead and give it a name, say sample for today. Forgive me guys, I'm bad at naming. Do I need to review the details? I'm just gonna go ahead and say create. So now guys, it would prepare somewhere around 10 services or 10 operations rather. So these are the operations that are happening here. and it might take a little longer than normal. So let us just hope that it happens quicker. If not, I'm gonna pause this video meanwhile, and once it gets up and running, I would get back to you. So guys, as you can see, we've actually gone ahead and run all the services that I mentioned, 10 out of 10. And this is what it has done. Additional service integrations, log group, you have CloudFormation stack, then you have basically your VPC, subnet 1, subnet 2 security groups, load balancer. So guys, a security group is created that takes care of security. Your load balancer ensures that all the traffic gets distributed evenly in case if there is a lot of traffic. You have your VPC that helps you connect all the instances that are there inside a particular network. You have your cluster, you have a task definition, you have your service, and quite a few other things. So guys, let us just go ahead and view the service that we've launched. If you come here, you would actually get a lot of details, like what task is running. You have your event details here as well, auto scaling groups if any, and what are the deployments that have happened, other metrics if any, what was the CPU utilization and stuff like that. So there would be a lot of things that would be under concern. For now, let us just go ahead and see how the application looks like and stuff like that. Before that, you have your cluster details here. You have your task definitions, EKS, that is for some other session. You have your clusters, you have your repositories and stuff like that. So if I just go ahead and click on this particular icon, not the icon, the link rather, there you go. I would be redirected here. If I just scroll down. So guys, basically this is your load balancing group that is here, and these are some of its basic configurations that are there. This is the name, this is the ARN that is there, which concerns this particular service, the ports and all that we've already assigned, VPC and your load balancer. These are some of its attributes that are there. We can actually go back or scroll up, and probably we can not scroll up. Let's just come down here somewhere. Yeah, description. You're actually gonna go ahead and take a look at some of the targets that are there. These are your availability zones that you can do. You have your health checks that are constantly shown, as in how healthy your service is. Some monitoring details again here if you wish to. CloudWatch gives you the details. I've already mentioned that it would also help you actually go ahead and set alarms that if you wish to, and you can just go back here. Okay, let's just go ahead and search for ECS again. There you go. So your cluster is here basically, guys. These are the other details. It is sample for today, bad name. We launched it using Fargate. It works in tandem with your ECS, and these are the running tasks it says, and the number of services that are there. So you can just open sample for today. So yeah, this is the details about all the services that are there. And then you have your load balancer, which would let you actually go ahead and confirm whether your application or your container is up and running or not. So if you kind of scroll down here, there would be a DNS here which you can copy and you can put it here, and there you go, your application is up and running. So guys, this is how you actually go ahead and create a container, and basically you deploy that using ECS, and you can deploy Docker images. You can actually go ahead and deploy quite a few other types of applications and containers using ECS. One more thing that you need to know, guys, is you actually need to go ahead and delete your applications when you are actually using ECS service, or you're actually going ahead and using AWS. It is very important you understand the importance of deleting your services, because if not, you might be charged. We've actually gone ahead and configured a load balancer as well, so we need to delete quite a few things here. So this is our application, right? So if we come here, my application, what are the options that I have? I can say update, and number of tasks is 1. Set it to 0 so you do not miss out on anything important. Say next, next. So the service is updated. Let's just go to sample app service. The problem for me is navigating between these services, guys. I'm actually not used to using this interface a lot, and it kind of makes it irritating for me to actually go ahead and do all these things. So I'm just gonna go ahead and now select this and say delete. Say delete me. So this application would be deleted. Once you do that, you go back to your cluster, guys, and you can actually go ahead and delete your cluster as well. Where is the option to delete your cluster? Go to this sample for today and delete the cluster. So deleting the cluster takes a longer time than quite a few other things. Once you've deleted this, guys, you can go to your services, go to EC2 probably, and in the left side panel, you'd be given an option as in something called as load balancers. You can delete the load balancer there, and probably all the required tasks are done.
AWS Fargate. First, we'll discuss what is the need for AWS Fargate. Then we'll see what AWS Fargate actually is and how it works. Moving on, let's take a look at few key concepts that you must know when you're dealing with AWS Fargate. And finally, we'll be doing a demo in which we'll be deploying an application on AWS Elastic Container Service using Fargate launch time. I hope the agenda was clear to you guys, so let's get started. First, let's try to understand why Amazon launched AWS Fargate when it already has other popular container services like Amazon Elastic Container Service and Amazon ECS for Kubernetes, and what is the story behind it. So about a few years ago, before any container services even introduced, people used to launch their applications on virtual machine. Well, in this case, it is Amazon EC2 instances. So they would create this application package. This application package had code, lot of system libraries, system tools, web frameworks, and many other software packages that are needed to run an application successfully. Then they would take this application package and combine it with operating system into what we call Amazon Machine Image. Then they would launch this Amazon Machine Image and run it on Amazon EC2 instance. This worked fairly well. Then the Docker came along and containers started to become very popular, and people started deploying their applications on these containers. These containers, just like virtual machines, remove the need for physical hardware, they decrease the energy consumption, and increase the effectiveness. But the question here is, how are these containers any different from virtual machines? Well, the main difference between them is their architecture. I won't go into much details here, but let me give you a basic idea. As you can see in the diagram, in the bottom layer, we have host machine or host operating system. This host machine provides different kind of resources like RAM and CPU for all virtual machines. And these resources are shared among different virtual machines. And then there is hypervisor. It sits between your host machine and guest operating system. You can think of this hypervisor as a piece of software or firmware or hardware that creates and runs different virtual machines. And then we have virtual machines sitting on top of hypervisor. As you can see in the diagram, each virtual machine has an underlying operating system, virtualized hardware, and the user space to work on. Now, when we're talking about container services, with containers, instead of virtualizing the entire operating system or the computer like we do in virtual machine, just the operating system is virtualized. Well, what I want to say is containers share the host system's operating system with other containers as well. This way, your application package is completely separated from an underlying operating system. And you can also get certain level of isolation between all your applications that are running on single operating system. When your application is separated from underlying operating system, you can easily maintain all your applications that are running on different containers but on same EC2 instance. And moreover, you can use your EC2 instances more efficiently as well. So this container service started becoming more and more popular, and people started using them at very huge scale. So the number of containers in an instance started increasing, and the number of instances also increased. Now, managing all this increased number of containers and instances is always a tedious task. This was when Amazon introduced a container management service called Elastic Container Management Service. This Amazon ECS removed the need for the users to manage all the EC2 instances and the containers. So with this Amazon Elastic Container Service, users no longer had to manage the containers and the clusters. This Amazon ECS service kept track of all the instances, the applications that are running on these instances. It also kept track of the number of resources that were used by containers and the number of resources that are still available. So basically, this container management service did everything for the users. But still, using this container management service removed only a part of overhead that users were dealing with. Users still had to configure and manage the underlying instances that form clusters, as in the users still had to manage the EC2 instances on which these clusters of containers were running. Now, if we take a peek into one of these instances, you can see that an instance has container, lot of containers, an entire operating system, a Docker daemon, which acts as an interface between different containers in instance, and then you have EC2 agent and many other system level libraries and software packages. Now, managing the system level libraries, packages, lot of containers, an entire operating system for a single instance is a relatively easy task. But suppose if you have to do this for fleet of instances, then obviously it will become a difficult task. So all users wanted to do was to build their application, but they ended up managing containers and the underlying instances on which these containers were running. As a solution to this problem, Amazon introduced AWS Fargate. So with AWS Fargate, you no longer have to deal with EC2 instances. In fact, you don't have to use EC2 instances at all because AWS Fargate itself will act as a compute engine. So you only have to think about containers, so you can just focus on building and operating your application in a proper manner. And this AWS Fargate will launch your containers and host them for you and scale them as well. So AWS Fargate makes it easy to scale your applications. You don't have to worry if you have provided enough number of compute resources or storage resources for your application. You just have to specify your application requirements, and AWS Fargate will manage all the scaling and the infrastructure needs to run your application in a very highly available manner. And finally, AWS Fargate seamlessly integrates with Amazon Elastic Container Service and Amazon Elastic Container Service for Kubernetes. This way, with just few simple steps, you can launch containers on Amazon Elastic Container Service using AWS Fargate launch type. So there you go, guys. That was the story behind AWS Fargate. And now you know what was the need for AWS Fargate. So let me define AWS Fargate for you. AWS Fargate, in basic terms, is a compute engine that allows you to run containers without you having to provision, configure, or manage and scale clusters of virtual machines on which your containers run. Now let's dig a little deeper and see how this Fargate actually operates. So the image that you see on the screen will give you a rough idea of how actually AWS Fargate operates. Let's try to figure it out. So as you can see, as your first step, you built a container image. In this container image, you built in such a way that it's suitable for application. And then you store this container image in a registry. Well, you have Docker Hub, or you can use Amazon Elastic Container Registry. And from this registry, you can download the image whenever you want and run on the cluster. So now you have built a container image. The next step is you choose a container management service. It should be either Amazon Elastic Container Service or Amazon Elastic Container Service for Kubernetes. Once you've chosen a proper container orchestration service, you need to create a cluster so that you can store all the containers and the resources that you have assigned to your application. This is where you have to make a choice between choosing EC2 or Fargate. So obviously we'll be choosing Fargate here. So now you launch a container, and AWS Fargate runs your container and manages all the underlying infrastructures and clusters for you. Suppose later on, if your application needs extra resources, then AWS Fargate seamlessly scales your application without you having to bother about it. So wasn't that simple? Let's summarize what we've learned till now. So you built a container image that is suitable for your application. Then you choose a container management service out of ECS or ECS for Kubernetes. Then you launch a container using AWS Fargate launch type. And this AWS Fargate will manage and configure all the underlying infrastructure instances and the clusters for you. And suppose if your application needs extra compute or storage resources later on, it will seamlessly scale your application needs without you having to bother about it. So there you go, guys. That's how AWS Fargate works. And now let's take a look at a few key concepts that you should know when you're dealing with AWS Fargate. Okay, so first we have containers. I'm sure you might have heard of Docker containers, and I'm sure you know what those are. Well, a Docker container is a standardized unit of software development. In simple terms, it has everything you need to kickstart your application, like system libraries, code, system tools, runtime, and web frameworks, and many other things. Now, these containers are created on a read-only template, which we call container image. And these images are built from a Docker file. You can think of this Docker file as a plain text file that specifies all the components that you should include in your container. So once your Docker container image is created, it is stored in the container registry, like it is stored in the Docker Hub, or you can use Amazon Elastic Container Registry service. From there, you can download image whenever you want and run it on the cluster. So it's as simple as that. So you have a Docker file, which has all the specifications regarding your container. And from this Docker file, you create a container image and then store it in container registry. And from container registry, you download image whenever you want and run it on the cluster. And then we have task definition. Well, to prepare your application to run on Amazon ECS service, you need to create a task definition. You can think of this task definition as a blueprint for your application. So basically, it's a text file, mostly in JSON format, that describes one or more containers that you'll be using for your application. When I say it describes your containers, It includes the type of containers that you'll be using for your application, or the launch type which you'll be using, or the ports which should be open for your application to be accessed, among many other things. So the following is an example of a simple task definition that defines a single container that runs on Nginx web server, and it's using a Fargate launch type. So as you can see, the simple task definition belongs to web server family. And as for the container definition, you have name, image, and the memory and CPU requirements. And it also says that we are launching this container using Fargate launch type. Then you have task requirements as in network mode, memory, and CPU requirements. So don't worry about it, guys. We'll deal with it in the demo part of the session. You'll understand it much better over there. So just keep in mind that this task definition is like a blueprint for your application. So guys, next we have task. Well, let me give you an example. I'm sure when you're writing a program, you might have used class and objects. Like, object is an instance of class. Similarly, a task is instantiation of task definition within a cluster. So once you've created a task definition for your application, you need to specify the number of tasks that will run on your cluster. Well, you can always go ahead and have single task, but it's always good to have more number of tasks. Suppose one of your tasks fails, then your other tasks will come into picture. Then you have Amazon ECS Task Scheduler. It's responsible for placing your task within your cluster. Well, there are several different kind of scheduling options available, but mostly you can go ahead and define a service that runs and maintains user-specified number of tasks simultaneously. We'll do that in the demo part of this session. I'll show you how many tasks you can add, where you can add, and how do you do it. And now, like I said, the task scheduler is responsible for placing these tasks within your cluster. But what is cluster? Well, it's logically a group of resources that you're assigning to your application. Suppose if you're using Fargate launch type within your cluster, then Amazon Elastic Container Service will manage all your cluster resources. But if you're using EC2 launch type, then all your cluster will be considered as a group of container instances, which you will have to manage. So there you go, guys. Now you know what containers are and how container is actually created. Then you know what task definition is, a task keys, and clusters. Now we are ready enough to venture ahead and deploy an application on Elastic Container Service using Fargate launch type. So let's go ahead and do that. So guys, this is my AWS management console. And I hope you've understood what we've learned in the theory part of the session and you know all the key concepts. Now let's go ahead and deploy an application using AWS Fargate launch type. So first I'll have to select Elastic Container Service here. If you're using Elastic Container Service for the first time, you'll land on this page. And there's a Get Started options at the bottom of the page. When you click on that, it'll directly take you to a page where you can start using Fargate. But before we do that, let's go ahead and explore other features of Elastic Container Service, as in how to launch an application without using Fargate. Only then you'll understand the difference of Fargate and EC2. So there you go. Like I said earlier, creating or launching an application on Elastic Container Service basically has 3 steps. First, you need to go ahead and create an image for your container. That is what you will do in this Amazon ECR part. Then you need to create a task definition as in blueprint for your application. Finally, the cluster to hold your containers as well as the resources that you've assigned to your application. So click on this repository. Basically, a repository is where you store your Docker images and Amazon Elastic Container Registry. Click on this Get Started. Give your repository a unique name and the endpoint will be specified here. And click on Next Step. So let's say My Image and click on Next Step. Now your repository is ready. So like I said earlier, it's a place or it's a location where you store your image. Well, there are certain details specified here, how to create an image and push image to this repository. We won't be going into much details here, but let's see what is there. The first step is to log into your Docker, then build an image. Then this is the command to push the image into the repository which you just created. So you just follow these steps on your command prompt and your image is created and will be pushed to repository which you just created. So let's go back. Okay, let's assume that we have created an image and we have pushed into our repository and our container image is now ready to use. And as for the next step, we need to create a task definition. Well, like I said earlier, it's like a blueprint for application. So every time you launch a task in Amazon ECS, you specify task definition. This way, the service knows which Docker image to use, how many number of containers your application need, and the resources allocated to these containers. So you have this create new task definition here. Click on that. So you have 2 options where you specify, do you want to launch your application using Fargate or EC2? Let's select EC2 first. So click on Next Step here. First thing you do is configure task and container definitions. So give a unique name for your task definition. And it says that we've chosen to launch an application using EC2. In the task role, suppose you want your task to contact other AWS services, you can use this API role. Then as for the network mode, you can create your own VPC or you can use the default VPC as well. And now, earlier we created image and stored it as repository. Suppose you want to pull that image and use that in your cluster, then you need to create a role which gives you permission to do that. So that is what this task execution role does. And in addition to that, it also publishes your container logs to Amazon CloudWatch on your behalf. Well, you can go ahead and create one on your own, or you can just ask the Elastic Container Service to create a default one for you. If I say none, then no task execution role will be created. Well, I can use this already existing one or create a new one. Next, you need to configure task definition parameters like CPU units and the memory units that your task might require. Then there's an option which says add container. So this is where you add your container image that you created earlier. This is the image ID, give your container a name and click on add here. We won't be doing that here. I'm just showing you how it happens. That's it. And there are certain other details which I won't be going into. Then you click on create option here. So that's it. Now you know how to create an image, store it in repository, how to create a task definition and attach your containers to this task definition. Now finally, clusters. Okay, I forgot to create a task definition using Fargate launch type. So let me go back. So again, create new task definition and use Fargate launch type. Click on next step. Everything is same except here in case of EC2, it shows Fargate. As you can see, rest is same. You have task role, network mode, again task execution role, task configuration details like CPU and memory and the container image. Okay, now let's go back. So now you have assigned all the resources that you need to your application. You have created a container and a task definition. The next thing you need is you to store all this task definition, containers and all the resources in cluster. So you can always go ahead and click on get started option, which will directly take you to Fargate page, or you can just click on create cluster. Well, when you do that, it asks you to choose either Fargate type or EC2 types. Well, in EC2, you have two, EC2 Linux and EC2 Windows. Let's go ahead and choose one, EC2 Windows, and click on next step. Well, obviously, it'll ask for a unique cluster name. Give your cluster a name and choose what type of instance model you want to use, on-demand or spot. Then instant type, as like you know that there are different instance types. You can choose one of your choice out of the available ones. Well, the next is number of instances. Suppose you want all your containers to sit in one instance, then you can choose one. Suppose if you want to use fleet of instances, then you can specify the number you need there. Then the storage in terms of gigabytes and the key pair, SSH key pair as well. And as for networking, you can go ahead and create a new VPC or you can always use a default one. And this is the IP address to access your application, port address. And when you're launching your application using EC2 types, then you'll have to give two subnets here, subnet 1 and subnet 2. Well, you can go ahead and add more subnets as well. Make sure to mention the IP address and the port range here so that people can access your application. Then you have an instance IAM role. It says that Amazon ECS container makes calls to ECS API actions on your behalf using this IAM role. Well, if you can always go ahead and create one, otherwise ECS will create one for you. So this is how you create a cluster on your own using EC2 Windows option. Now let's select Fargate. Okay, and click on next step. So earlier there were options regarding EC2 instances, type, on-demand, spot, number of instances, all that. But here you don't have all those reasons, just a cluster name and VPC if you want to add it. That's it, and click on create. It's as easy as that. So let's go back and click on this get started option. Okay, so let's say you just have created an image. Forget you've created any task definitions or anything. So using this when you click on this get started option, you can do all the 3 steps which we did earlier in just 1 step. So in the key concepts portion, which we discussed in the theory part, we've learned the container definition, container image, task definition, services as in the Amazon ECS scheduler, which assigns the task to the cluster. Then you have cluster. It's a collection of resources that we assign to your application. So there we go. First, we need to define a container, as in create a container image. You can always go ahead and click on this edit option and configure option and create a container image of your own. But for this demo, we'll be using a sample or preloaded container definition. Well, you have Nginx web server, Tomcat web server, and a simple web app. So I'm going to use this simple app and click on edit. I'm not going to change anything, just to show what is there. So let's retain the same name, simple app. And this is the image ID. And it's chosen soft limit for the memory and 512 bytes. Okay. These are the required details. And make sure that you enable port 80 so that your application can be accessed. And you have advanced container configurations as well, like health checker, as in the timeout, time and periods. Then you have environment details, the number of CPU units, network settings, storage and log details as well, and many other details among this. Once you've made the changes according to your requirement, you can just go ahead and click on update. But I'm going to use the same details. So let's just click on cancel. Next, you need to configure task definition parameters. So task definition name and the network mode as in VPC, default VPC. You can always go ahead and create a new role, or you can just say use the existing role. So edit. So the task name, network mode, execution role, I've selected ECS task execution role, the default role which ECS assigns to me. Then there's a launch type, obviously it will be Fargate. Then task definition parameters are like task memory unit and task CPU units as well. You can mention that and click on save option. Now, a container image is created, but here we have used the preloaded container image and we have configured the task definition parameters as well. So the next step, we need to define a service. As in, we have created multiple tasks in the previous steps. So all these tasks need to be assigned to a cluster. So this is why you need to define a service so that it knows which Docker image to use, how many containers you need, how many resources are allocated to your containers and all that stuff. So give your service a sample name. Let's just click on this edit. So give your service a sample name and specify the number of tasks. Like I said earlier, these tasks are instance of task definition. So you can create as many tasks as possible out of task definition. Suppose one of your tasks is unhealthy, you can go ahead and use other task instead of this unhealthy task. But for this demo, I'll be using just one task. You can specify here. Then make sure to give IP address and port range should be 80. Remember that. And if you want load balance to be enabled, then you can just click on application load balancer. It says here that if you're not using a load balancer, then a security group is created to allow all public traffic to your port. But if you're using an application load balancer, 2 security groups are created to secure your service. Since we're not using any load balancer, let's say all the traffic will be directed to this port 80 and click on save option. That's it, and click on next here. Now we'll have to define a cluster to hold all these containers as well as the resources which we have assigned to your application. So give your cluster a name, an ID, VPC ID if you're using any, and subnet ID if you're using any. Well, as for this demo, I've selected an option which says automatically create a new one for me. So ECS will handle that for me and click on next option. Okay, there you go. This is the page where you review all the details which you have given till now, and you can go ahead and make changes if you have done any mistake. So we have selected a sample container. And as for the task definition parameters, okay, the network mode, task execution role, container name, image ID, and task definition parameters as in memory protocol. And as for the service, I just want one task. And as for the cluster name, which is default, by the way, let us change the name. Let's say my first cluster. It should be fine. Okay, next. Okay, it says my first cluster, and VPC and subnets will be automatically assigned by ECS. Then click on create. There you go. It takes a while, but your application will be successfully launched by Fargate for you without you having to bother about any EC2 instances, or you don't have to bother about the containers and all that stuff. Well, wasn't that easy? Just few steps. Using one step, like using one click, we created a container image, we created a task definition, we created a service which handles these containers, and a cluster which holds these containers as well as other resources that your application might need. So all that is happening in the background, but the status is being shown to you here. So it says cluster has been completed, properly created, task definition is also created, service is still being created. And as for the log group, it already exists. And then you have subnet 1 and subnet 2 security groups and the default VPC. So let's wait for a while. Okay. So it says your service has been created properly and you can view your service. Okay, let's click on view service. Okay, there we go. The cluster, my first cluster, it's the name. Status, it says it's active. This is a task definition, default task definition, which Fargate created for us based on the specifications which we provided. And the launch type, obviously Fargate, and it's the latest version of platform that it's using to deploy an application. You have other details as well. As for the load balancer, we haven't enabled it. If we do, then it shows the load balancer is enabled. All the details related to load balancer as well. Okay, then we have network details, VPC and subnet groups. Okay, let's start from the back. Logs. It's still loading. So we haven't done any activity using this. So for now, it's not showing any logs. Same for the metrics as well. For now, the graphs are blank. So if you remember, we just selected one task. It says the health percent is 100, maximum percent is 200. If you have selected 2 more tasks, it would have shown the health of all those tasks here as well. Okay, these are the events, as in the things which we did from the time we created a sample service using Fargate. It just shows the list of activities that has happened. Now, if you want to view your sample web application on your web browser, then you go for this task, click on this task ID. It'll take to your page where it shows the details regarding your cluster, your task definition and all that. In the network details, you have this Elastic Network Interface ID. You click on that, it'll take to EC2 page. There, when you scroll down, you have IPv4 public IP. You copy the address, Control C, and paste it on your web browser and click enter. So there you go, guys. It has created a sample web application just in few steps. Okay, now let's go back to our Elastic Container Service and see if there's anything left to explore. Okay, so this is the cluster we just created, my first cluster. It says one service, one task is running right now, no pending tasks as well. Okay, that's it, guys. Now you know how to launch a container or how to launch your different containers or an application using Fargate launch type. Well, wasn't that easy when compared to using just the Elastic Container Service using EC2? Well, I've done nothing. It's just a small part of what Fargate can do. Go ahead and explore it. Create your own applications, create your own container image, attach it to the task definition, and explore Fargate.
Autoscaling and load balancer. So today I'm going to tell you how you can autoscale your resources so that they become highly available. So guys, this is what we're going to do today. First, we're going to see what are snapshots and AMIs. So these are basically the entities using which you will be autoscaling your resources. So once you know what are snapshots and AMIs, we'll move on to why do we actually need autoscaling and what is autoscaling exactly. After that, we're going to see what is a load balancer, and towards the end we'll be doing a hands-on, which is going to be very interesting because I don't think there's a demo out there which can show you the kind of demo that I'm going to show you today. All right, and if you think about it, guys, if you're thinking about moving to the cloud industry, autoscaling and load balancing are the very important topics in this domain, right? So you should know about them. So if you don't know about them, please pay attention today because you're going to gain a lot of knowledge today. All right, moving on, guys, let's start with the first topic, which is snapshots and AMIs. So let us see what are those. So I guess most of you are aware of what an EC2 instance is. So for those of you who are not, an EC2 instance is just like a raw server. It's a fresh piece of computer that you have just bought. It's just like that, right? So on that computer, you can choose any operating system that you want. So once you have the operating system, you can install any kind of software on it. All right, so you have to install every time you launch a new EC2 instance, you have to install all the required softwares on it. All right, but there's a workaround. What if you want a specific configuration of EC2 instance? Say you want 5 EC2 servers which are exactly like this, like each other, right? So one way of doing that would be to launch a new instance every time, install the required packages every time, and going about it, right? The other way of doing it would be to actually create an image of once you will be configuring your EC2 instance, and after that you'll be creating an image of your EC2 instance, and then using that image you can actually deploy 4 more EC2 servers. All right, so this image is basically what is an AMI. So AMI, which is an Amazon machine image, is nothing but an executable image of your already existing EC2 instance, right? But before an AMI can be created, there's a thing called snapshot. Now, what are snapshots? Snapshots are nothing but the copy of the data, the copy of the data that you have on your hard drive. So basically, if you have your C drive, right, and you want to copy your C drive, you copy your C drive onto some external drive. So that becomes a snapshot. But if you can boot from that external drive so that to your whole operating system comes up on some other machine, then it becomes an AMI. So this is basically the difference between the two. A snapshot is not a bootable copy. An AMI is a bootable copy that you have. All right, so I hope you got the difference between what is an AMI and what is a snapshot. So I'll repeat it again, and you use an AMI to basically replicate an EC2 instance again, so that you don't have to do the configurations all over again. right? So now you'll be wondering, we were to talk about what is autoscaling, what is load balancing, why do we need AMIs? But be patient, you'll be clear with everything with the session. All right, moving on, guys. Let's now discuss why do we need autoscaling. Now, before that, guys, now the way I'll be going through this session is I'll be explaining you each topic and then I'll show you it in the AWS console. All right. So we just discussed what are snapshots and what are AMIs. So let me quickly show you how you can configure or how you can create an AMI of an already existing EC2 instance in the AWS console. So give me a second. I'll just go to my browser and my AWS console. So guys, this is my AWS console. I hope it's visible to you. So the first thing that you'll be doing is you'll be going on to your EC2 console. All right. So in your EC2 console, you will have all your servers that are running right now. Right. So for the sake of simplicity, I've already deployed two servers, which are server 1 and server 2. Now I have configured them both with Apache so that they can they can host a website, right? So let me quickly show you how the website actually looks like. So if I'll go to this particular IP address of server 1, this is in path server 1. Right, so this is how the website looks like, right? Similarly, for my server 2, if I go into my server 2, this is how my server 2 will look like. Here it is. All right, so these are my two servers. Now what I want is I will create an exact copy of these servers so that they can be replicated. All right, so when I say replicated, everything from softwares to this website will be copied onto an image, and that copy or that image, when I will deploy it, it will be deployed inside one more EC2 server in which I don't have to do anything. This website will be there. I just have to go to the IP address and I can see this website. All right, so now what I'll be doing is I'll be creating an AMI of both these servers. So let's create an AMI for server 1 first. I'll select the server 1, I'll go to actions, I'll go to image, I'll click on create image, and all I have to do is give an image name for it. So let me give the name as live server 1. Right, this is my image name. I'll click on create image, and that is it. It takes in your request for creating an AMI and it does that. All right, pretty simple. Now similarly, I'll be doing it for server 2 as well. I'll select server 2. I'll go to image, I'll create an image, and I'll name the image, say, live server 2. So once I've done that, you can see the images in your AMI tab. So if you look at over here in the images section, you can look at AMIs. If you go to your AMIs, you can see there are two images which are just being created, which are in the pending state as of now. And they are live server 1 and live server 2. Now using these images, you can create any kind of server that you can create the exact same server with just a click of a button. All right, you don't have to configure anything much. All right, so this is how you create an AMI. Pretty straightforward, guys. Let's move on and discuss why do we need autoscaling now. So you learned how to create an AMI. Let's go ahead and understand autoscaling and see how they are connected to AMIs. All right. So say you have an application, you have a website, and every machine, now this website is hosted on some server, guys, right? And servers are nothing but machines. Now every machine has its limitation, right? For example, say this machine is say around 8 GB and say i5 processor. So say it can host around 100 people. Right? Only 100 people can come to this website and easily navigate inside the website. But if more than 100 people comes in, this computer or this server becomes slow. All right. So say there are 100 people as of now, and they are trying to access your website, and they can easily access it. Now your website becomes a hit overnight. All right. And now a lot of people are trying to access your website, which makes your server overburdened. Now, in this scenario, you can do only one thing, that is deploy more servers and distribute the traffic equally among those servers so that the requests can be handled. All right. Now, this thing is a manual task, and manual is a big no in the IT world, guys. So we invented a service called autoscaling, and using autoscaling, what happens is it actually analyzes the kind of load which is coming in, right? And it deploys the servers according to that. So say around 300 people are coming in, and it sees that you need 3 servers to handle those kind of requests. It'll do that automatically, right? And that is where your AMI comes in, guys, because the new servers that you'll be launching, those new servers have to be taken out of some template, right? So the first server has to be the exact copy of the the second server has to be the exact copy of server 1. The third server as well has to be the exact copy of server 1, right? And that is where the AMI comes in. So what basically happens is, in the autoscaling service, you basically attach your AMI which you created, and using that AMI, it deploys more servers, right? This is why AMI is significant, or this is how AMI is related to autoscaling, and this is why do we need autoscaling. Let's move ahead and just give us a definition that what autoscaling exactly is. So like I said, whenever your load increases and you have to scale automatically up and down, you use autoscaling. So it's not only about scaling up, that is when your load increases, say 3 or 4 servers you have deployed, and when your load decreases, still 4 servers are there to sitting idle, right? So that is not the case. With autoscaling, you can also scale down as per your needs. You can configure everything which you can imagine about scaling up and scaling down in the autoscaling properties, right? So this is why we need autoscaling. Now, one more thing that you need with autoscaling is, if you would have noticed, I said the number of servers that gets deployed in the autoscaling. Say there are 4 servers which get deployed during autoscaling, right? Now the traffic has to be distributed equally, right? So this traffic which has to be distributed has nothing to do with autoscaling. It has to be done by a separate entity, and that is what we are going to discuss in the next section. But before that, let me show you how you can configure the autoscaling properties and attach the related AMI so that the related servers are launched, right? So let me go to my AWS console. So here am I, and as you can see, the AMIs have already been created. They are live server 1 and live server 2. Now what I'll be doing is I'll be creating autoscaling groups, or I'll be configuring the autoscaling properties so that these servers can be autoscaled as and when required, right? So before that, I actually have to create a launch configuration. Now what is a launch configuration? So if you look at the AMI, guys, you have only specified what kind of data should be there in your server. What you have not specified is what kind of machine you should launch every time there's a need. All right, so that is exactly what you do in launch configuration. So you have the data, but you don't have the information about the kind of machine that you want to launch. So that kind of stuff you will be specifying in the launch configuration. So what I'll be doing is I'll click on create launch configuration, and now it'll give me a wizard as same as that of any EC2 server. Right, in the EC2 server, I had to choose an operating system, right? So same, it will give me the wizard, but I don't have to go here. I'll have to go to a separate tab which is called My AMIs, right? So I'll select My AMIs, and now I'll select the newly created AMI, the AMI which I just created, which is say we are creating a launch configuration for our server 1 right now. So I'll select the live server 1. I'll click on select. And now it will ask me the kind of the configuration that I want for my server, right? So I need a t2.micro because we are doing a demo today, right? So we don't need much of computing power. So we just have to we'll select t2.micro and we'll name our launch configuration a thing. So let's name it as live server 1, right? And the IAM role is not required, and I'll click on next. Now it'll ask me for adding the storage, so 8 GB is enough for an Ubuntu machine. I'll go to configure security groups, right? And in these security groups, I just have to add the HTTP rule because I have to connect to all the instances that I'm launching, right? So I'll select the HTTP rule from here, right? And I'll click on review. So that is it, guys. Nothing else has to be configured here, right? So every server which will be launched, it will be associated with a key pair which you'll be specifying here. All right, you can create a new one if you don't have already. I already have a key pair, so let me choose my key pair. So that is Hemant_2, and I acknowledge that I have this key pair, and I'll create the launch configuration. It just takes a second or two to do that, and we are done. All right, so now we have created a launch configuration. We have specified what kind of machine we want. We have specified what kind of data should go into that machine. Now we'll be creating the autoscaling group, in which we'll be specifying in which cases we want to autoscale. All right, so let's create an autoscaling group now. All right, so it has automatically picked up the launch configuration that we have just created, that is live server 1. Right, let's name this group as live server 1 group. Right, and what is the initial size that you want in your launch configuration? That is the minimum number of servers that you want. So let it be 1. And remember, guys, this is the most important part. When you are creating a launch configuration, ensure that you're doing it in your default VPC to be on the safe side, because there are a lot of settings that you have to do if you create a VPC on your own, and that becomes a hassle. All right, so if you accidentally delete your default VPC, which I did, right, so you have to contact the AWS support team, and they'll help you out with it. They'll basically create one for you. You cannot create one on your own. All right, so always ensure that you are in your default VPC whenever you're creating your autoscaling group. All right, so now I'll be specifying the subnets. So basically you have to select a minimum number of 2 subnets, right? I'll be not getting into what are subnets, because then it will be like a 3-hour session. We'll click on configure scaling properties. Now over here you can specify the properties that I was talking about. When do you want your server to scale, right? So over here you can specify the average CPU utilization. Now what do you mean by average CPU utilization? So there are 4 servers running as of now, right? So it takes the average of all the 4 servers, right? And if the average goes beyond whatever number you have specified here, say I specified 70 over here, right? So in that case, whenever the average CPU utilization will go beyond 70, it will launch one more server. Similarly, if it goes, I can configure one more property here, which says if it goes below 20%, like scale down from one server. All right. So if there are 5 servers and the CPU utilization has gone less than 20%, it'll scale down from one server and come down to 4 servers. All right, and you can also set how many seconds should it wait. Say the traffic is spiking down and up like too frequently, right? So for that, what you can do is you can set a time. So if the 20% mark has been not crossed till say like 5 minutes, then it will scale down a server. Or if the 70% mark of the CPU utilization has been crossed over 5 minutes, it will then only scale up. It will not scale up if at only once for only 1 second it becomes 71%. All right, so you can specify all of that over here, but since I cannot load test my instance over here, I'll just keep it at its initial size, which just means that it'll, even if I delete my instance, that is one instance has to be there in any case. If I delete the instance, it will automatically launch it again. All right, so we'll select the keep this group at its initial size, and we'll go to configure notifications. So I don't want to configure the notifications, neither the tags. I'll click on review and I'll click on create autoscaling group. All right, so I've successfully created an autoscaling group for my live server 1. All right, similarly I'll do the same steps for my server 2 as well. I'll click on create autoscaling group, and I'll select a launch configuration which was there for my server 2. So I've not done that, so let's create a launch configuration first for our server 2. We'll go to AMIs and we'll select the server 2 part here. All right, so I've selected server 2. I'll do the same steps that I did earlier, right? So let me give it the name as live server 2 group. I'll click on add storage, configure security group, Over here, I'll add the HTTP rule. Click on review and launch configuration. Select the key pair. Acknowledge it. Create launch configuration. I'm doing the same steps, Skype. I'm not doing any new thing here. I've created the launch configuration. Now I'll create the autoscaling group, which is live server 2 group, right? And then the VPC, as I said, should be default subnets, a minimum of 2 subnets you should select. I'll click on scaling properties. I'll keep it at initial size, configure, review, and create the autoscaling group. All right, nothing much, guys. So same things that I did for my server 1, I've done for my server 2 as well. All right, so since I've created an autoscaling group, if you go to your EC2 dashboard, you would notice that 2 more servers are now being deployed. All right. So you can actually identify them over here. See, these 2 servers are being initialized. So these have just been created by your autoscaling group, because we've specified that a minimum number of 1 server should be there at all times, right? Now, if you try to go to the IP address of this server, right, you will see that it will have the exact same settings for my EC2 instance. So this is my server 1. Right, so as you can see, a new instance got created, but with the exact same settings. I didn't have to do anything. It automatically created an instance with the same settings. All right, and same is the case with server 2 as well, guys. If I go to my server 2 and try to access it, I'll see the same things over there as well. So I'll show you in a bit. Yeah, so this is my server 2. All right, so my autoscaling group is functioning fine. So let us come back to our slide now. So we are done with autoscaling. Now, like I said, you need to have an entity which will equally divide the traffic between the servers that you've just deployed. All right. So they say I've created 2 autoscaling groups, guys, as of now, right? Why I've created a second autoscaling group, I will tell you in a bit. But for now, understand that there is an autoscaling group. All right, and inside that autoscaling group, say there are 5 servers, and if a person is coming in, or a customer who has logged on to your website is coming in, how would his traffic be treated? How would he know which server to go to, right? So there comes in the third entity, which is called the load balancer. So what load balancer does is, a load balancer, your customer will basically be coming to your load balancer, and the load balancer will decide based on the usage of your servers that which server is more free, and then will give the connection to that server. All right, so this is basically the role of a load balancer. So like I said, a load balancer is a device that acts as a proxy and distributes network or application across a number of servers. Now, I've been saying it repeatedly that your servers are actually, your traffic is actually distributed equally among the servers, right? But in a few moments, I'll tell you that there is one more way of distributing your traffic. All right, so before that, let me again stress on the point that this was your autoscaling group, guys. This is just the example that I took in the beginning, right? So there are like these set of users, and they're trying to access your website, and they are being routed to these servers. So this routing is actually done by a load balancer. All right, now, like I said, the traffic which is distributed, it is distributed in 2 types, right? The first type would be to equally distribute them among the number of servers. Like say there are 5 servers, so it will distribute it among the 5 servers. But if there are there are 2 kind of servers now, so your load balancer can identify what kind of request is being made by your user. For example, in your website or in your application, you have a part wherein you can process the image, right? And you have a part where you have your blogging section. All right, so if you want to process the image, you want your traffic to go to a different set of servers which are auto-scaled at their own in their own auto-scaling group. All right, and if you have the blogging section, you have a different auto-scaling group which is auto-scaled at a different with a different auto-scaling group. but you want everything to go from one single link. So the way to do that is using an application load balancer. So let me just repeat what I just said. So say this set of servers, they host your image processing part. They do all your image processing, and these set of servers, they host your blogs that you have on your application. All right. A user comes in, he just logs on to your website and he goes to a URL which says, say, edureka.co/image. All right. If he goes to /image, your load balancer will see, okay, he's asking for the image kind of content. So he should go to this set of servers because these servers serve the image purpose. And if you go to edureka.co/blog, your load balancer will identify, okay, this user, he is asking for the blog content. So he should go to this set of servers. All right. So all of that is done using your load balancer. If you compare it with the classic load balancer, it does not have that kind of intelligence, right? What it will do is basically all the traffic that it has got incoming to it, it will equally distribute it among the number of servers that are under it. All right. But with application load balancer, you have this option wherein you can divide the traffic according to the needs of the customers. All right. Now, when you have divided the traffic, again, the same thing will happen here as happens in classic load balancer, that at this point, it will equally distribute the traffic among the number of image servers, right? And similarly, the people who want to access the blog, it will equally distribute the traffic among the number of people who want to access the blog server. All right. So this is what an application load balancer is all about. So classic load balancer was something which was invented earlier, and these days nobody uses the classic load balancer anymore. People are using application load balancer. All right, and that is what our demonstration is going to be all about today. All right, so enough of talks. Let's move on to the hands-on, that is the demo part. So let me quickly show you what we are going to accomplish today. So basically a user will come in, he will have the address of your load balancer, and if he asks for the image path, or say server 1 in our case, he will go to the autoscaling group of server 1. If he asks for server 2, he will go to server 2, but all of them will have the same address, that is using your address of your load balancer. All right, so this is what we are going to accomplish today. Now for those of you who didn't understand that why did we create two autoscaling groups, is because we want these servers, that is the image processing servers, to be scaled as well, and at the same time we want the blog servers to scale as well. Right? So that is the reason we want we created two autoscaling groups. So I created a server 1, which you can imagine is for your image processing. And I created an autoscaling group for server 2, which you can imagine is for your blogging section. All right. Having said that, guys, now let's move on to my AWS console and go to our load balancers. All right. So what I'll be doing now is I'll be creating a new load balancer, and that load balancer would be of the type application load balancer. So as you can see, I have two options here. Either I can create a classic load balancer, or I can create an application load balancer. So I'll go on with the application load balancer, and I will name it as live load balancer. And the scheme is internet facing. So since mine is a website that I want you guys to access, right? So it could be internet facing. Otherwise, if you are working in a company and that company wants a load balancer for their internal websites that the companies have, you can actually opt for an internal load balancer as well. But since ours, we have a website and we want that to be used, we will use the internet facing load balancer. All right, and the listeners, it's HTTP, that's fine. And the availability zones, like I said, you have to select a minimum of 2 availability zones, and you'll click on configure security settings. All right, so now you'll be specifying the security group. Right, so in security group, it's better to create a new security group. Remember, guys, don't include the default security group for your load balancer. It's a good practice to always create a new security group so that you can customize your rules according to your needs. All right, so I'll create a new security group and specify the HTTP rule, and I'll click on next. And now comes the part wherein we'll be specifying the targets. All right, now what are targets? Now in application load balancer, guys, targets are basically but auto scaling groups. Right, so target 1 would be your auto scaling group 1, your target 2 would be auto scaling group 2, target 3, target 4. You can have as many targets as you want, but in this wizard you have to specify a minimum number 1. Right, so we'll create a new target group. We'll call it as say auto scaling live auto 1. All right, and the protocol is HTTP, port is 80. We'll click on next, and I'll review everything. I think everything is fine, and I'll create this load balancer. All right, so we have not done all the settings, guys. I'll show you how to do all the settings. For now, we have just created a plain load balancer. All right, so I have created a load balancer which is pointing to a target group 1, and that target group is not pointing to my auto scaling group as of now. All right, we will do that now in this part. So we have created, I just created a target group called live auto 1. I'll create one more target group which will be called live auto 2 for my second auto scaling group. All right, so I'll create this and done. So I now have two target groups, that is live auto 1 and live auto 2. Now these two target groups have to point to my auto scaling groups respectively. All right, now the way to do that, you cannot point them here. You have to go to your auto scaling groups, right? And in your auto scaling groups, you have to select the auto scaling group that you have just launched. So it is live server 1 group and live server 2 group. So I'll go to live server 1 group. I'll go to details, and over here you'll click on edit. All right, and inside edit you have this option for target groups. You don't have to specify anything in the load balancers. This option is only for classic load balancer, but we are creating an application load balancer, right? So we'll be specifying everything in the target groups. So for live server 1 group, we'll be specifying the demo server 1. So demo server 1 has already been, it will be live auto 1, the target group that I just created. And live auto 1 is connected to your load balancer. So basically your load balancer will point to your target group, and your target group is now pointing to your auto scaling group 1, which are pointing to your instances. All right, so this is how it the visibility comes in. So I'll save it. The target group 1 is live server 1 group, and the target group 2 I'll be specifying in the second auto scaling group, which is here. That is live auto 2. All right, I'll save it, and let me quickly verify if I've done everything right. So this is live server 1 group, and this is live auto 1. Fine. This is live server 2 group, and it is live auto 2. Fine. So my load balancer can now see the auto scaling groups that I've just configured. So let me quickly go to my load balancer. Now comes the part, guys, wherein I'll be specifying when to go to auto scaling group 1 and when to go to auto scaling group 2. Like I said, we'll be specifying it using the kind of request that the user has made, right? So the way to do that is is by first selecting your load balancer and going to listeners. So once you go to listeners, guys, you will reach this particular page. Now in this you have to click on view or edit rules. Right, so once you click on view or edit rules, you will reach this page, which is kind of an if-else, if-else structured. So now what will you do is, so you can see that there's a default rule as of now that any request which is made, it will go to live auto 1. All right, which means any request which is made, it will straight away pointed to the auto scaling group 1. Now we'll specify if the request if the user is asking for server 2, he should be pointed to server 2. So let us do that. The way we'll do it is like this. We'll click on add rules. We'll click on insert rule, and now I'll specify. So you have two options here. Either it could be the the routing could be based on your host, that is the address of your website, or it could be based on the path. Now, what is the difference? Say edureka.co. This is a host name, right? Now, if I type in resources.edureka.co, it'll still point to my domain. But if I've specified resources.edureka.co, and if I write it over here and I specify it has to go to server 2, it'll go to server 2. Otherwise, if you type in resources.edureka.co, nothing will happen because you've not configured anything, right? So that is the host path. With paths, the difference is that say you write edureka.co/blog, all right? So that /blog becomes the path. But with host, the thing is, the difference is resources.edureka.co. So that becomes one host name, right? But with path, you're basically putting a slash and you are going into a particular folder. All right, so you can specify the path here, right? It doesn't matter if you have not specified in your server for different you could the way you could have done the image processing and blog the other way around rather than having it on two servers was that you could have configured it inside two servers in your root directory, right? It could be server 1 for your image processing and server 2 for your blogs. But I don't want that because as distributed as your system is, it becomes more reliable, right? And that is the reason we have two different servers for two different set of things. So the way you can route your traffic to both these servers is by typing in the path. So say if I have to go to server 1, I'll type in server 1/*. So star basically means anything after server 1 can be accepted, but it has to go to the request will be forwarded to live auto 1. All right, so if I have server 1 in my path, anywhere in my path, it will go to live auto 1. So I'll save this rule. Similarly, I say that if it has server 2 in its path and anything after that, it has to go to live auto 2. All right, I'll save it. And that is it, guys. Now my load balancer has saved its settings. Let's hope for the best and try executing it. So this is the link, guys, right? If you just type in this link, it'll by default go to server 1, right? So if I go to this link, you can see it is going to server 1 as of now. But if I specify /server1, it'll go to my server 1, and if I specify /server2, it'll go to my second server. Now you might be wondering that Hemant, you might have a different directory in your same server. So let me clear your doubt according to that. So what I'll do is I will go to my EC2 dashboard, right, and I'll go to server 1, and I'll quickly show you what happens if I type in server 2 here. All right, so this is the IP address, right? So if I type in this IP address, I'm going to server 1. If I type in /server2, it will give me a 404 because there is no folder called server 2, right? Same is the case here. So if I go to this IP address, you can see server 1. If I don't specify anything after my address, it will still go to the same server that is here, that is this IP address, right? But if I specify /server2 over here, it will not be able to do so because this is not a load balancer, it is directly your IP address. But over here, if I specify server 2, it will redirect me to the second server. One second. Right, it will redirect me to the second server. And that is all that I need. All right, so with one address, you are actually pointing to two servers, which will be solving your two problems. Now, the real life use case, like I told you, it could be for different kind of tasks. Say you have a blogging section on your website and you have an image processing section on your website. If you want two different servers to host your two different services, you can do that easily using a load balancer.
Amazon S3, which is simple storage service. This is the agenda or the offerings of today's session. We would start by understanding what are AWS Storage Services. Then we would take a look at the main topic of discussion, that is Amazon S3. In that, we would be also focusing on core concepts like buckets and objects, versioning and cross-region replication, storage classes. Then we would discuss transfer acceleration. I would also give you a use case. And while we go through this session, I would be parallelly giving you demo on required topics. So this could be a long video, guys. So I believe you all have come with some patience for today's session. Having said that, guys, let us just quickly get started. So what are the different AWS storage services? Now, when you talk about storage services, there are quite a few storage services. Let us quickly take a look at those one by one. So Amazon Elastic Block Storage is one of those storage services. What it does is it basically gives you storage in the form of blocks. Each of this block is connected to a particular system or an instance. So in order to access this memory or this storage, you have to make sure that you have an instance connected to it and you can access it through that instance only. So that is one limitation of Elastic Block Storage. Otherwise, it is highly scalable. You can kind of detach, attach volumes to your instances at your will, and it is a very good storage service. Having said that, the other storage service is Amazon Elastic File System or Amazon EFS. Now, this again works on a similar mechanism that Amazon EBS works on, but the difference is it is a shareable or shared file system. Hence, it is not attached to a particular system or an operating system. Then you have Amazon S3 Glacier, which again is a storage system or a service which basically lets you store archival data. Now, what do I mean by this? Well, there is certain data that you would not want to retrieve or use on daily basis or on frequent basis. In that case, you can actually go ahead and put your data in a service like Glacier, because what it does is it basically locks in your data for a certain while during which you cannot access it. Once you've cleared that duration, you are free to access this data. But the other issue is it takes or gives you high amount of latency. That means you cannot access this data in real time or right away. It takes a while to retrieve this data. So why should you store your data at a place or in a storage like Amazon S3 Glacier? Well, the benefit of this storage is it is very cheap, or it is more affordable when you compare it with S3. And the fact that it has high latency, that is the reason it is cheap. What kind of data can you store here? Say, for example, the data that you might not require every day. If you talk about Indian systems or Indian hospitals, we normally have our birth certificates that are delivered by hospitals to us once a baby takes birth. So what happens is once you get this so-called birth certificate, it is not every day that you're going to go to the hospital and request for a new birth certificate. But the hospital still has to maintain a copy of your birth certificate. That is, in case if you need to get this document, probably they can give it to you. So that is why this is some data which is important, but it is not needed every day. So that kind of data can be stored in Amazon S3 Glacier. I believe I've made my point. I've gone a little vague or out of the way to discuss this topic, but I hope we are on the same line. Having said that, guys, the other storage systems are AWS Storage Gateway, which basically forms a gateway between two different platforms. Say, for example, my data lies on my on-premise architecture and I need to move it to Amazon Storage Services. So what I can do is I can have this storage gateway that lets me move my data from that environment to this environment. So in simple words, it acts as a middle layer or a gateway for storing data or for moving data. Then you have Amazon S3 Storage. Before that, I would also like to mention a couple of other services which are not there on the screen. Say, for example, you have your Snowball, which actually lets you move your data physically. I mean, you would be having a device or a system in which you would kind of copy your data, move to the desired destination, and then paste it there. But this happens physically. In case if you want to move large amount of data, then you have other storage service by AWS called as Snowmobile, which is a moving data center which works on the similar principles. You copy your data from your existing environment into the data center. It is physically transferred to the main location, and from there you can move your data to the data center where you are planning to move it. And this might take 5 to 7 working days depending upon the location where you are planning to move the data, and a lot of other policies come into picture as well. So this was about the other storage services that AWS has to offer. There are a couple of other storage services that AWS still offers, and I haven't discussed those. but you are free to visit Amazon's official channel to know more about those. As far as today's topic is concerned, our main focus would be on S3 storage. So let us just move further and try to understand what the storage exactly is. So guys, when you talk about S3, now it is a simple storage service which is simple or easier to use in real sense. It lets you store and retrieve data which can be in any amount, which can be of any type, and you can move it from anywhere using the web or internet. So it is called as storage service of the internet. What are the features of this particular service? It is highly durable, guys. Now, why do I call it durable? It provides you durability of 99.999999, some 11.9. Now, when you talk about that amount of durability, it is understandable how durable this service is. What makes it this durable? It uses a method of checksum where it constantly uses checksums to analyze whether your data was corrupted at a particular point. And if yes, that is rectified right away. And that is why this service is so durable. Then it is highly flexible as well. As I've already mentioned, S3 is a very simple service, and the fact that you can store any kind of data, you can store it in any region or any available region is what I would mean by the sentence. It makes it highly flexible to store the data in this particular service. And the fact that you can use so many APIs, you can kind of secure this data in so many ways, and it is so affordable. It meets different kinds of needs, thus making it so flexible. Available. Is it available? Yes, definitely it is very much available. As we move into the demo part, I would be showing you which regions basically let you create these kind of storages and how can you move and store data in different regions as well. So if you talk about availability, yes, it is available in different regions, and the fact that it is so affordable, making it available becomes all the more easy. Cost efficient, yes. Now to start with, we normally do not get anything for free in life, but if you talk about S3 storage, AWS has a free tier which lets you use AWS services for free for 1 complete year. But this happens in certain limits. Now, when you talk about S3, you can store 5 GB of data for free, at least to get started or get used to the service. I believe that is more than enough. And what it also does is it lets you have somewhere around 20,000 get requests and somewhere around 2,000 put requests as well. So these are something that let you store and retrieve data. Apart from that, you can move in 15 GB of data every month outside of your S3 service as well. So if you're getting this much for free, it is definitely very much affordable. Also, it charges you on pay-as-you-go model. Now, what do I mean by this? Well, when I say pay-as-you-go model, what we do here is we pay only for the time duration that we use this service for, and only for the capacity that we use this service for. So that is why as you move along, if you need more services, you would be charged more. If you do not need more amount of the service, you won't be charged to that greater extent. So is it cost efficient? Definitely it is. Scalable? Yes. That is the best thing about AWS services. Most of them are scalable. I mean, you can store huge amount of data, you can process huge amount of data, you can acquire huge amount of data. If it is scalability that is your concern, you do not have to worry about it here, because even this service readily scales to the increasing data that you need to store. And the fact that it is pay-as-you-go model, you do not have to worry about the cost factor as well. Is it secure? Definitely it is. Now you can encrypt your data. You have various bucket policies as well that let you decide who gets to access your data, who gets to write data, who gets to read data. And when I said you can encrypt your data, you can actually go ahead and encrypt your data both on client side and on your server side as well. So is it secure? I believe that answers the question on its own. So guys, these were some of the features of Amazon S3. So guys, now let us try to understand how does S3 storage actually work. Now it works with a concept of objects and buckets. Now bucket, you can think of it as a container, whereas an object is a file that you store in your container. These can be thought of as AWS S3 resources. Now when I say an object, basically object is your data file. I've already mentioned that you can store any kind of data, whether it's your image, whether it's your files, docs, whatever it is. These are nothing but your data, and this data comes with metadata. When I say an object, it is combination of your data plus some metadata or information about that data. What kind of information? Basically, you have the key, that is the name of the file that you use, and version ID is something that tells you which version are you using. As we discuss versioning, probably I would talk about version ID a little more. But meanwhile, I believe this is more than enough. Your objects are nothing but your files with the required metadata. And the buckets, as I've already mentioned, these are nothing but containers that hold your data. So how does it work, guys? Well, what happens is basically you go ahead and create buckets in regions and you store your data in those regions. How do you decide what buckets to use, what regions to use, where to create the bucket and all those things? Well, it depends on quite a few factors. When I say I have to create a bucket, I need to decide what region would be more accessible to my customers or to my users, and how much cost does that region charge me, because depending upon the region your cost might vary. So that is one factor that you need to consider. And latency as well. I mean, if you put your data in an S3 bucket that is far away from you, fetching it might cause high amount of latency as well. So once you consider these factors, you can create a bucket and you just store your objects. When I said version ID key, actually your system automatically generates these features for you. So for you, it is very simple. Create a bucket, pick up your object, put it in it, or just go ahead and retrieve the data from the bucket whenever you want to. So I believe this gives you some picture about what S3 is. Now, let me quickly switch into the demo part and let me give you a quick idea or quick demo as to how S3 works so that it is not too much theory for you people. So guys, what I've done is I've actually gone ahead and I've switched into my Amazon Management Console. Now, as I've already mentioned, AWS gives you a free tier for which you can use AWS services for free for 1 complete year. Mine is not a free tier account, but yeah, if you are a starter, you can create a fresh account. You just have to go ahead and give in certain details. All you do is you just go to your web browser, search for AWS free tier and sign in with the required details. They would ask you for your credit card or your debit card details. Enter any one of those for the verification purpose. And you can actually go ahead and set up alarms as well, which would tell you as in, okay, this is the limit to which you have used the services. And that way you won't be charged for access of data usage or service usage. Having said that, guys, this is about creating an account. I believe it is fairly simple. You can create an account. Once you create an account, guys, this is the console that would be available to you. What you have to do is you have to go ahead and search for Amazon S3. If you search S3 here, it would kind of redirect you to that service page. So guys, as you can see, this is the company's account probably. Somebody uses it in the company and they have their buckets that are already created. Let's not get there. Let us just go ahead and create our own bucket and just go ahead and put in some data into it. It is fairly simple, guys. I've already mentioned it is very simple to use kind of service. All I have to do is click on create bucket and enter in name for some bucket. Guys, now this name is unique. It is globally unique. Once you enter a name for the bucket, you cannot use the same name for some other bucket. So make sure you put in valid name. And the fact that I use the term global, something reminded me to be explained of. So guys, as you can see, if I go back here, I want you to notice this part. So guys, when you are into the management console or you open any service, by default, the region is North Virginia. Okay, so if I create a resource, it would go to this region. But when I select the service that is S3, you can see that this region automatically goes to global. That means it is a global service. It does not mean that you cannot create bucket in particular regions. You can do that, but this service is global is what they're trying to say. So let us just go ahead and create the bucket. Let us call it today's demo. You cannot use caps, guys. You cannot use some symbols. So you have to follow the naming convention as well. Today's demo. Sorry, I'm very bad at naming conventions, guys. I hope it is okay. Let it be in US East. You can choose other regions as well, guys, but for now, let it be whatever it is. So I'm gonna stick to North Virginia. There are 76 buckets that are being used. Let us just say next. Bucket name already exists. So this was already taken, guys. See, so you cannot use it. Let's call it, say, Ramos bucket 13113. Okay, do you want to keep all the versions of the object? We will talk about what versions are. Okay, guys. Meanwhile, you just bear with me. I'm just going to go ahead and create a bucket. Create a bucket. And there you go, guys. I'm sure Ramos bucket should be here somewhere. Here it is. If I open it, I can just go ahead and create folders inside it, or I can directly upload data. So I say upload, select a file. Let's just randomly select this file. It is Van Rossum, founder of Python, basically. Let's just say next, next, next. And the data is uploaded, guys. You can see the data being uploaded and my file is here for usage. So guys, this is how object and bucket kind of stuff works. You can see that this is the data that I have. If I click on it, I would get all the information. What is the key? What is the version value? For now, let's not discuss version, but this is the key or the name of the file that I've uploaded. So it is fairly clear, right guys? So let us just quickly switch back to the presentation and discuss some other stuff as well. Now guys, another important topic that is to be discussed here is S3 storage classes. Now we've discussed how the data is stored or how buckets and objects work. But apart from that, we need to discuss some other pointers as well. As in, how does AWS charge me, or what kind of options do I have when it comes to storing this data? So it provides you with three options guys: standard, infrequent, and glacier. Let me quickly give you an explanation to what do these storage classes mean and what all they offer to us. When I say standard, it is the standard storage which gives you low latency. So in case if there is some data that needs to be fetched right away, you can actually go ahead and use standard storage. Say for example, I wish to go to a hospital for certain kind of checkup. So in that case, my details would be entered in. And the fact that I'm getting myself checked in a hospital or diagnosed in the hospital, what happens is this data is important, and if it is needed right away, it should be available. So this kind of data can be stored in your standard storage where the latency is very less. The next we have infrequent access. Now what do I mean by that? Now in this case, my latency period has to be low because I'm talking about data that I would actually need anytime if I want to. But when I store this data for a little longer duration, all I want is this data to be retrieved quickly. Say for example, I get a particular report or a particular test done. So in that case, I would actually go ahead and submit my details, or say for example my blood samples, but I need this information maybe after 3 days. So what happens is, in this scenario, I would want to store this data for a longer term, but the retrieval should be faster here. In the first case, that was not the case. If I needed that data right away, and if I wanted it to be stored for a very short duration, I would use standard. But if I want to store it for a longer duration and I want a quick retrieval, in that case, I would be using infrequent access. And finally, I have Glacier. We have already discussed this. Here, your retrieval speed is low and the data needs to be put in for a longer duration. And that is why it is more affordable. If you take a look at the stats that are there in the image above, you can see that minimum storage duration is nothing for standard. For infrequent, it is 30 days. And for Glacier, it is 90 days. If you take a look at latency, it is milliseconds, and 4 hours. So that itself explains a lot of stuff here. So what are storage classes and what do they do? I believe some idea is clear to you people. Again, as we move into the demo part, we would be discussing this part as well. And we would also discuss expiration and transition that supports these terms. But let us move further and try to understand something else first. Versioning and cross-region replication. Now guys, when I say versioning, I'm actually talking about keeping multiple copies of my data. Now, why do I need versioning and why do I need multiple copies of my data? I've already mentioned that AWS S3 is highly durable and secure. How is that? Because you can fix the errors that are there, and you can also have multiple copies of your data. You can replicate your data. So in case if your data center goes down, a copy of it is mentioned or maintained somewhere else as well. How is this done? By creating multiple versions of your data. Say for example, an image, I store it in my S3 bucket. What happens here is there is key, the name is same, image, and version is some 33333, right? Now take a look at the other image. If I actually go ahead and create a copy of the first image, its name would remain same, but its version would be different. So suppose both of these images, they reside in one bucket. What these images are doing is they are having multiple copies or giving me multiple copies. Now, in case of image, not a lot would change, but if I have doc files or data files, in that case, versioning becomes very important, because if I make changes to particular data, if I delete a particular file, a backup should always be there with me. And this is where versioning becomes very, very important. What are the features of versioning? By default, versioning is disabled when you say, or when you talk about S3, you have to go ahead and enable this versioning. It prevents overwriting or accidental deletion. We've already discussed that. You get non-concurrent version by specifying version ID as well. What do I mean by this? That means if I actually go ahead and create one more copy of the data and store it, so the latest copy would be available on top. But I can go to the versions option, put in the ID that belong to the previous version, and I can fetch that version as well. So what is cross-region replication? Now, guys, we've discussed versioning. Let us talk about another important topic, that is cross-region replication. Now, when you talk about S3, basically what happens is you create a bucket in a region and you store data in that region. But what if I want to move my data from one region or from one bucket in one region to other bucket in other region? Can we do that? Yes, cross-region replications let you do that. So what you do is you basically go ahead and create a bucket in one region, you create another bucket in another region, and probably you give access to the first bucket to move data from itself to the other bucket. So this was about versioning, this was about cross-region replication, and I believe we've also talked about storage classes. Let me quickly switch into the demo part and discuss these topics to little more detail. So guys, moving back, what we have done is we've actually gone ahead and created a bucket already, right? When you talk about what was the name of the bucket, it was Remos, if I'm not wrong. Yep. So if you click on the bucket name, Remos, what it does is it basically shows you these details, guys. Now you can see that your versioning is disabled, right? So if I click on it, I can actually come to this page and I can say enable versioning. That means a copy of the data that I create is always maintained. So if I go to Remos bucket, or I just move back, okay, this interface can be a little irritating at times. You have to move back and forth every now and then. So guys, there is a file which we have stored. You can just take a look at this date first. It says that it is 2:35. That was the time when the object was moved. Let me just say that upload the same file. This was the file we uploaded. I say next, 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 upload. So guys, this file is getting uploaded. You can see the name of the file is still same. We have only one file here. Why? Because it was recently modified at 245. From 225 to 235, it got changed to 245. So it is fairly clear, guys, what is happening here. Your data is getting modified. And if you wonder as in what happened to the previous version, don't worry. If you click on this show option, you can see that both of your versions are still here, guys. This was created at 235 and at 245. So this way, data replication and data security works much better. So you can secure your data, you can replicate your data. So in case if you lose your data, you always have the previous versions to deal with. How does the previous version thing works? So guys, what happens is if I delete this file, what Amazon S3 would do is it would set a marker on top of this file. And once I delete it, if I search for that ID won't be available. Why? Because the marker has switched to the next ID now. So whatever I want to do, I can do with the next ID as well. So guys, one more thing that you also need to understand here is what happens to the file. I mean, I've actually deleted a file, but a version is there with me. Can I delete all the versions? Yes, you can specify the ID and you can delete all the versions that you want. You can also do one thing, that is you can set a particular life cycle for your files. When I say life cycle, you can decide as in, okay, now I have a file in standard storage. We've discussed these storages, right? Standard storage, infrequent, and Glacier. What you can do with your lifecycle management is you can decide as in, okay, for a particular time duration, I want this file to stay in standard. Maybe after a while, I want to move it to infrequent, and after a while, I want to move it to Glacier. Say, for example, there is certain data which was very important for me, but having used that data, I don't want to use it for next few months. So in that case, I can move to the substitutes or to the other storage classes where probably I won't be needing to use that data for a longer while. And doing that, I won't be paying for this data as I used to pay for the standard, because standard is the costliest of the three. So let us quickly see, can we do that, or how does it work at least? If I just go back, this is my file. I can actually just go ahead and switch to management. In that, I have the option of life cycle. If I click here, there is no life cycle. Add a life cycle. You can add a life cycle rule as well, guys. New, let me call it new, and let me say next. It asks me what do I want to do. You can add rules in lifecycle configuration to tell Amazon S3 to transition objects to another storage class. There are pre-request fees when using lifecycle to transition data to any other S3 or S3 Glacier storage. So which version do I wish to use? Current, I can say yes. Add transition, and I can select transition to this tier. When? After 30 days. And if I say next, it would agree. Expiration, you can select other policies as well. So guys, when I say transition, first thing what it does is it tells me what time to transition to which storage class. And expiration, it tells me when does this expire. So I can decide when to clean up the objects and when not to. Let's not do that for now. Let's just say next. Next. So guys, what will happen here is after 30 days, my data would move to standard 1A storage. So you can actually go ahead and decide whether you want to move to Glacier. In that dropdown, you had more options as well. I did not show you that, but it is pretty understandable. You can move to Glacier as well. So this is about life cycle, guys. One more thing, you have something called as replication. You can add replication as well if you wish to replicate your data. Cross-region replication. I believe, guys, I do not have access to do that because I'm using someone else's account for now. But let me just give you some idea as to what you can do to replicate your data. You can just go ahead and click on Get Started. So replication, to remind you people, it is nothing but a process of moving your data from bucket in one region to other bucket in some other region. So for that, I need to select a source bucket. So let us just say that this is the bucket that I have. Next. Now, guys, in my case, I haven't created the second bucket. What you can do is you can just go ahead and create one more bucket. Once you create the bucket, you can select the destination bucket. For now, let us just say that this is a bucket that has been created by someone else. I'm not going to transfer data here, but let's just select this for the demo sake. This is the bucket that I have. See, it says that bucket does not have versioning enabled. This is very important point, guys. I showed you how to enable versioning, right? If you select the bucket, there is an option on the right side saying versioning. You can actually go ahead and enable versioning there. So once you enable versioning, you would be able to use this bucket. Do you want to change the storage class for the replicated objects? If you say yes, it would give you the option of selecting what storage class do you want to select, right? If you don't have to. You can say next. You have to enter an IAM role. If you do not have any, you just say create a role and then the rule name. In this case, I do not have any details about this and I don't want to create a role because this account does not belong to me. Sorry for that inconvenience, but you can actually go ahead and select create a role and just say next. And I'm sure that you can actually go ahead and your bucket starts working or your cross-region replication starts working. What happens after that is once you store your object in a particular file, you can actually move that object, not in a particular file, in a particular bucket. You can move that data from that bucket to the other bucket, and a copy of your data is maintained in both the buckets that you use. So this is what cross-region replication is, guys. I believe that we've discussed what are storage classes, we've discussed what is cross-region replication, and we've discussed versioning in general. Let us quickly move back to the presentation and discuss the remaining topics as well. So guys, I've switched into the presentation part. Till time we've discussed how cross-region replication works, we've discussed how versioning works, and we've seen how to carry out that process. The other important topic that we need to focus on is we've known like how to create versions, how to move data from one place to the other. But the thing is, what if I have to move data from a particular location to a location that is very far away from me and still ensure that there is not too much latency in it? Because if you're moving data from one location to a location that is far away from you, it is understandable that it would take a longer while. Why? Because we are moving data from internet. So the amount of data that you move and the further you move, it should take a longer while for that. So how do you solve that problem? You have S3 transfer acceleration. You can do that by using other services as well. We discussed Snowball and Snowmobile as well, but they physically move the data and at times it takes n number of days to move your data. With S3 transfer acceleration, that is not the issue because it moves your data at a very fast pace. So that is a good thing. So how can you move your data at a faster pace? By using S3 transfer acceleration. Now guys, let us first understand what it is exactly. So what it does is it enables fast, easy and secure transfers of files over long distances between your client and S3 bucket. And to do that, it uses a service called as CloudFront and the edge locations it provides you. As I move further, I would be talking about what CloudFront is. Do not worry about it. First, let us take a look at this diagram. So normally, if you are moving your data or directly uploading your data to a bucket that is located at a faraway distance, I mean, suppose I'm a customer and I wish to put my data into an S3 bucket, which is located maybe a continent away from me. So using internet, it might take a longer while. Instead, what I can do is I can use transfer acceleration. So how is it different? Now guys, there is a service called as AWS CloudFront. What it does is it basically lets you cache your data. When I say cache your data, that means you can store your data at a location that is in the interim or that is close to your destination. Now this service is basically used to ensure that data retrieval is fast. Suppose I'm searching for a particular URL. What happens is when I type that URL, a request is sent to the server, it fetches the data and sends it to me. So if it is located at a very far location, it might take long while for me to fetch the data. So what people do is they analyze as in how much requests are coming from a particular location. And if there are frequent and a lot of requests, what they do is they set up an edge location close to that particular region. So you can put your data, you can cache your data on that edge location, and that data can be fetched from that edge location at a faster rate. So this is how edge locations work. What transfer acceleration does is it basically puts in your data at the edge location so that it can be moved to your S3 bucket at a quicker pace. And that is why it is fast. So guys, this was about S3 data acceleration. Let us quickly move into the console part and try to understand how S3 acceleration works. So guys, I've switched into the console. S3 acceleration or data transfer acceleration is a very easy thing to do. I do not remember the bucket name. I think it was Remos something. Okay, if I select this and open it, I can actually go to the properties part. Guys, there are other things that you might want to consider. You can come here and take a look at those as well. For now, I'm just gonna say go ahead and enable transfer acceleration. It is suspended. I can enable it. It gives me the endpoint as well, and I say save. So guys, what this means is if I'm putting my data into this bucket, it would be transferred very quickly, or I can use this bucket to transfer my data at a quicker pace by using data transfer acceleration by S3. Again, guys, I missed out on one important point. The fact that we have been talking about buckets and stuff like that, there is something important that I would like to show to you people. First, let us just go back and disable this part. I do not want it to have the transfer acceleration thing going. I just wanted to show it to you people how it is done. I just say go back to suspended. And one more thing, guys, if you once you actually enable the transfer part and if you upload a file, you can see the difference in the speed. The problem is you need a third-party tool to do that. So you can actually go ahead and download a third-party tool as well. And using that, you can actually go ahead and see how it works. Having said that, I was talking about buckets in general. So let us just go back and go to Remos again. There you go. And I'm gonna copy the ARN. I'll tell you why. I've copied the ARN. Now, when I open this bucket, guys, we have quite a few things. Permissions, I talked about security, right? So you can decide public access as in who gets to access your bucket. So guys, you can actually go ahead and decide who gets to access what kind of buckets. Say for example, here in your block public access, you can decide who gets to access what data publicly. For that, you have access control lists. Using these ACLs, you can actually decide who gets to access how. Other thing you can do is you can just go ahead and create a bucket policy and decide who gets to access your bucket or who gets to put your data, delete your data, and do all these things. Let us just go ahead and create a policy. Now you can write your own policy or you can just use a policy generator, which again is a third-party tool. So I want to create a bucket policy for my S3. So let's just say S3 bucket policy. And what kind of effect I want? I mean, do I want someone to access my system or do I want to deny someone from accessing my system? I can decide that. So let's for now just say that I want to deny someone from doing something. And what I want that someone to do is to deny a particular thing for that person for all the objects. I mean, I do not want that person to access any of the objects that is there. So what I say is star. That means nobody should able to do anything to any of the objects that are there in this bucket. So it says star service Amazon S3. What action I want? I want to prevent someone from deleting an object. There you go. And this is the ARN. That is why I copied it. It should be followed by a / and a star. Add a statement. And I say generate policy. So guys, the policy has been generated. I just have to copy it. If I copy this thing and I go back to the console, if I paste it here, I can say save. It's saved. I'll save it again just to be safe. So guys, we have actually gone ahead and let me just go ahead and again go to Remos. So guys, now there is an object here. Let me just try and delete this object. If I just go to the actions part here, and I say delete, see the file is still here. Is it the other version? No, it's not deleted. See, there's an error here. If I click on it, it says 100% failed. Why? Access denied, because I do not have the access to delete the object right now. Why? Because I've created a bucket policy, guys. So that is what bucket policies and ACLs do. They let you make your objects or your data more secure. And as you saw in the option, there are quite a few options that you have at your disposal, which you can choose from, which you can mix and match and decide as in, okay, this is what I want to do. I want to probably give someone an access to delete a bucket. I want to give someone an access to do this or do that. So guys, this was about S3 data transfer acceleration, and we've also seen how you create a bucket policy, how you attach it to your bucket and stuff like that. Now let me just go back and kind of brush up this session with a use case so that you can probably understand the topics that we've discussed a little more. First, let us go back to the use case, guys. So guys, I've switched into my presentation console again, and we would be discussing IMDb media. Now, for people who watch movies, they might know what IMDb is. It is a website that gives you details about movies. They tell you what are the movies that are nice. If you probably select or type a particular movie name, they would give you details about it, as in who were the actors, how was the movie, how was the review, a short snippet explaining you what the movie is about, its genre and stuff like that. Plus they have their own ratings to kind of gauge in the customers even better, as in IMDb being a popular site, and when they say that this movie is this person good or liked by these many people, people normally believe it. So they have that score as well. So if you talk about a website that basically deals with movies, you understand the number of movies that are released worldwide. And if most of them are present here on IMDb, that means that database is huge. But we are talking about data that is being processed in great numbers, great amounts. I mean, when you talk about the data that is here, what is happening here is you have n number of movies that are being released. So if someone searches for a particular movie, it has to go through the database and that data has to be fetched to him right away. So how do you deal with the latency issue? Well, this would answer a lot of questions, or it would sum up a lot of topics that we've discussed here. Let us go through this use case probably. So what happens here is, in order to get the lowest possible latency, all the possible results for a search are pre-calculated with a document for every combination of letters in the search. What this means is, probably based on the letters, you have a document that is created, and it is traversed in such an order that all the data is scanned letter-wise. When you actually go ahead and put forth a query, what happens is, suppose if there is a 20-character letter or a word that you put in, so there are somewhere around 23 into 1030 combinations that are possible. So your computer has to go through these many combinations. What S3 does is, it basically lets you store the data that IMDb has. And once IMDb has stored that data, they use CloudFront again. We have discussed what CloudFront is. They use CloudFront to store this data to the nearest possible location, so that when a user fetches this data, it is fetched from that location. So what happens is, basically, when these many possibilities or combinations are to be dealt with, it becomes complicated. But in practice, what IMDb does is, it basically uses analytics in such a way that these combinations become lesser. So in order to search for a 20-character letter, they basically have to go through 150000 documents. And because of S3 and CloudFront, you basically can distribute all the data to different edge locations and to buckets within hours. And since we are talking about huge amount of data, it is more than terabytes. It is like hundreds, thousands of terabytes of data. So we can understand how much data are we talking about. And S3 actually features or serves a number of such use cases or requirements. So guys, I believe by now you've understood what S3 is. AWS Glacier, which is a very popular cloud storage service. Let's take a look at today's agenda first. Well, as far as this session goes, first and foremost, I would start by talking about what is AWS Glacier. Then I would talk about its needs, and I would also discuss what are its different features. Finally, I would finish things off with the demo part. I hope this agenda is clear to you guys. So let's not waste any time and jump into the first topic of discussion, that is, what is Glacier? Well, if you talk about Glacier, it is nothing but a highly secure, low cost, and a durable storage. Now, the definition is fairly simple, and these keywords also seem very simple, but they are very important when you talk about it from storage perspective. Now, as we move further, you'd get an exact idea as to what AWS Glacier is. But before that, we need to understand why do we actually need it. Once we answer that question, you'd have all the answers as to what it does and what it is. So when you talk about the need, why do we actually need Glacier? Well, a major reason is cost. If you talk about data storage, it is otherwise costly. What do I mean by otherwise costly? Now you already have services like S3 in the market. S3 is nothing but simple storage service by AWS, which is already affordable and highly durable. But if you're talking about storing data for a very long duration, then S3 might not be a great option. Why is that? Because S3 charges you month-wise. And since you're paying month-wise, if your data is huge, you'd be charged for the data that you might always not want to use. To give you an example, suppose you have data related to medical. Say, for example, you have your birth certificate. Now, how often do you visit a hospital to get your birth certificate? Even if you do, you won't ask them to give you your birth certificate right away. Probably you would fill in some application and then wait for your birth certificate to get generated. So this process might take a longer while. And the other thing is, this is some data that stays with your hospital for as long as they can keep it. So that might be a long duration. So there is data which might be there for a very long duration with you, which you want to keep it, but you may not retrieve or use it every day. In that case, using a service like S3 won't be that efficient because you'd be paying for the data that you're not using regularly and it is still lying somewhere without being used. What if we had a service that actually let us store data for a very long period and did not charge us a lot for that? Wouldn't that be convenient? Now, this is where Glacier comes into picture. It is used to store archival data. That means if I can afford to store the data at a place for a very long time, that means without having to retrieve it again and again, I can actually afford Glacier because it is 10 times, almost 10 times cheaper than what S3 is. And what happens here is there is only one disadvantage with AWS Glacier, and that is your retrieval costs are higher because what Glacier believes in is you write once, you can read it multiple times, but don't ask for retrieval every now and then because we are storing archival data here, and that is why it is more affordable. And what AWS Glacier does is if you do try to retrieve that data, it takes a longer while to retrieve that particular data. And hence we keep the archival data here. So that is why you need Glacier, a durable storage which can provide you with data storage at a low cost and for a very long duration. Let's try to understand some of its features and try to explore Glacier a little more. So if you talk about its features, first and foremost, we have something called as archives. Now, archives are nothing but files that you store on AWS Glacier. So what are those files? It can be your video files, it can be your images, or even your documents. So whatever kind of data it is stored in the form of archives. Now it can be a single file or it can be a collection of files that is zipped together. If you talk about a single file, it actually lets you store a data up to 40 terabytes, which is a huge space if I'm not wrong. I mean, a single file of 40 terabytes, you can store any amount of data in it. So yes, you can store single file, you can store multiple files. You have that option. And all these files, they're stored in the form of archives. The other term is vaults. Now, what do I mean by vaults? Now, think of it as a container where you can actually go ahead and put in your data. If you talk about S3, you have buckets where you put in your data in the form of objects. If you talk about AWS Glacier, you have vaults. And in your vaults, you'd be putting in your archives, which have your archive ID. So once an archive ID is associated with your archive, you can put in the data. And if you put forth certain policies, you cannot make changes to that data. We would get into the details of that part as well. But for now, Vault is nothing but a container where you'd actually go ahead and put in your data. Now, when you talk about putting in your data or your archive files, it actually supports all kinds of files. So think of it as a folder or a container where the files which we discussed in the previous section, all those kinds of files can be saved in here. So what are the other features that we can talk about? Now, when you talk about AWS Glacier, you have various data retrieval features, which are again very important because we are talking about putting in data. So if you're putting in data somewhere and storing it, there has to be a proper way of retrieving your data. As I've already mentioned, the way you retrieve data with AWS Glacier is kind of slower compared to S3. So what AWS Glacier does is it gives you certain limit, as in for a certain limit, you can actually go ahead and retrieve a particular amount of data that you need. And the remaining has to stay in your so-called storage for a longer duration. So it is more of a subscription kind of a thing where you subscribe a particular service for a longer period of time and it becomes more affordable for you. Same is with AWS Glacier as well. So if you do put in a data and if you put it for a longer duration, it would be more affordable for you. But even in that, you have certain limit in which you can actually go ahead and retrieve certain amount of data. Apart from that, if you still have requirements where you have to go ahead and retrieve your data, there are certain conditions that you need to meet, as in how fast do you want to retrieve the data. For that, you have two cases. First one is your expedited retrieval. Here, what happens is you can get your data retrieved at a faster rate in few minutes, but you're charged more for it. You also have your standard or normal retrieval rate where you are charged normally, but then it takes 3 to 5 hours for your data to get retrieved. So that is the difference. If you are actually retrieving data in bulks, it again becomes affordable because you're asking for data in bulk amounts, and then it becomes kind of cheaper, again like the subscription part which I just talked about. You also have something called as Amazon Glacier Select. Now what Glacier Select does is it lets you retrieve data. Now when I say retrieve data, that is what we just discussed, as in there are different ways to retrieve data. But what AWS Glacier does is it actually lets you retrieve relevant data. Suppose you want to process a particular amount of data and you just want certain chunks of data. You can do that by using Amazon Glacier Select as well. Now we have something called as AWS Snowball and Direct Connect as well. Now what these do is they let you integrate much better with the AWS Glacier, and in that way you can actually put in data and also retrieve it with a little more ease. What happens is you have a dedicated network that is established, and it gives you high bandwidth services where you can actually retrieve data faster than your normal services. And this is where Snowball and Direct Connect step in. They let you retrieve data and also they let you connect or form a network that is much better. Vault lock and access control. What vault lock does is, suppose you have to put in particular data. I mentioned in the past or in previous slides that we would be discussing as in how can you lock your data, or what happens in certain cases when you put in your data, whether you can retrieve that immediately or not, or whether it gets freezed or not. So what happens here is when you talk about a vault lock, you're actually going ahead and setting in certain policies. Now there's one more term here saying access control. What access control does is it lets you put in certain rules using which you can decide as in how do you want to access your data or retrieve it. Do you want to lock in certain data for certain period? And that can also be done by using your vault lock. So you can actually go ahead and set in a particular policy that you want to lock this data for this particular period and people can only read it. So that is what the protocol would be, and that is what would be followed. So that is what a vault lock and access control does. It gives you access rights and permissions as in how do you want to access your data. Data durability and reliability. Now this is a very important point. We are talking about archival data. So if you talk about cloud platforms, security becomes an utmost important part because people are normally concerned about it because they have the available data there. So what AWS Glacier does is it gives you a durability of 99.999999999. That is 99.9 times 9% durability, which is a huge amount. And if you talk about storing in your files, what AWS does is it creates multiple replicas and stores that at different data stores or different repositories they have. So even if your file gets lost, you always have a backup. And when you talk about this much amount of durability, suppose you have 10,000 files or objects. So the possibility of you losing one of your files is 1 in 10 million years. Now that is a huge duration, isn't it? So yeah, if you talk about durability and reliability, this platform is highly reliable. Vault access policy and inventory. Now, vault access policy, again, it is similar to your access control where you have certain policies you put in for your vault and you can decide, I mean, how do you want to access your data and all those things. If you talk about inventory, think of it as a notebook where you put in all the details, as in what data has been written, what is the data that has been retrieved, what are the vaults that are created, deleted, and all those information that actually gets stored in your inventory. And when you talk about getting this inventory updated, there is certain duration, as in suppose if I create a vault, it takes a certain duration to get that updated, and that happens once during your day. So if you do put in certain information, that gets updated today. If not, it gets updated tomorrow. So these were some of the features. Now let me quickly switch into the demo part. So for that, what I'm going to do is I'm going to go ahead and switch into my AWS console, and we are going to go ahead and take a look at a small demo. So yes, guys, what I've done is I've gone ahead and I've switched into my AWS console. Now this is where we would be taking a look at a simple demo when you talk about Glacier. So for people who are completely new to AWS, let me tell you that what AWS does is it lets you have a free tier account where you can use certain services for free for one complete year. So if you do not have this account, I would suggest that you go to your browser, type AWS free tier, and you would be redirected to a page where you would have to go ahead and create an account. Now that account would ask you for your credit or debit card details. Do not worry, AWS won't charge you anything. That is, if you exceed the limits, then a bill might be generated in your name, but for that you won't be charged. I mean, as long as you stay in the limits prescribed by AWS, you won't be charged. So I would suggest that you do go ahead and create an account if you don't have one. And if you need any more information, you can take a look at the other YouTube videos that we have where we've talked about AWS. In that videos, I've definitely talked about how to create an account. So if you want to go ahead and take a look at that, you can refer those videos as well. Search for any AWS Edureka video and you would have the information for that. Having said that, let's quickly jump into the demo as far as AWS Glacier is concerned. Now, here we have all the services that are made available to us by AWS. If you click on it, you would see that all these services are here. You have different services which you can use from. Right now, I'm going to go ahead and stick to AWS Glacier. Here it is. Yeah, so if you're a first time user, you would be having a fresh page where it would say that get started or create your vault or something like that. So that is what you'd want to click on and you'd be redirected to this page. Since I already have an account and I have some vaults that are created, this is how it looks like. So yep, once you do click on that thing, this is where you'd be redirected. So what we are going to do now is we are going to go ahead and see how can you create a vault by using AWS, that is AWS Glacier in particular. How can you put in files into this vault and how can you delete all the stuff that you've created? It's a fairly simple demo and you should not be having any problems. Now, again, there are two ways to approach the way you store data in AWS Glacier. One is you can use the programmatic way where you can put in or use certain SDKs like Java, .NET. All these are supported by your AWS Glacier. For that, what you'd have to do is you'd have to go ahead and switch into your command line interface, and from there you'd have to programmatically put in your data, remove data, process data, whatever you want to do. You'd have to do that programmatically. Instead, what you can do is you can go ahead and use a third-party tool as well, which I'm going to do in this case. We have a tool called as AWS Fast Glacier, which I'm going to use. And if you need that tool, you can just go ahead and type for AWS Fast Glacier and that tool would be made available to you. You have to download that and click on it twice and the tool gets installed, as simple as that. For the sake of simplicity, I'm going to use that. Don't worry, I would be walking you through all the processes as well, so you can stay tuned to understand how the other process works as well. Well, as far as this demo goes, first we would be creating a vault. And once you create a vault, as I've already mentioned, you need an IAM policy or a user, that is your identity and access management user. What that user does is that gives you access to actually go ahead and put in your data into this particular vault. So for that, let's start by creating a vault first, which is a very easy process. You click on create vault, you get directed to this page. Now in my case, I have this region selected, which was my default region. You might create your vault in other regions as well. To give it a name, let's say new vault, and I say next step. It would ask, do you want to get some notifications? If you enable these, you would have to create an SNS topic. What it does is it lets you get notified on your email, as in this is the data that has been put in or put out of your Glacier. That means it keeps you updated in the form of notifications. In my case, I do not need any right now, so I'm going to say no. So do I want my vault to be in this region? I would say yes. So I say submit and the vault is created. It is as simple as that. So you have a demo vault here. You can go ahead and attach a vault lock to it. You can add tags to make it simpler for you to recognize your data much better. Certain permissions can be granted. You can edit the policy that is already there. You can add a new policy as well. Notifications, you can enable those once you've created your vault as well. And these are some of the details about your vault, as in where it is created and all those things. Having said that, we also need an IAM user now. So why do we need an IAM user? I've already told you, in order to put in the data, you need some user credentials, right? That is what your IAM user would do here. So how do we get there? I come to services, I say IAM. There you go. You can just go ahead and add a sample user. So I say add user. What name should it be given? Let's say new demo user and give it programmatic access for now. What permissions? Now this is important. What kind of access do I want my IAM user to have? Should it be read-only access? Can he or she make changes to it? For that, you can actually go ahead and create a user group to set in certain policies for that particular group access. You can copy permissions that are already there. Suppose you have similar vaults created, similar IAM users created, and you have certain already created rules. You can just replicate those by using this as well. Or you can attach an existing policy directly, which AWS has to offer to you. So I'm going to say attach this for now. And I need full access to my Glacier for now. So let's search for Glacier policies. Here you go. This is Amazon Glacier full access. So I select this. Since it is a simpler demo, my security is not a big concern here. So I can just say give it full access and I create a user. I say create one. There you go, guys. We have a user already. Now, as you can see, we have certain details here, right? My access key ID and my secret access key, using which I'm gonna access my third party tool, which we are going to use right now. So yes, our vault is created and we have an IAM user here. Now let's quickly try to open fast Glacier. I've actually gone ahead and installed it. So do not worry, I would be sharing in the link in the description below so that you people can actually go ahead and download fast Glacier. So stay tuned for that as well. As you can see, I have this session opened here already, but for now it is not giving me any particular option to log in. So I'm just gonna open it again. Yeah, so I believe I haven't logged out of my previous session. Just bear with me, guys. There's some error. Let me just quickly get rid of it first. So guys, what happened was I actually had an account created and that was deleted. So it was throwing in certain cookies and certain errors every now and then. So I just did go ahead and delete that account again and save the changes properly. So once you do install this fast Glacier, you would be redirected to this particular screen, and this is where you log in. Now, in order to access your vault, you need to create an account. So let's go ahead and create a sample account for now. Say sample demo, maybe. Yep. And I need to put in my access key. Now we just created an IAM user, right? So I have the access key and secret access key. So I'm going to copy this, Control C. I'm going to come back here and I'm going to put this ID here. There you go. And my secret access key for that too, I'm going to come here, show, and copy this. And I'm going to paste it here. And I say create a new account. You can encrypt your account. You have an option for that as well. Again, this is a basic demo, so I'm not going to do that. So as you can see, I've logged in. So we had a vault created in this region, US West Oregon, and the name of our vault was New Vault. So you have an access to it. So if you do not have proper access, you won't be able to access this vault and put in any data whatsoever. I can just go ahead and say upload a file here. I can download it, delete it, and create a new folder in which I can put in a file as well. Let's just upload a file for now. So I say upload file. Let's pick some random file and say open. There you go, guys. My file has been uploaded. Now, if I were to download this particular file, it would give me options. Do I want it expedited? Do I want it standard or bulk? And accordingly, the rates would also change. This being a small file, you do not see a change, but if your data is in huge amount, you'd see the difference in the prices as well. As I've already mentioned, estimated time for this thing is 1 to 5 minutes. Standard would take you 3 to 5 hours, and your bulk would take you 5 to 12 hours, but it would be much cheaper. I'm not gonna download anything for now because it's not important. If you want, I can just click on retrieval data, and yes, it would ask me select a folder where you want it to be downloaded. Let's take this folder. It has initiated a task, and whether it gets downloaded or not, it would be updated here. You can actually go ahead and delete your file as well. So it is as simple as that. You just click on it and you say delete, and the file gets deleted. Now guys, when you talk about AWS Glacier, there was one point which I forgot to mention. That is, right now you're talking about archival data only, but there are quite a few services that actually process data in different ways. Now, if you talk about Redshift, now this is where you're processing your big data, right? I mean, whether it's your Redshift or it's your other database or whatever it is from where you want to take in your data. Suppose you have something called as AWS Athena, which is used again for analytics and big data. So if you want to utilize these services, in that case, your archival data might not be that convenient for you to use. But what AWS Glacier is doing is, it is actually making room for that as well. And in near future, you are somebody who is big data or analytical enthusiast, you can actually directly take in your data from your Glacier as well and process it using your Athena and Redshift as well. So yes, in your near future, if you talk about Glacier, it's going to expand and connect to all the services that are there. I discussed about S3 as well. Now, what S3 does is it actually takes in a particular cycle, right? I mean, it stores in your data in the form of objects, and there is a life cycle for your data storage. What people do is, after your S3 data crosses a particular period in your life cycle, and if you still need to store that data, it actually creates a policy using which you can move your data to Glacier, and where you can store that data for a longer duration and at a cheaper price. So this is what your AWS Glacier is, and this is how you actually go ahead and store your data. That was a point which I wanted to mention. And apart from that, there are quite a few other things that you can do with your AWS Glacier. Like, as I've already mentioned, you can actually go ahead and delete your files. You can go ahead and delete your vault as well, but come here. Yes. Once you delete it, it would be eliminated from here as well. you can actually go ahead and move to your AWS console and you can delete your vault from there as well. So if you go to services to Glacier, you have a vault. You can come here and delete your vaults as well. But you cannot just right away go ahead and delete a vault because as I've already mentioned, processing here takes a longer while. And if I try to delete this particular vault, say for example, I try to delete demo vault. Yeah, it's not getting deleted because it believes there is something there in it. So if there was a certain item in it and I deleted that and it did not get reflected right away, for that duration, I won't be able to delete my vault. But once that thing is not here, I can delete this vault right away. So yeah, you can actually go ahead and create vaults. You can put in your data. You can do it by using this, or you can actually refer AWS documentation as well, where there is some code given to you, and using your CLI or your command line interface, you can actually go ahead and process all this data programmatically as well. That would be more better if you want to just stick to AWS and not any third-party tool to do your job for you.
So in this module, we'll be talking of various database options available within AWS, and predominantly in the first part of the session, we'll be talking about RDS, which is a relational database services, and what are the options available within RDS. So RDS supports your most commonly used relational database engines such as Oracle, Microsoft SQL, MySQL, and so on. And then we'll be talking about Amazon Aurora. So Aurora is actually part of RDS portfolio. And the reason it has been cited separately is simply because that it's a homegrown offering from Amazon and they promote it pretty heavily. Then we'll be talking about DynamoDB, which is a NoSQL offering, very similar to MongoDB. And we'll see the implementation, how we can implement NoSQL architectures for our applications. So all of us would know what a database is. It's a collection store wherein you would store the data in structured or unstructured manner. So wherever you store the data in structured manner, you refer them to as relational databases. So types of data services available within AWS, you have RDS, which is relational database service, and it handles structured and tabular data. So it is confined to a schema. So as I said earlier, most commonly used database engines like Oracle, Microsoft SQL, MySQL, they are part of the portfolio. Then you have DynamoDB, which is a NoSQL database offering from Amazon and uses document and key value store. So a very good option to handle the unstructured data, which is a limitation with RDS. Then Elastic Cache, in-memory cache, that you can build rather than storing the results of frequently accessed queries. You would store them in memory as compared to storage. Then Redshift, petabyte scale warehousing solution, again used for data analysis and reporting. Aurora, it should actually be subset of RDS, but since this is a homegrown product and it's fully MySQL compatible, and Amazon claims it is 5 times faster than MySQL and less costly as compared to commercial license of MySQL. There are two ways rather to implement a database service in Amazon. One is the first approach is do-it-yourself approach, wherein you as a customer would be responsible for everything. So you'll be spinning up a EC2 instance, you would install the database software, or you can directly purchase a AMI from the marketplace. And you as the customer, you are responsible to manage the entire database operations. That would include backups, patching up, replication, and so on. So that is the do-it-yourself approach. The second approach is by picking up a managed service. So the illustration that you see is a representation of your on-prem database or do-it-yourself, wherein you are responsible from bottom to the top, from power, cooling, racks, server maintenance, operating system, DB, software patches, high availability, setting up a cluster or replication, scaling, and app optimization. Then extension of do-it-yourself, again in the cloud environment, the lower 4 components, which is till the OS level, is managed by the provider, and you as a customer are responsible everything that you deploy on the operating system. So again, a lot of overheads come or fall into customer's kitty. With respect to managed databases, as a customer, you are only responsible for optimization of your app. Rest of the activities are managed and controlled by the service provider. So that can offload a great deal of overhead because managing data tier is pretty administrative overhead. So in a managed database service, activities like backups, replication, failover, all these things would be managed by the service provider. But again, these are configuration parameters that you will have to ensure that you set them right. So we'll start off with RDS. So RDS is a relational database management system which manages relational database for users. So relational databases data is maintained in tables, and those tables can have complex joins and relationships. So with RDS, you essentially select an instance of your choice, wherein cost is a factor here, and you can either bring in your own license or have the license bundled along with the service. So if you opt in for that, your Amazon would be managing all the DBA activities for you. And then with respect to taking backups, again, the service provider, based on the schedule that you define, your backups would be done in form of snapshots. So you could take backups either on an automated fashion, just set up a dual on the console, or you could manually take them as well. Then there's a concept in order to provide high availability and durability at the data layer, which we refer to as multi-AZ deployments, which is multiple availability zone deployments. And RDS database services, they are pretty feature rich and very commonly used in transactional systems. So a couple of use cases would be e-commerce sites, gaming applications. A couple of RDS benefits, pretty simple and fast. We'll see how easy it is to set up the service. And with respect to scalability, you can scale up the service on the fly. Most commonly, database engines are available under RDS. You pay only for what you use. This is common across all these services. Then admin activities, patching, backing, replication, failovers, they're handled by AWS. So on the screen that you see is various database engines that are available within RDS service: Oracle, Microsoft, MySQL, MariaDB, Postgres, and Aurora. So let me log into the console. So again, RDS is a region-specific service. So make sure you select the right region in which you want to provision the service. So you have multiple options available, the variety of database available within RDS portfolio. So what I want to demonstrate here is that you can bring in your own license, or you can either bundle the license along with the instance. So you may want to check out on whether for a specific edition of RDS engine that you're looking at, what are the options available, whether you can bring in your own license or not. So in this case, you have both the options, but I've seen certain versions wherein you'll have to bring in your own license. So it is always a good idea to check that. So with respect to number of schemas that you can build on top of each database engine, I believe this is a native feature that is extended by the engine itself. So with Aurora, you have no limits. Likewise for MariaDB and MySQL. For Oracle, you can have one database per instance with no limit in number of schemas. With SQL Server, you can have 30 databases per instance. And these are the major and minor versions of each database engine. So you may want to check up with the, let's say you're looking out for a specific major or a minor version. It's always a good idea to check it on the Amazon portal. So within RDS, the instances, they are generally referred to as DB instances, and essentially very synonymous to EC2 instances. And they're defined by the compute and memory capacity and the database instance class. So again, it is synonymous to various EC2 instance types. So not all the instance types would be supported because databases are storage intensive. So you may want to pick up an appropriate database instance. So by default, you can run 40 RDS instances within your account. So for databases, again, there are multiple classes: standard, memory optimized, burstable performance, and essentially storage forms it's one of the essential components. You have magnetic, general purpose, and provisioned IOPS type of EBS storage available. So it is always recommended that for database workloads, opt in for provisioned IOPS because that gives you dedicated performance. So there's a concept of multi-AZ deployments within RDS. So in case of multi-AZ deployments, what happens is that instead of provisioning one instance, Amazon would provision 2 database instances for you, and they are provisioned in separate availability zones. So take a look at this architectural representation, and in this case, we notice that we're using a RDS service regardless of whatever database engine it is. So rather than deploying one, it deploys 2 instances in 2 different availability zones. So one is dedicated as master and the second one is as slave. So our application services still talk to the master database service, and in the background, there's a synchronous replication between your master and slave. So this is synchronous replication. So both the databases would be similar at a given point of time. So any commit failures to your secondary would also cause the rollback at the master instance as well. So these are in synchronous replication. So the idea here is that you have two database instances that are spread across two availability zones. So in the extreme case of availability zone going down, let's say this was to go down, the connections can roll back to the slave server. So the way it has been implemented, so your app connects to the database service with a DNS endpoint. So again, for the app servers, they are distributed. So in a real-time scenario, the service generates a DNS endpoint, and that DNS endpoint points to your master. So I'll just change this representation. So this is the DNS endpoint, and it points to your master. So in case something happens to your RDS master, this connection is flipped to the standby instance, thereby leaving zero downtime for your applications. So this is a manipulation, custom implementation from Amazon, wherein this failover is due to changing of DNS pointers from master to slave. And we know that there is synchronous replication across these two master and standby or slave instance. So both the instances would be in the same state. Also, with this approach, your backups are taken against your standby instance. So when you perform your backups, it does lead to degradation in performance if you were to take it directly from your primary instance. So backups are taken from the standby instance in form of snapshots, and they eventually go to S3 storage service, which is highly available and durable. So a couple of failover scenarios. If your primary database instance fails for any reason, your compute resource or database instance fails, availability zone goes down. You want to do patching, which calls for a reboot. So again, it renders your primary database as unavailable. And lastly, if you want to change the instance type, so probably you may want to upgrade or downsize your instance. So multi-AZ, I expect at least a couple of questions from examination perspective. So instead of one, it deploys two into availability zones. Backing, patching, and replication is all Amazon's responsibility in this case. Next, various database engines support the concept of read replicas as well. So read replicas, as you see in the illustration, you have two copies. One is your master and the second one is read replica. So this could actually be something like this, your master and slave. So this could be multi-AZ kind of configuration out here. And then you are creating read replicas of your master instance. So these are asynchronous copies of master. So there's a time lag between master and replicas. So these are generally used wherein to offset additional or excessive read traffic on your master database instance. So they are read-only databases. They are asynchronous. There is a time lag between your master database and your read replicas. So there are a couple of use cases. Principal one being that you want to offset excessive read traffic from your master database. Secondly, a lot of companies use smaller or medium mid-sized organizations. They use read replicas, let's say, for the analytical purposes. So rather than querying your master database, you can query your read replicas directly. So kind of mini warehouse only for the contents that are available at the read replica database level. Then with respect to backups during the configuration phase, you can set up or rather first schedule at what time, at what frequency you want to backups to be taken, define the schedule. And then you also get to define the backup retention period. So the retention period can be set from 1 to 35 days. You can also create manual backups. So the difference between automatic and manual backups would be, so let's say I was to delete my RDS instance. In that case, all the automated backups would go away. Whereas manual backups is up to us on how long we want to retain them. Then with respect to cost of RDS, again, based on instance class, cost of license, storage being used, IO requests, and data transfer in and out of your database instance on internet. So this is not likely to be the case in many scenarios. So let's provision a RDS instance. We'll select MySQL RDS engine. Since Aurora is fully MySQL compatible, again, it wants you to try out Aurora. And additionally, it wants you to specify whether this is for dev test or prod environments. So with prod environments, you'll get a multi-AZ and provisioned IOPS storage for high availability and consistent performance. So the license model will use general purpose and we'll select the default engine version. Then various database instance classes. So again, it boils down to the hardware components, CPUs and memory. Then you have options of multi-AZ. So in this case, for our demo, we'll not select a multi-AZ deployment, we'll do a single AZ deployment. Then for storage type, when it is recommended for production, you always go for provision DevOps. We'll select general purpose for the demo. So this gives you a estimation of monthly cost associated with the instance. This is the DB identifier. You could have multiple database instances running in the AWS environment. So this is more like an identifier. So this is where you get to specify which VPC you want to provision. So if you have built in your own VPC, you can select the same. So in our case, we have two options. So I'll be using default VPC. Then you have subnet options. So subnet here actually refers to which availability zones that you want to use for provisioning of your database instances. Then with respect to security, whether you want to make your database service publicly accessible, 9 times out of 10 would be no. We'll allow the service to create a new security group for us. So once the service has been provisioned, we'll go ahead and make the changes to the security group. Give the database a name. So we can enable encryption, but the type of instance that we have selected does not support the storage encryption. So this is where you specify backups. So 0 days means no backups, and the maximum duration is 35 days. So we'll keep it 1. You get to define the backup window. So you can specify the start time and the duration. With respect to monitoring, there are two monitoring options. One is basic and one is enhanced, or sometimes it is referred to as detailed. So enhanced monitoring is chargeable, whereas if you opt in for basic, that is free. So if we say disable, it would mean basic monitoring. Then you can push your logs to CloudWatch, which is the monitoring service, and perform analysis on those logs. Then you have auto miner version upgrade. Practically, you may want to disable it because you may want to test it in lower environments first. So as a customer, you get to opt out of the version upgrade part. So you can test out the version upgrades in your lower environments and then apply the same. Next step is to create the database. So once RDS has been provisioned, we can use any SQL client application to connect to our database service. So the service would generate, as I said, a DNS endpoint that we'll be using within our applications to connect to this database instance. You see various metrics that are available from CloudWatch for this specific database instance that we have provisioned. Under the details, these are the configuration parameters that we supplied during the provisioning process. And the endpoint would include the DNS or the FQDN that is assigned to this database instance. The database instance that we have actually selected is actually pretty low on resources. So that's the reason it takes a bit of time. So to connect to this RDS, in our case, MySQL, we'll connect it in the same way we connect to a traditional on-prem data center, that is either via a SQL client or command line. So the only limitation with RDS would be that it does not allow you the access of the underlying operating system on top of which this database engine is installed. So if it's Linux, you cannot get the SSH access of the EC2 instance. If it is Windows, you will not get the Windows console access. That's simply because the service is managed. So if your need is access at the operating system level, then RDS is not an option for you. So the instance has been created. It's actually in the backup process. So we can go to snapshots and we'll see it would be in the process of creating the backup of the instance. This is the DNS endpoint it has generated for this database instance, and you will be using this as host information in your SQL clients, and you'll be able to connect to your database service as in case of traditional environments. So from the console, you can stop, reboot, or delete. Then if you want to take manual backups, just go ahead and hit on take snapshots. So this would create manual snapshot. One of the attributes of snapshots would indicate whether it is automated or manual. Then you can create read replicas out of this instance, specify the source, specify the read replica identifier. So again, read replica would also generate DNS endpoint. So you'll have to code your application in such a way that traffic gets redirected to read replicas and write traffic to your master database. So as in EC2, we had multiple purchasing options. So if you need this database instance on a continual basis, you can go ahead and reserve the instance as well. So I've seen how do we create an RDS instance. Interacting with RDS instance would be pretty similar to the one that we do in traditional environments. So you can create, read, write operations in a similar fashion. Aurora specifically has been highlighted as homegrown solution from Amazon, and they publicize it pretty heavily. So it is fully MySQL compatible, and Amazon claims it's 5 times fast performing than MySQL. It also supports the concept of read replicas, and to an extent, you can have cross-region replicas. So let's say your application caters to multiple users spread across multiple regions. So you're going to have a master in one region, read replicas across multiple regions. So if the read traffic is more, your request can always be served by the read replicas, which are at some time lag from your master instance. So again, since the service is fully managed and you have again the concept of multiple AZs applicable to Aurora, from the storage perspective, the data is replicated to 6 storage nodes allocated in 3 zones in parallel. So whenever things are happening in parallel, your operations would be much faster. And then backups again go to S3 storage service. So this slide highlights the input-output traffic patterns in Aurora, wherein it goes to the first in-memory queue on your storage node, and then it is carried to the sort group and subsequently applied. With respect to recovery, Aurora is pretty much faster as compared to traditional databases, wherein the way you apply your logs in traditional environments versus the way the logs are being applied in Aurora. So since the operations are parallel distributed, you can recover very quickly from a outage in case your Aurora was to go down. So that concludes working within RDS. The next part of the service that we'll be talking is DynamoDB. So DynamoDB is again fully managed NoSQL database service from Amazon. So again, this is a homegrown service from Amazon. So it's a NoSQL offering. So in many ways, it is similar to MongoDB, but as I said, it's a homegrown AWS solution, and it is schemaless and uses a document store and a key value store. As a customer, you only get to specify the throughput capacity, and DynamoDB does the rest. So there's no selection of instances and what type of instances, compute capacity. All what you specify is what is the throughput that you need, which is read capacity units and write capacity units. So on the screen, you see difference between SQL and NoSQL databases, or relational or non-relational databases. So SQL solutions are very good for transactional systems, good for ad hoc queries, data warehousing. NoSQL offerings are a better fit, wherein you are expecting large, huge amount of workloads. You're capturing terabytes of data. So that's kind of a limitation with RDS, that they cannot scale beyond a point. So web scale applications, they are well suited for. With respect to data models, your SQL offerings or your RDS offerings, they work on well-defined schemas where you put your data in tables, rows, and columns, and those tables can have relationship between them. So there's an advantage to it. You get a lot of feature-rich information, whereas the disadvantage is that you cannot, once you have defined the schema, you can change it, but it's ask a DBA, it's administrative nightmare. Whereas with NoSQL offerings, you can have structured, semi-structured, and it's not confined to a schema. So you can change the schema on the fly. With respect to access, you will be using SQL for RDS and for NoSQL console, CLI, or your SDKs. Then with respect to scaling, RDS supports concept of vertical scaling, wherein you can add more hardware resources to your existing compute resources, whereas NoSQL offers horizontal scaling. So that's where it can consume large amounts of data. So in the DynamoDB analogy, each record is referred to as an item, and you can perform various DB operations, create, insert, update, delete. They are performed at the table level using appropriate API, and the data in the background is stored on SSD drives. So the structure wherein you get to specify the primary key, and you could set up a composite key, which is a combination of your partition key and sort key. And then the schema that you see here, book ID, then per item basis, you can alter the schema. So for example, for this product ID, 3 items out here, and I could add another column to it. So which is actually absolutely not possible in relational databases. So how do we interact with AWS from the console or from the CLI? These are the specific command sets: create table, describe, update, delete, list, describe, limit, and we'll see them in the console. So what you see on the screen is various operations with respect to creating, reading, updating, and deleting data from DynamoDB tables. Then let's say if you want to replicate data from one region to another, you can use DynamoDB streams. So a good feature to have some kind of redundancy in place wherein you can use DynamoDB streams to replicate data from one table to another table, which is in other region. So with respect to consistency, there are two terms that we should be aware of. First one is eventual consistency, and the second one is strong consistency. So whenever you add data to your DynamoDB table, it takes a bit of time to get replicated. So for a fraction of a second, if you try to read the data, you might not get the data was updated very, very recently. So I'm talking about a fraction of a second. So this is eventual consistency. However, you can enforce strong consistency as well, wherein the service would return the response with most up-to-date data. So depending upon your application, if you can afford eventual consistency model, you can do that. Else, if you want data to be replicated and acknowledged to the application across all the AZs, you'll go for strong consistency. Customer, you only get to define the throughput, which is the number of read units or write units. You can actually track that down on the console, whether depending upon the consistency model, whether it is eventual or strong. You can calculate the number of read capacity units or write capacity units that you would be using. And there's a formula of calculating the number of read units or write units that you would be consuming. So again, that would depend on which consistency model that you have created. So write is pretty simple. It is 1 kilobyte for an item. Whereas in the case of eventual consistency, you get double the number of read units, whereas for calculating read units for strong consistency, it is reduced to half. So a couple of benefits of DynamoDB, it's pretty fast and consistent performance designed for web scale applications. Service is fully managed, so you do not have to really do anything at the database layer. You get to define the levels of access, goes without saying highly scalable. You can specify the number of read and write capacity units, and you can also set up auto scaling in DynamoDB. So let's say you are about to max out on your read capacity units, you can put an auto scaling policy in place wherein it would increase your read capacity units, and likewise for write capacity units. It supports concept of event-driven programming. So in RDS, we have triggers. So in this case, we can use another AWS service, which is Lambda. So that would help you achieve event-driven programming. A use case for DynamoDB, that you have an application that renders content in multiple languages and you are storing 31 billion items or 31 billion records in DynamoDB table, and customers actually learning in their preferred language. So imagine the scale at which the service works. So from implementation standpoint, you create tables, you can add and query items, and you can monitor and manage the tables using the CloudWatch service. So going to the DynamoDB console, and the service is region specific. So make sure you're in the right region. So what you get to do is you can create tables. So there's an excellent tutorial for DynamoDB on how to create and how to set your partition key along with the sort key. So you're trying to build up a music search application, and you'll be storing your music data in DynamoDB, and give it a name, set the partition key, which is the name of the artist, and specify the sort key in this case. So it's up to us whether we want to use a composite key or not. And in this case, I'll use song title as the sort key. So for read write capacities, if you're practicing it out, you can select provision, or else you can, so we'll select provision. And in this case, auto scaling has been applied to DynamoDB recently, wherein in this case, we have specified 5 read capacities and 5 write capacities. So under items is synonymous to records in your RDS. So you can add items to your table that we just created. So artist, let's say a song title, give it some name. Let's say I want to add another column for this item, which is year of publication. So let's say 1980. So I modified the schema on the fly for this specific item. Whereas in relational databases, it is next to impossible. So it takes a lot of work to alter the schema. So this is the benefit that you get with offerings like NoSQL. Then with respect to fetching the data from the table, you can perform either scan or query. Query is more optimized method, whereas scan, let's say if there are millions and millions of items, it goes through every item by item. So that's a pretty slow process. Query is more optimized. So you'll get based on whatever filters you have specified in the query. So in the second part, what I'll do is I'll upload data from the CLI. So I'm creating the access keys for this user, and let me download the CSV file. So I'm creating another table. So I'm passing the secret access key and the secret access key. So I'll be pushing this JSON to the table that we just created. So unprocessed items is null. That means it has uploaded the content. If I go ahead and take a look at the item list, so these were the contents in that JSON. So we saw these actions in one of the previous slides: put request, the item details. This approach is normally used for pushing mass data into DynamoDB tables.
Amazon DynamoDB. Today we shall be discussing this new and fast way of storing and retrieving data using the AWS platform. But before we begin, let's look at our agenda for today. So first of all, we're going to start out by discussing what is DynamoDB, followed by why do we need it, in what scenario would you need to use it. Then we are going to draw parallels between 4 of the most popular AWS database solutions, them being Amazon Aurora, Redshift, RDS, and our star of the day, DynamoDB. In the section, we shall discuss how similar or different each service is from each other, and which is the best option to fit your needs. In a professional setting, however, in many situations, you might need 2 or more of these databases as a part of a single solution. Moving on, we are going to discuss components and features of DynamoDB. Then we shall have a quick little demo on how to create a sample table, read, write, and query on DynamoDB. So without much ado, let's get started. So what is DynamoDB exactly? Now, Amazon DynamoDB is a fully managed NoSQL database service platform provided by Amazon. For those of you who are new to this terminology, NoSQL databases are non-tabular databases and store data differently than relational tables. They come in a variety of types based on their data model, and DynamoDB here works on key value pair and other data structure documents provided by Amazon. Now, it requires only a primary key and doesn't require a schema to create a table. Hence, it can store any amount of data and serve any amount of traffic. With DynamoDB, you can expect a good performance even when it scales up. It's pretty simple to learn, and a small API that follows key value method to store, access, and perform advanced data retrieval. Now, DynamoDB comprises of 3 fundamental units known as table, attribute, and items. In order, an attribute is the simplest element in DynamoDB that stores data without any further division. It's like the fundamental element of this database solution. An item holds a set of attributes, and a table holds a set of items. I hope this much is clear. There's not much to it. These days, databases have become the backbone for any company, irrespective of how big or small they are. Traditional database systems, which were initially used, are not really the go-to solution today because of the dynamic change in requirements and the type of data procured. This is where DynamoDB wins, and that is what we are going to discuss further in the section called Why DynamoDB. So understand this. The main problem that a NoSQL database aims to solve typically revolves around issues of scale. When data no longer fits on a single MySQL server, or when a single machine can no longer handle the query load, some strategy for sharding and replication is required.
The pitch behind most NoSQL databases is that because they were designed from ground up to be distributed and to handle large data volumes, they provide some combination of benefits that a simple relational database can't easily offer. So NoSQL databases allow us to model data close to what the application requires. The relational database management system's way of thinking is to usually force fit every domain model into a structure of tables and columns, and this has led to a plethora of artifacts that try to solve the impedance mismatch problem. The various NoSQL databases offer a semantically richer form of data storage where you can store your domain objects either as documents or as key value pairs or even as graph structures. That way, you don't have to plug in additional frameworks that take care of intermediate data translation. Of course, besides the semantic richness, all NoSQL stores are designed for better scalability, so that's always there. Real-time analytics and applications based upon that collect a lot of data, and all of this data is collected in various different forms. What you need here is something that can scale up to that number first and accept various different data types. In such a case, something like DynamoDB is easy to set up and the scaling would be extremely smooth. Hence, companies such as Expedia and Nexon use Amazon DynamoDB as their primary database to leverage its features to deliver steady latency and a stable application experience to their customers. Moving on, we shall discuss DynamoDB and its other sister services from AWS. Each of these services are very different, and like I had mentioned before, it can prove to be pretty difficult to determine which best fits your needs. In fact, in many situations, multiple databases are a part of a single solution. So let's go through an overview of each of them to help inform your decision further. First of all, we have DynamoDB, which we previously discussed, but for the sake of this section, I'm still going to give it an overview. DynamoDB is a key value database that runs the NoSQL engine. This means that it treats all data within it as being composed of a list of attributes and values as opposed to data points constituted by the relationships between cells and column or row headers, as you have in a relational database. This makes the data stored in DynamoDB dynamic, which means it's easy to modify. Key value databases are best suited to certain use cases such as session data and shopping cart information. They can also achieve a fast throughput of read and write requests. Next, we have Amazon RDS. Amazon RDS is the first port of call service. It's one for when you're simply looking to offload your database management workload. It's compatible with 6 popular database engines, namely Aurora, MySQL, MariaDB, PostgreSQL, Oracle, and MS SQL Server, which means it can be operated just like any of these databases. It's worth noting here that RDS is the only database on this list compatible with popular Microsoft SQL Server, although those wishing to access the benefits of the other services might consider migrating to an engine compatible with Redshift, DynamoDB, or Aurora. Like all the other databases, excluding DynamoDB, RDS is a relational database that simply refers to the nature of data storage. As in, an Excel workbook that has been formatted as a table, the data is constituted by its value, the data in the cell, and the relationship that the cell has to its column or row headers. This is a little simplified as a relational database is a little more complex than an Excel workbook, but not much, and it's a good way of explaining the meaning of the phrase. Next, we have Redshift, which is also a managed database service and a relational database. It runs its own engine adapted from PostgreSQL and is extremely powerful, but it can also be more costly and more complex to work with. Redshift is an OLAP database. It's an online analytical processing database. This means it's specially suited for processing analytical queries involving more complex calculations. Because of its vast storage potential and differing functionality, Redshift is sometimes referred to as a data warehouse. Hence, it's an enterprise-level database mostly used by larger companies. And finally, we have Amazon Aurora. Now, Aurora is a database engine that can be run on the RDS or as Aurora serverless. Now, Aurora is MySQL and PostgreSQL compatible, It means that the language which programs it is functionally similar to these two engines, although it is an engine of its own right. Furthermore, Aurora has significantly higher performance stats compared to MySQL and PostgreSQL run on RDS. So now how do they compare? We are going to compare all the four in four major categories: scaling, storage, pricing, and maintenance. So first of all, let's talk about scaling. Now, because RDS is less complex, it is easier to scale, requiring just a few clicks on the AWS console to determine an auto-scale max capacity. It can be run using a reserved capacity or on demand. On the other hand, Redshift's infrastructure is way more complicated, meaning there will be more downtime and complexity involved in scaling. Using Elastic Resize, Redshift can be scaled more quickly though, but it doesn't quite close the gap with RDS. At the extreme end of things, however, Redshift is probably the better choice since its concurrency scaling feature allows it to take on a virtually limitless amount of queries. But then again, that is something which will cost you extra. Now, DynamoDB here scales seamlessly with no impact on performance, and the user may choose to run DynamoDB on demand or in provision capacity mode, in which a limit can be set on scale, much like RDS. Now, as per Aurora, how it scales depends on whether it's running on RDS or Aurora Serverless. On RDS, it scales as we described before. On Serverless, however, it will automatically start up, scale down, and shut down in line with your application's needs. But although this sounds impressive, however, Aurora Serverless is not the most robust of solutions. This makes Aurora more subject to restrictions than all these other solutions. So if you have standard scaling needs, RDS is a good option for you. And if you have enterprise needs and the time and budget, Redshift might be preferable, depending on the types of queries that you're running. Similarly, if you have a very high volume of read or write requests, DynamoDB is the best option for you. And for non-analytical purposes, if you still need a powerful relational database, Aurora might just work best for you, although you have to consider restrictions that it will impose on your work. It depends on what you need to scale. Next, let's talk about storage. Now, RDS's storage limit depends on which engine you're running, but it tops out at 64 TB using Amazon Aurora. SQL accommodates 16 TB, and all the other engines allow up to 32 TB. In Redshift, the max capacity is much higher than 2 petabytes, and Aurora's max capacity is 64 TB on RDS. And as we can all see, DynamoDB has a limitless storage capacity. Not really complicated, is it? Redshift has more storage and DynamoDB has limitless storage. Moving on, let's discuss pricing. Again, RDS's pricing is affected by the engine used, but generally it proves to be cheaper than the others. It's available under a pay-as-you-go model with a higher tariff or a reserved instance model with a lower tariff. Redshift is also available on a reserved instance and an on-demand model, with additional features such as concurrency scaling being charged at a different scheme. Aurora's pricing falls under the RDSs when run as such. When run serverless, you charge by Aurora's capacity units, which equals 2 GB of memory and corresponding computer network. Now, DynamoDB can be charged under an on-demand or provision model like the RDS, but with some variation. Under on-demand, users will be charged per read and write, and in the provision model, which is similar to AWS's reserved instances, users get to pay at a lower rate for an anticipated amount of read and write. So again, Redshift is more expensive at its base rate and has additional pricing models for additional features. DynamoDB's pricing is similar to RDS, but reflects its differing functionality. Aurora is priced as RDS when run as RDS and differently when run serverless. Finally, let's talk about maintenance. As you can see, while all are managed database services, Redshift's complexity incurs some user maintenance costs and DynamoDB's doesn't. Your RDS and DynamoDB instances are maintained solely by AWS for the most part, with the user having the option to defer certain updates. Aurora can be run as a managed database or serverless, requiring very little maintenance as well. Redshift does require more maintenance, but is still easier to maintain than a traditional database. Mostly, users are advised to perform vacuuming, which makes cells from which data has been deleted available for storage. Using the AWS console, you can check how long it takes for your query to be performed and how much CPU it's using and more. Ultimately, which database you use depends upon your needs and your needs alone, and most people anyways end up using multiple databases and create a hybrid custom solution that suits themselves. As for DynamoDB, it's designed in such a way that a user can get high performance, run scalable applications that would not be possible with a traditional database system. There are a number of features in DynamoDB, including but not limited to an on-demand capacity mode, which basically means that the applications using the on-demand service, DynamoDB automatically scales up or down to accommodate their traffic. Second, built-in support for ACID transactions, wherein DynamoDB provides server-side support for transactions, and on-demand backup, which allows you to create a complete backup of your work at any given point in time. You also have point-in-time recovery, which helps you with the protection of your data in case of accidental read or write operations, and encryption at rest, which keeps your data encrypted even when your table is not in use. This enhances security with the help of encryption keys as well. Now let us discuss some terminologies associated with DynamoDB. We'll keep everything simple. The terms used with DynamoDB are easy to understand, and it makes it unique from the rest of the database services actually. So firstly, something I discussed before, you have attributes, items, and table. Now an attribute is a single field that is attached to an item, like your employee name, age, information regarding whether they are male, female, or other. Then you have an item, which is a set of attributes in a table. You can also understand an item as a set of attributes that can uniquely define your entry in a table. For example, an item in employee records will identify a single employee. And finally, you have a table, which can be visualized as a group of items. Continuing with an example of the employee records, if you have several items such as employee name, employee ID, address, phone number, information regarding their gender, all such items combine together and are stored in a table. Now, apart from that, you have something known as a primary key, which is a unique attribute that is necessary while creating a table. It cannot be null at any given point, and hence while inserting an item into the table, a primary key attribute is a must, such as your employee ID. It is a primary key for the table employee records, right? Two items cannot have the same primary key, like your employee ID. Two employees cannot have the same employee ID. Even in primary key, there are two categories. You have a simple and a composite primary key, where a simple primary key is made up of a single attribute, and a composite primary key is made up of two items, such as in a table displaying car details, you can see several cars with details combining both the brand name and the model number as a composite primary key. Next, you have an attribute that lets you query your data with or without the help of a primary key, and it is known as a secondary index. Now, DynamoDB has these secondary indices that help you achieve additional access. Apart from this, you have another optional feature provided by DynamoDB to keep track of data modification events in your table. It's known as DynamoDB streams. Here, each event is represented by a stream record, and if the service is enabled, you get a new event every time there is a new item created, deleted, or updated. Now, these are the different terminology used in DynamoDB. So finally, let's proceed and find out how to access DynamoDB so that we can go ahead, create our sample table. So there are three ways in which you can access DynamoDB. It's very easy. First is through your console. Second is through your command line interface or CLI, which you can simply open your command prompt and type the relevant commands and access the table. And finally, using an API. You can use AWS SDKs. You can use AWS SDKs, which supports a variety of languages like Java, JavaScript, .NET, Python, and PHP. So now that we know how to access your table, let's go ahead and do so. So here is my AWS Management Console. I shall quickly navigate to DynamoDB. As you can see in the search bar, if I type DynamoDB, the service just pops up in front of you. It even has a brief description saying managed NoSQL database, and that's what we need. So in this particular section, we are going to learn how to create a table, read and write, insert your data in the table, as well as querying a table in DynamoDB. So once we've navigated to the DynamoDB section in your AWS Management Console, we're just going to go ahead and click on this blue button called Create Table. Now, once that is done, all you have to do is fill in the necessary details, such as a table name. I'm going to name this as employee, and the primary key or the partition key, which we had discussed before, we're going to keep as employee ID. We're going to keep it at a default string because most employee IDs are usually a combination of alphabets and numbers. They're alphanumeric. So we're just going to keep it at string. We are also going to use default settings, which means we are using no secondary indexes. Provisioning capacity is set to 5 reads and 5 writes only. Basic alarms with 80% upper threshold using SNS topic DynamoDB, and encryption at rest with default encryption type. So I'm just going to go down and click on Create. Once I do so, you'll see that our table is being created. In a bit, you can view your table being created. At Overview, if you click on Overview, you can understand your table. You have the data stream details, recent alerts. If you click on Items, you can find options to create items, to edit, to insert and query on the table. There are many more options such as metrics, alarms, capacity, indexes, backups, so on and so forth. You can use all of them to understand your table better, to monitor your data, to do much more complex computing with your table. For now, we are just going to create a simple table with a few simple attributes. So now that you've created a table, we are going to go ahead and insert a few items and understand how NoSQL works. I'm already at the Items tab. If you're not, navigate to the Items tab. It's the second one from the left, and click on Create Item. Now this opens a JSON editor, sort of a prompt, where you have your first category or column name, and then you can put in your value in there. So for employee ID, I am just going to put ED11602, right? Now to add more rows, you can always go ahead, click on this plus sign, this plus symbol on the left in blue, select append, and what kind of data, what data type you want to enter. So I'm going to put in string, maybe employee name. Let's call them Ayushi. Add one more, append, same routine. Let's say department or team. Team sounds better. Marketing. And let's just add one last one. Let's call it. Okay, this always makes me nervous. Typing in front of people, might just make a mistake and be embarrassed for the rest of this session. Contact number, let's just put it as 99999 1 2 3 4 5 6 7 8 9 10. Just 10 times 9. Wow. And I guess this is what all of your data looks like after adding multiple columns. So we're just going to go ahead and save. All right. I'm going to quickly create several more items, and you can see them all appear here in the section. Now, since it's a NoSQL architecture, you can always play around with columns you add to the table, So for example, here I'm going to put in name, number, and not team, but maybe position. Yeah. For some odd reason, everybody in this company's name just starts with an A. We are just going to have to deal with it. I'll just quickly do one more. Now, after you're done, your table is going to look something like this over here. Now we've got a mix of data. You have some people where the team's specified, some people where the position is specified. The common columns have been merged. 1, 2, 3, employee ID, contact number, and employee name. And now that we have a table ready, let's go ahead and look at some basic queries. So here in this gray bar type section, you can frame your query and click on Start Search. There's a white button here to get your desired results. So for example, what I'm going to do is I am somebody new to the company. I received a missed call and I have to get back to the person, but I don't remember their name. So I'm going to find out who they are by using their phone number. So I'm going to add a filter. I'm going to enter the attribute, let's say contact number. It's a number equal to, and I'm going to say 6767. So I am going to start search, and the person with the number 675 times is Anjali, and she works as an editor here. I wonder why she might need me, but we'll never find out, would we? I might also just try to find somebody using their employee ID. So I'm going to type employee ID and enter the value ED11442. And you can see Ashish has popped up working for an analyst position. Now, this is a very small example on how to use DynamoDB to suffice your needs. In real-life scenarios, there are much bigger problems to which it provides solutions. For example, a company like Duolingo, which is an online language learning site, uses DynamoDB to store over 31 billion items on their online learning site, with courses provided in 80 languages, 24,000 read units per second, and 33,000 write units per second. This is a read-heavy application, and DynamoDB is the perfect choice for a storage database. Apart from that, you also have your quarantine favorite OTT platform, Netflix, which uses DynamoDB as well. It runs A/B testing that builds personalized streaming experiences for its 125 million plus customers to make their experience, and in extension your experience, a pleasant one, and its enterprise cloud journey a success. One key commonality that you might have noticed among software companies and many other DynamoDB customers is the ability to accommodate extreme concurrency, request rates, and spikes in traffic. This is the home ground for DynamoDB. This is where it shines. By leveraging the power of AWS DynamoDB, you can take advantage of the seamless integration between your enterprise applications by managing your database using the cloud. Storage database powered by DynamoDB helps to manage and scale your growing user base and accompanied data. Thus, it unlocks numerous opportunities for you to grow your business.
Amazon Redshift, the most popular cloud-based data warehouse. We will begin by taking a look at traditional data warehouse. We'll be discussing its underlying architecture and the disadvantages of using traditional data warehouse. And then we'll move on to our today's topic, which is Amazon Redshift. Here, we'll be discussing its architecture, its key concepts, its unique features, and the advantages of using Amazon Redshift. And finally, we'll be doing a demo on Amazon Redshift. In this demo, we'll see how to import data from Amazon S3 to Amazon Redshift and perform queries on this data very easily. So I hope that was clear to you guys. Let's get started. I'm sure you know what a data warehouse is. You can think of data warehouse as a repository where data generated from your organization's operational systems and many other external sources is collected, transformed, and then stored. You can host this data warehouse on your organization's mainframe server or on cloud. But these days, companies are increasingly moving towards cloud-based data warehouses instead of traditional on-premise systems. And to know why, we need to understand the underlying architecture and the disadvantages of using traditional data warehouses. So let's begin by looking at architecture part. It is important to understand where the data comes from. Traditionally, data sources are divided into two groups. First, we have internal data, that is, the data which is being generated and consolidated from different departments within your organization. And then we have external data, that is the data which is not getting generated in your organization. In other words, that is the data which is coming from external sources. So this traditional data warehouse follows a simple three-tier architecture. To begin with, we have bottom tier. In bottom tier, we have a warehouse database server, or you can say a relational database system. In this tier, using different kind of backend tools and utilities, we extract data from different sources and then cleanse the data and transform it before loading it into data warehouse. And then comes the middle tier. In middle tier, we have OLAP server. OLAP is an acronym for Online Analytical Processing. This OLAP performs multidimensional analysis of business data and transforms the data into a format such that we can perform complex calculations, trend analysis, and data modeling on this data very comfortably. Finally, we have top tier. This top tier is like a front-end client layer. This tier holds different kind of query and reporting tools using which the client applications can perform data analysis, query reporting, and data mining. So to summarize what we have learned till now, traditional data warehouse as a simple three-tier architecture. In the bottom tier, we have backend tools using which we collect and cleanse the data. And then in middle tier, we have tools, which is OLAP server, using which we transform the data into the way we want. And then finally, top tier, in which using different query and reporting tools, we can perform data analysis and data mining. Moving on to the disadvantages of traditional data warehouse concept, there is this leading US business service company, and this company is running a commercial enterprise data warehouse. This data warehouse has data coming from different sources across different regions. The first problem that this company faced was when it was setting up a traditional data warehouse. As we discussed earlier, the architecture of traditional data warehouse is not very simple. It consists of data models, extract, transform, and load processes, which we call ETL, and you have BI tools sitting on top. So this US-based company had to spend a lot of money and resources to set up a traditional data warehouse. Data warehouse, which was initially 5 terabytes, was growing over 20% year over year, and it was expected that there might be higher growth in future. So to meet this continuously increasing storage and compute needs, the company had to continuously keep upgrading the hardware. Again, this task of upgrading the hardware continuously involves a lot of money, manpower, and too many resources. So, autoscaling in traditional data warehouse is not an easy concept. And since the company could not meet all the storage and compute needs easily, it was facing a lot of performance issues as well. And finally, the company had to deal with increasing costs. Initially, they had to spend a lot on setting up data warehouse, like they had to spend on hardware, manpower, electricity, security, real estate, and deployment costs, and many other. And as their data warehouse grew, they had to spend again to meet storage and compute needs. So to sum it up, setting up a data warehouse and deploying it and managing it later involves a lot of money and resources. Moreover, autoscaling in traditional data warehouse is not an easy concept. Because of all these reasons, many companies are increasingly moving towards cloud-based warehouses instead of traditional on-premise systems. So guys, in this session, we'll be dealing with one of the most famous cloud-based data warehouse provided by Amazon, which is Amazon Redshift. In simple words, Amazon Redshift is a fast, scalable data warehouse that makes it simple and cost-effective for you to analyze all your data across your data warehouse and data lake. Guys, I have a definition which is put up on the screen, and I have few words which I have highlighted over there. So as we progress through the course of this session, we'll know what those words exactly mean. So let's ignore them for now. But there are certain key concepts which you should be aware of when you're dealing with Amazon Redshift. So we'll discuss them now. Amazon Redshift Dataware is a collection of compute resources which we call nodes. And these nodes, when organized into a group, they become clusters. Each of these clusters run an Amazon Redshift engine, and it contains one or more databases. So this cluster has a leader node and one or more compute nodes. As for the leader node, it receives queries from client applications, and then it passes these queries and develops a suitable query execution plan. And then it coordinates the parallel execution of these plans with one or more compute nodes. Once the compute nodes finish executing this plan, again the leader node aggregates the results from all these intermediate compute nodes and then sends it back to client application. Then we have compute nodes. You can think of these compute nodes as a compute resources that execute the query plan which was developed by leader node. And when they are executing this plan, they transmit data among themselves to solve many queries. These compute nodes are further divided into slices, which we call node slices. Each of these node slices receive part of memory and disk space. So the leader node distributes data and part of user query that it receives from client application to these node slices. And all these node slices work in parallel to perform operation and increase the performance of your Redshift data warehouse. So to say, we have leader node, we have compute nodes and node slices. But how do they interact with client application? That is the question here. So I have these client applications, basically BI tools, or it can be any other analytical tools, which communicate with Amazon Redshift using drivers like JDBC and ODBC. JDBC refers to Java Database Connectivity Driver. It is an API for programming language Java. Then we have ODBC. It refers to other database connectivity driver, and it uses SQL to interact with leader node. So basically using these drivers, client application sends a query to leader node. Leader node, on receiving the client application's queries, it passes these queries and develops a suitable execution plan. Once the plan is set up, compute nodes and compute slices start working on this plan. They transmit data among themselves to solve these queries. So once the execution is done, leader node again aggregates the results from all these intermediate nodes and sends it back to client application. So this is the simple explanation of Amazon Redshift concepts. Moving on, when you launch a cluster, you need to specify the node type. Basically, we have two types of nodes. Dense storage nodes. These are storage optimized and are used to handle huge data workloads. And basically, they use hard disk drive or HDD type of storage. And then we have dense compute. These dense compute nodes are compute optimized and they are used to handle high performance intensive workloads. And they mainly use solid state drive or SSD kind of storage. But there are three things that you should keep in mind when choosing one among them. Firstly, you should be aware of the amount of data that you want to import into your Amazon Redshift. And then the complexity of the queries that you run on your database. And the need of downstream systems that depends on the results of these queries. So keeping these three things in mind, you can choose either dense storage nodes or dense compute nodes. So guys, that was the architecture and its key concepts. Now we'll take a look at few reasons as to why Amazon Redshift is very popular. As we discussed earlier, setting up a traditional data warehouse involves a lot of money and resources. But it's very easy to set up, deploy, and manage a suitable data warehouse using Amazon Redshift. On Amazon Redshift console, you will find Create a Cluster option. When you click on that option, Amazon Redshift asks you for certain details like the type of node you want to choose, the number of nodes, the VPC in which you want to create your data warehouse, user ID, password, and many other details. Once you feel that you have given the right set of details, you have an option which says Launch the cluster. And one click, your data warehouse is just created. So with one click, you can easily create a data warehouse in Amazon Redshift. Once your data warehouse is set up, Amazon Redshift automates most of the common administrative tasks like managing, monitoring, and scaling your database. So you don't have to worry about managing or scaling your database needs. So that's how easy it is to develop or set up a data warehouse using Amazon Redshift. We also learned that autoscaling is difficult in traditional data warehouse, but you can scale quickly to meet your needs in Amazon Redshift. Well, we already know that a cluster node has a leader node and one or more compute nodes. So if you want to auto scale in Amazon Redshift, all you have to do is resize your cluster size. As we know, these compute nodes are like compute resources. So if you want to scale up, you can increase the number of compute nodes. Similarly, if you want to scale down, you just have to decrease the amount of compute nodes. Alternatively, we have something called single node and multiple node. In single node cluster, one node takes the responsibilities of both leader and compute functionalities. And the multi-node cluster contains one leader node and user-specified number of compute nodes. So suppose you want to resize your cluster and you are using a single node cluster, then you can change from single node cluster to multi-node cluster. Similarly, you can change from multiple node cluster to single node cluster when needed. So that's how easy it is to scale up and down in Amazon Redshift. Moving on, we learned earlier that while using traditional data warehouses, it's possible that the performance of your data warehouse might decrease. But with Amazon Redshift, you can get 10 times better performance than any other traditional data warehouse. It uses a combination of different strategies like columnar storage and massively parallel processing strategies to deliver high throughput and response times. So let's discuss these strategies one by one. Well, first we have columnar data storage. To understand what that is, first we should know row storage. Most of the traditional data warehouse and databases use this row storage. In row storage, all the data about a record is stored in one row. Okay, so let's say I have this database here. I have 3 columns and 2 rows. The first column contains the unique number associated with student. The second column contains the name of a student, and the third column contains the age. As we already know, data is stored in form of blocks in databases or data warehouses. So as you can see in row storage, the block 1 contains all information there is about a particular student, his SSN, his name, and then age. So basically, it stores all the information that there is in a single row. So in the first block, you have information about first student, and in the second block, you have information about second student, and it goes on. Now the columnar storage. Again, I'm using the same database. Again, I have 3 columns and 2 rows. But column storage stores data by columns, with data for each column stored together. So again, we have blocks, but the first block here has all the data that is there in first column. So you have all the SSN stored in first block, and all names stored in second block, and all the ages stored in third block. So it goes on. There are a lot of advantages of using this column storage. Firstly, since in column storage, a single block contains same type of data, you can achieve better data compression. As you can see, columnar storage can hold values 3 times the records as row-based storage. Because of this, the number of input-output operations decreases. And thirdly, by storing all the records for one field together, columnar database can query and perform analysis on similar type of data far quicker than row storage. So this is how the concept of columnar storage, which is used by Amazon Redshift, provides us a better performance. And then we have massively parallel processing. I'm sure you might have heard of parallel processing in computer science. It's just that number of different processors work together or compute together or in parallel. Similarly, massive parallel processing in Amazon Redshift is nothing but clustering. We have already discussed this earlier. We have a cluster, and this cluster has a leader node and one or more compute nodes. And this compute nodes is further divided into something called node slices. So when this leader node receives a query, it develops an execution plan, and this compute nodes and compute slices work together or in parallel to execute this plan. And later, this leader node sends the results back to client application. So basically, this compute slices and compute nodes work in parallel to achieve better performance. Moreover, Amazon Redshift is also able to smartly recognize the data on nodes before running a query, which dramatically boosts the performance. So that's how we can get a 10 times better performance using Amazon Redshift. And then the cost. In traditional data warehouses, people had to spend a lot of money to set up and then later to maintain the data warehouse. But Amazon Redshift is the most cost-effective cloud-based data warehouse. If you remember, in traditional data warehouse, they had to spend on hardware, real estate, manpower, electricity, and deployment costs and many others. And as their data warehouse grew, they had to spend again on meeting the storage and compute needs. But in Amazon Redshift, we don't have to pay any upfront cost. So Amazon Redshift is most cost effective and it costs 1/10 of traditional data warehouse. You can start small for just $0.25 per hour without any commitments, and you can gradually scale up later if you need. In addition to all those advantages, Amazon Redshift allows you to query data from data lake. Data lake is a storage repository that holds a vast amount of raw data in its native format until it is needed. So in data lake, you have data in different formats. You can load data from Amazon S3 into your Amazon Redshift cluster for analysis very easily. That is, from data lake, you can store easily into your Amazon Redshift. But it needs more effort and cost. Effort because loading data into Amazon Redshift cluster involves extract, transform, and load, which we simply call ETL process. And this process is very time consuming and compute intensive. And it's costly because uploading lots of data, cold data from Amazon S3 for analysis requires growing your clusters, which is again costly and requires a lot of resources. So as a solution, we have something called Amazon Redshift Spectrum, which acts as an interface between your Amazon S3 or data lake and Amazon Redshift. So you can directly query data stored in Amazon S3 or data lake with this Redshift Spectrum without need for unnecessary data movement. I hope that was clear. And finally, with Amazon Redshift, your data is safe and secure. It offers backup and recovery. So as soon as data is created or stored in Amazon Redshift, a copy of that data is made, and through secure connections, a snapshot of it is sent to Amazon S3 for later. So suppose you lose your data, or if you have deleted the data from Amazon Redshift by mistake, you can restore the data easily from Amazon S3 service. Amazon Redshift also provides you with an option to encrypt your data. So when you enable this encrypt option, all the data in your cluster, in your leader node and your compute nodes and node slices is encrypted, and this way your data is very safe and secure. So guys, these are all the advantages of using Amazon Redshift. So now you have a basic idea of its architecture, its various key concepts like clusters, nodes, leader node, node slices. Now it's time to work on a demo. In this demo, we'll see how to transport data from Amazon S3 to Amazon Redshift data warehouse and perform simple queries. So I hope that was clear to you guys. Let's get started. But the first thing, there are certain softwares which you need to pre-install so that you can start working on Amazon Redshift. First, suppose you want to perform queries on the data on Amazon Redshift, then you need a SQL workbench where you can perform your queries. And as we learned earlier, the client application need a connection to communicate with Redshift. So we need to install a JDBC driver. And for that JDBC driver to run, we need to have a Java runtime environment. So we have three things to install here now. I'll show you how to install each of them. And I have this Java runtime environment download link by softonic.com. So it says free download, and you click on that, it'll be downloaded. You can store it anywhere. And once you're done with that, search for Amazon Redshift documentation. So here it is. Okay, not that. This one. And when you scroll down, it says Amazon Redshift get started. Click on that. And in the step 1, we have prerequisites. Okay. Scroll down and it says in the step 2, you have an option where you can download or go to SQL Workbench website and download it. So click on that. And here it says build current version. And you have download generic packages for all systems. You can download it. Once you click on that, it'll start downloading. And there is one more thing, which is JDBC driver. Go back to documentation part, scroll down, and the step 4, you can see configure a JDBC connection. Click on that. It'll take to your page where you have JDBC drivers of different version. You can download the first one. Click on this and it'll be downloaded. So once all these three things are downloaded, store them in a file of your choice. Well, I have stored them on my desktop. I have this AWS folder and in that Redshift. So here's my workbench. A zip file. It was a zip file, so I extracted all the files. And then I have my JDBC driver here. Well, Java runtime environment isn't download, so that's okay. So I hope that was easy. So just install all these things and you're set to go. And we're back to our Amazon Management Console. I have previously used Amazon Redshift, so I have this Amazon Redshift in recently visited services. Anyway, you can search for Amazon Redshift here. Here it is. Well, it's taking time to load. Okay, this is my Amazon Redshift console page, and you have different kind of options on your navigation pane on the left side. And there are two ways to create or launch a cluster. First, you have quick launch cluster option and launch cluster option. This is the very easy way to launch a cluster. But suppose you want the freedom to specify all the details as in the VPCs, the security groups, different type of nodes, username, password, and all that, you can go for launch cluster option. Let's go ahead and explore that. So first it asks for a name, let's say my cluster and database. the 81, and the port, this is default port 5439 is the default port which will be handled by Amazon Redshift. Then the master username, let's say AWS user, and password. That's it. And confirm your password and click on continue option. So cluster details are done and dusted. Then you have node configurations. Well, for the free tier, you only have DC2 large, but suppose you have a premium membership, then you can choose any of this. For this DC2 large, this is the CPU capacity, memory, and storage, and the input output performance is moderate. You can go ahead and choose the cluster type. We discussed this. We have multi-node and single node. In single node, we have both the leader and the compute node responsibilities handled by single node. The multi-node, we have a single leader node and user specified number of compute nodes. Click on continue. And then here it asks for the VPC details, parameter group, and suppose you want encryption or not, and all the details. So basically, in this launch cluster option, you have the freedom to specify all the details. But for this demo, I'm going to use quick launch cluster option. So again, as for the free tier, I'm using DC2 large. And again, for the free tier, I'm using DC2 large type. It says there are 2 compute nodes, and let's retain the same cluster name. As for the master user, AWS user, now let me give the password. And the default port is 5439. And last option, we have to choose among the available IAM users or IAM roles. But the question is why we need a IAM role here. In this demo, I said that we're trying to import data from Amazon S3, but you need certain set of permissions to access data which is stored in Amazon S3. For that, we need to create a IAM role. So let's go back to IAM service. Let me close all these tabs. Okay. Here you have roles option. You can click on that and click create role. And since we're dealing with Amazon Redshift, select Redshift, Redshift customizable, and click on next permissions. So we want Amazon Redshift to access data from Amazon S3. So search for S3 here, and you have a permission which says Amazon S3 read-only access. Well, for this demo, this is an if, but there is one more permission which says Amazon S3 full access, so you can perform read and write operations as well. As for this demo, I'm going to choose this permission which says Amazon S3 read-only access provides read-only access to all the buckets in Amazon S3. And click on next review. Give your role a name. Let's say my Redshift role 2. And click on create role. So now our Amazon Redshift database has permission to access data from Amazon S3. Let's go back to Redshift console. Okay, let me refresh this. And now it's showing the role which has been created is showing here. So as you can see, unlike other launch option, in this, I didn't have to specify much details, just the node type, the number of nodes, and then the master username, cluster identifier, and password, and the default database port. And you can click on launch cluster option. So with one click, you've easily deployed a database on Amazon Redshift. If you remember, when we tried to use this launch cluster option, we had option to select a default database or create our own database. But when you use this quick launch cluster option, a default database called dev will be created for us. So guys, this cluster has been created. So before we connect it to your SQL workbench, let's try to explore here. You need to make sure that the database health status and in maintenance status, everything is in green color. As for the cluster status, it should be available. And for the database health, it should be healthy. Only then you can make a perfect connection with your SQL workbench. So you have this icon here, click on that. Well, you get all the information there is about your cluster. Or you can just go ahead and click on this cluster. So this is the endpoint. This tells me all about how to make a connection with this cluster. I have this. When I click on that, it says publicly accessible, yes. And the username is AWS user. And the security groups, apparently it just shows the TCP rules which are set. So that's about the endpoint. Then the cluster name, you have cluster type, node type, and it shows the nodes and the zone and the date and time when it was created. And you have cluster version as well. On the right side, you have cluster status, which is available, database health healthy. So is it currently in maintenance mode? No. And then you have parameter group apply status, which is in sync with your database. And there are a few other features as well. But here you can see this VPC group. Click on that. Go for inbound and make sure it is set for TCP. Okay, edit. Make this custom TCP rule. And here 5439. Custom. That's it. And click on save option. So that's the default port with which you can access the Redshift. And let's go back. Clusters. Okay, where were we? We changed the default group of VPC. So this is the URL with which you can connect to the SQL Workbench. So let's copy this and paste it in our text file. I've pasted it over there. Well, if you're using ODBC connection, then you can use this URL. When you scroll down, you have capacity details of your entire cluster. It's DC2 large. So 7 EC2 compute units, total memory, storage, and platform. Okay. Let's go back to this IAM role. But I should have an IAM role option here. Let me see. Check it out. Okay. There's an option which says see IAM roles. You can copy this entire thing and paste it again in the editor so that while connecting it, it'll be easy for us to find it. Okay. Then, so now your cluster is created, your database or data warehouse is set up. Now you can just connect it with SQL Workbench and start working on it. So let's go back to the folder where I've stored my Workbench. Here it is. When you scroll down, there's a file which says SQL Workbench executable jar file. Open. So here it is. It's asking for a default profile name. Let's say new profile 1. Okay. Then driver. That was Amazon Redshift driver only, JDBC driver. And this was the URL. We copied it earlier in the editor. So I'm going to paste it over here now. This is the URL. Control C and paste it. AWS user in the password. Okay, that should work. Make sure that you select this auto commit, save it, and then click on OK. It says connecting to the database. Now it's successfully connected. So I can easily perform queries now. First, let's create some tables. Well, I'm using the sample database from Amazon S3. So you have this AWS Redshift documentation. Go back to that. And here it says get started. And in the step 6, you have this default SQL queries and tables provided. So you can go ahead and use that. I have it stored in my editor. So I'm going to copy. First, I'm going to create all the tables. Control C and paste it over there. Let's check what tables are there. First, we have user table. Well, this is like an auction data schema. So you have user table, many users, and you have category users, the category, different categories to which users belong to. And then you have date on which a particular event occurred. Then you have event table, all the details regarding an event. Listing, as in the items which are being sold are listed here, all the details about the items. Then you have sales, as in which user is buying, how much, which item, and all that details. So basically we have 6 to 7 tables. I'm going to select all that and say run option. So here it says table users created, table venue created, category, date, event, listing, and sales. So all the tables are easily created now. As for the next part, we need to copy the data or the data for the database from Amazon S3 to Amazon Redshift. Let's go back to the editor. And I have this copy command. I'll explain you the format. Control C. And let's paste it here. Okay, let's explore this copy command. It says copy to the table users which you just created from this path. That is from the file which is stored in S3 bucket. But this is the credentials AWS IAM role which we copied to the editor earlier. Apparently, we're just giving a permission to access the data from S3. So we need to copy this IAM role here. And then we have delimiter. As in, let me go back to editor and show you an example. Okay. Let's say I have a data. Let's say I have name, Archana, space, some age, B, hobbies. So you can see this straight line. This is the delimiter, as in the thing which you're using to separate all the fields or the columns. So going back. So that's delimiter which separates the data. And this is region in which your S3 bucket is located. So that's it. But we have to replace the IAM role. This is the ARN of the role. I'm going to copy it. And wherever this is, you need to just paste it. Control V. Okay. We're done. Last one. So select everything and click on this execute button. It might take a while because the data set which was stored in Amazon S3 might contain large number of rows. So it might take a while. So as you can see, it states executing statement here. It says 1 out of 7 finished. So we have 6 more to go. So this SQL Workbench has successfully executed all the script which we have written here. Let's go and start performing some simple queries. Let's say I want to extract the metadata of user table. I have this query. Okay, select star from page table definition. So since we are extracting metadata from table name, let's say users, and click on execute option. So you have so many columns. Here it says first column user ID of type integer, encoding delta. Then you have username, first name, last name, city, state, email. So basically that's the metadata or the structure of user table. So we have sales ID, list ID, seller ID, buyer ID, and many other details. Let's execute some other command. Let's say I want to find total sales on a given date. Okay. Sum the count. Here I have some function which will count the number of sales from sales and date, where the sales date ID is date ID, and the date on which I want to calculate, I've specified it here, and then click. Okay, there's some error. It should show a number here. Rest is working, only that is not working. I've selected the user table and I've asked them to display all that there is in the user table. So this is the data. Okay, select star from users. So I want to extract the names of people who are from, let's say some states. Let's consider some state. Let's take NH. So STATE like NH. It should work now. It says executing statement. So these are the people who are from state NH. So basically, once you've the perfect connection from your SQL Workbench to your Amazon Redshift, you can perform whatever queries you like. So let's go back to our Amazon Redshift console. Well, so this is the cluster. I'm going to click on this. Here you have queries. When you click on that, all the queries which you performed till now will be shown. So this is the query. So it says first name from users was from state NH. This was the query which we performed earlier. So you have all the data or all the information regarding the queries which you executed. Well, that's all about Amazon Redshift. So guys, this is how easy it is to create a data warehouse using Amazon Redshift. Go ahead and explore many other features of Amazon Redshift. Well, I've just showed a part of them here. So go ahead and create a database, perform various queries, and have fun. Amazon CloudWatch. Firstly, we will see what Amazon CloudWatch is and why do we need it. Then we'll discuss certain Amazon CloudWatch concepts. Moving on, we'll take a look at two most important segments of Amazon CloudWatch, which are Amazon CloudWatch events and Amazon CloudWatch logs. And finally, to make this all more fun and interesting for you, I've included a demo as well. So let's get started. First, let us try to understand why we need cloud-based monitoring with a couple of scenarios. In our first scenario, consider that you have hosted a messenger app on cloud, and your app has gained a lot of fame, but lately the number of people using your application has gone down tremendously, and you have no idea what the issue is. Well, it could be due to two reasons. Firstly, since your application has complex multi-tier architecture, monitoring the functionality of every layer by yourself will be a difficult task. Don't you think? And secondly, since you're not using any kind of monitoring tool here, you wouldn't know how your application is performing on cloud. Well, one solution for that is to employ a monitoring tool. This monitoring tool will provide you insights regarding how your application is performing on cloud. And with this data, you can make necessary improvements, and you can also make sure that your application is in par with today's customer needs. And definitely after a while, you'll notice that the number of people using your application has increased. Moving on to our next scenario, let's say your manager has assigned you with a project and he wants you to make this project as cost effective as possible. So as you can see in this project, you're using 5 virtual servers which perform highly complex computations. And all these servers are highly active during daytime. That is, they handle most traffic during daytime. But during nighttime, the servers are idle. By that I mean the CPU utilization of these servers during nighttime is less than 15%. And yet, as you notice here, in both the cases, you are paying same amount of money. You have to notice 2 points here. Firstly, all your virtual servers are underused during nighttime. And secondly, you are paying for the resources which you're not using. And this definitely is not cost effective. So, One solution is to employ a monitoring tool. This monitoring tool will send you notification when these servers are idle, and you could schedule to stop the servers on time. So guys, this is one way to make your project most cost effective and avoid paying unnecessary operating costs. Let's consider another scenario for better understanding. So let's say I have hosted an e-commerce website on cloud, and during sales season, many customers are trying to access my website, which is definitely a good thing. But for some unfortunate reason, application downtime has occurred. And you guys have to remember that I'm not using any kind of monitoring tool here. So it'll be difficult for me to identify the error and troubleshoot it in reasonable amount of time. And it's quite possible that in this period, my customer might have moved on to different website. So you see that I've lost a potential customer here. So if I've had a monitoring tool in the situation, it would have identified the error in earlier stages itself and rectified the problem. Well, I could have easily avoided losing my customer. So I hope guys, with help of these use cases, you were able to understand as to why we need cloud-based monitoring. So let me just summarize what we've learned till now. We need monitoring firstly because it provides a detailed report regarding performance of your applications on cloud. And secondly, it helps us to reduce unnecessary operating costs which we are paying to the cloud provider. Moreover, it detects problems at earlier stage itself so that you can prevent disasters later. And finally, it monitors the user's experience and provides us insights so that we can make improvements. So well guys, in this session, we will be discussing about one such versatile monitoring tool called Amazon CloudWatch. Amazon CloudWatch basically is a powerful monitoring tool which offers you a most reliable, scalable, and a flexible way to monitor your resources or applications which are currently active on cloud. It usually offers you with two levels of monitoring, which are basic monitoring and detailed monitoring. If you want your resources to be eligible for basic monitoring, all you have to do is to sign up for AWS free tier. In basic monitoring, your resources are monitored less frequently, like say every 5 minutes, and you're provided with a limited choice of metrics to choose from. Whereas in detailed monitoring, all your resources are monitored more frequently, like say every 5 minutes, and you're provided with a wide range of metrics to choose from. But if you want your resources to be eligible for detailed monitoring, you'll have to pay a certain amount of money according to AWS pricing details. Now, let's have a look at few monitoring services offered by Amazon CloudWatch. Amazon CloudWatch, firstly, it provides a catalog of standard reports which you can use to analyze trends and monitor system performance. And then it monitors, stores, and provides access to system and application log files. Moreover, it enables you to set up high-resolution alarms and send notifications if needed. And Amazon CloudWatch also sends system events from AWS resources to AWS Lambda functions, SNS topics, etc. So if you have not understood any terms which I've used here, don't worry, we'll get to know more about these terms as we progress through the course of this session. Earlier, I mentioned that Amazon CloudWatch allows administrators to monitor multiple resources and applications from single console. These resources include virtual instances hosted in Amazon EC2, databases located in Amazon RDS, data stored in Amazon S3, Elastic load balancers, and many other resources like Autoscaling groups, Amazon Cloud Trail, etc. So guys, now let's try to understand Amazon CloudWatch a little deeper. Firstly, we'll have a look at few Amazon CloudWatch concepts, and then I'll explain you how Amazon CloudWatch actually operates. So it's metric. A metric represents a time-ordered set of data points that are published to cloud. So what I mean by that is, suppose let's say you have three variables x, y, and z, and you have created a table which has values of x with respect to y over a period of time. In this scenario, the variable x which you have been monitoring till now is a metric. So you can think of metric as a variable which needs monitoring. Next we have dimensions. Let's consider same variables x, y, and z. Previously you had created a table which has values of x with respect to y. Now let's create another table which has values of x with respect to z. So basically we have two tables which describe same variable x but from two different perspectives. These are nothing but dimensions. So basically a dimension is a name value pair that uniquely identifies a metric. And Amazon CloudWatch allows you to assign up to 10 dimensions to a metric. Then you have statistics. Previously we had created two tables. which had values of X with respect to Y and as well as Z. You can combine data from these tables, like to create a chart or maybe plot a graph for analytical purposes. This combination of data is nothing but statistics. Statistics are metric data aggregations over a specific period of time. Then you have alarm. Let's say you have been monitoring this variable X for some time now, and you want a notification to be sent to you when the value of X reaches certain threshold. All you have to do is set an alarm to send you notification. So basically, alarm can be used to automatically initiate actions on your behalf. Now that you have clear understanding of concepts of Amazon CloudWatch, let's see how Amazon CloudWatch operates. Amazon CloudWatch has complete visibility into your AWS resources and applications which are currently running on cloud. So firstly, it collects metrics and logs from all these AWS resources and applications. And then by using these metrics, it helps you visualize your applications on CloudWatch dashboard. Moreover, if there is some sort of operational change in AWS environment, Amazon CloudWatch becomes aware of these changes and responds to them by taking some sort of corrective action, like maybe it sends you a notification or it might activate a Lambda function, etc. And finally, it provides you real-time analysis by using CloudWatch Metric Math. So if you're wondering what CloudWatch Metric Math is, it is a service which integrates multiple CloudWatch metrics and creates a new time series. And you can view this time series on CloudWatch dashboard as well. So working this way, Amazon CloudWatch provides you with system-wide visibility. It even provides you actionable insights so that you can monitor your application performance. Moreover, it allows you to optimize resource utilization if needed. And finally, it provides a unified view of operational health of your AWS environment. So I hope that by now you know what Amazon CloudWatch is. So now let's try to understand how Amazon CloudWatch works with help of a demo. So guys, this is my AWS console. Let's say AWS Management Console. And the services which you can see on the screen are the services offered by Amazon AWS. But in this demo, we're going to use only few services. Let's say CloudWatch, and then you have EC2 and a service called Simple Notification Service. And when I click on EC2, it takes me to EC2 dashboard where you can see that I have 4 instances which are currently active. You know that here in this demo, I'm supposed to get a notification saying that CPU utilization of my instance is less than 25%. For me to receive a notification first, I'll have to create a topic and subscribe to it with my email ID. So let's explore a service called Simple Notification Service, where you can create a topic and subscribe to it. Once you reach SNS dashboard, click on Topics option on the navigation pane and click a Create New Topic. Give your topic a name. Let's say CW Topic, and give the display name as well. Let's give the same name and click on Create Topic option here. You can see that I've successfully created a topic. Now click on the topic which you have created and select Actions and subscribe to Topic option. Well, I want notification to be sent to me in form of email. You have different options as well in form of Lambda function or JSON, etc. But I'm going to choose it as email and give my email ID, which is here, and then click on Create Subscription option. So now whenever AWS console wants to send me a message, it will send to the email ID which I used to subscribe the topic. Now let's go back to CloudWatch dashboard. So guys, this is my CloudWatch dashboard and you can see different options on navigation pane. Firstly, I have dashboard where I can view all my metrics at same place. Then you have alarms, which shows the list of alarms which you have configured. And then you have events and logs, which we'll be exploring later. Our topic of interest is the last one, which is metrics. Select the metrics option here and then choose EC2 and then per instant metrics. When you do that, a list of metrics will be shown to you like network out, CPU utilization, network packets in, network packets out, and various other metrics for various resources which are currently active on your cloud. So, but we are interested only with CPU utilization. So I'm going to type that here. Well, it shows the list of instances which are active on my cloud. And I'm going to choose Windows 2 instance and then click on Graph Metrics option here. Okay, let's select Windows 2 only. And then on the right side, you can see you have a alarm button. When you click on that, a dialog box will be open where you can configure your alarm. Firstly, let's give alarm a name. Let's say low CPU utilization and a brief description as well. Let's say lower than 25%. Lower than 25% CPU utilization. Now I'm going to set the threshold, which is less than 25% in this case. And on the right side, you can see a period option. If your resources are eligible for basic monitoring, this period option by default is 5 minutes. And if your resources are eligible for detailed monitoring, it's usually 1 minute. And when you scroll down, you can see a send notification to option here. So select the topic which you have previously created. That will be C topic in my case, and then click on create alarm. Well, there is some error. Okay, it says there's an alarm already with this name. So let's give it another name of my instance. Now let's try again. And when you click on this alarm button and click on refresh option here, it says that I've successfully created an alarm. Here you can see that low CPU utilization of my instance. And when you click on that, it shows you all the details like description, threshold, and what action it is supposed to take when alarm is configured and all the details. So guys, try it out. It'll be easy for you to understand CloudWatch console much better. Okay guys, now you know what Amazon CloudWatch is, what it does, and the way it operates. But to understand the capability of Amazon CloudWatch completely, we should be aware of two important segments of Amazon CloudWatch, which are CloudWatch events and CloudWatch logs. So let's discuss them one by one. Firstly, we have Amazon CloudWatch events. Consider the scenario. Let's say you've created an autoscaling group, and this autoscaling group currently has terminated an instance. So you can see this as some sort of operational change in AWS environment. When this happens, Amazon CloudWatch becomes aware of these changes and responds to them by taking some sort of corrective actions. Like in this case, it might send you a notification saying that your autoscaling group has terminated an instance, or it might activate a Lambda function which updates the record in Amazon Route 53 zone. So basically what Amazon CloudWatch events does is it delivers a real-time stream of system events that describe change in your AWS resources. Now let's have a look at few concepts related to CloudWatch events. Firstly, we have event here. An event indicates change in AWS environment, and AWS resources generate events whenever the state changes. Let's say you have terminated an active EC2 instance. So the state of this EC2 instance has changed from active to terminated, and hence an event is generated. Then you have rules. Rules are nothing but constraints. Every incoming event is evaluated to see if it has met the constraint. If so, the event is routed to target. Target is where the events are handled. Target can include Amazon EC2 instances or a Lambda function or an Amazon SNS topic, etc. Now let's try to understand Amazon CloudWatch events better with help of use case. In this use case, we are going to create a system that closely mimics the behavior of dynamic DNS. And for those who don't know what dynamic DNS is, let me give an example. Let's say you want to access internet at home. Then internet service provider assigns you an IP address, but since internet service provider uses different kind of online systems, this IP address keeps changing, because of which it might be difficult for you to use this IP address with other services like webcam, security camera, thermostat, etc. So this is where dynamic DNS comes into picture. What dynamic DNS does is it assigns a custom domain name to your home IP address, and this domain name is automatically updated when IP address changes. So basically, dynamic DNS is a service that automatically updates a name server in domain name system. And Amazon offers you with a similar kind of service called Amazon Route 53. So in this use case, we are going to update Amazon Route 53 whenever an Amazon EC2 instance changes its state. Now let's see how the use case actually works. This use case precisely works this way. So whenever an EC2 instance changes its states, Amazon CloudWatch event becomes aware of these operational changes and it triggers a Lambda function. This Lambda function uses different kind of information regarding the instance like its public and private IP address, and it updates a record in appropriate Route 53 hosted zone. So let's say you have an EC2 instance and you have terminated the instance. So Amazon CloudWatch events become aware of this and it triggers a Lambda function. And this Lambda function deletes the record from Amazon Route 53. Similarly, if you have created a new instance, again Amazon CloudWatch events become aware of this and it triggers a Lambda function, and this Lambda function creates a new record in Amazon Route 53. I hope you have understood what Amazon CloudWatch events is and what it does. Now let's discuss how Amazon CloudWatch events works with help of a demo. So in this demo, we will schedule to stop and start EC2 instances with help of Lambda function and CloudWatch events. So let's go ahead with demo. So guys, you can see that I have 4 instances which are currently active. First, I'm going to create a Lambda function which is going to stop my Windows 2 instance. And you guys need to know that for Lambda function to do that, we need to assign permission. So Amazon provides you with a service called IAM, which is Identity and Access Management, where you can assign permissions. When you search for IAM in the tab, it shows you the service. Select that, and on IAM dashboard, on the navigation pane, you can see a policies option here. Select that and click on create policy option. First, it's asking you for a service here, which will be EC2 in our case. Click on EC2 function, then actions, which will be to start and stop my EC2 instances. So let's search for start instance. Well, a predefined function is already there, so you can choose that. Then you have stop instance. Again, select that. And then I want this to be eligible for all the resources, so I'm going to choose all resources here and click on review policy option. Let's give our policy a name, that is to start and stop EC2 instances, and description as well, a brief description, let's say to start and stop instances. And now click on create policies. It's taking a while, so I've successfully created a policy here. Next, we have to assign this policy to Lambda function. So click on roles here, then click on create role, choose Lambda function here and click on next permission. Search for the policy which we have created earlier, that is to start and stop. I found the policy, select that and click on next review option. It's asking for a name. Let's give a name, start stop instances, and click on create role. I've successfully created a role. So what we have done here is we have assigned permission for Lambda function to control EC2 instances. Now let's create a Lambda function. You can search for Lambda in the search tab, and there click on create function. Give your Lambda function a name, let's say to stop instance, and select the role which you have previously created and click on create function. You can see that I've successfully created a Lambda function. And now I'm just going to copy the code to stop EC2 instances here. I'm going to select this and paste it over here and make sure to save it. As you can see here in this function, it asks for instance region and instance ID. So let's configure the details. Let's give it as stop instance. And here you'll have to insert instance region and ID. Instance region and instance ID. Now we'll have to copy the instance region and ID of the instance whichever we need. So let's go to EC2 dashboard here. Now let's say I want my Windows 2 instance to be stopped. This is the instance ID which I'm going to paste it over there. Similarly, instance region now. Well, in this case, I'm choosing Windows 2 instance. You can choose whichever instance you want to stop. Once you're done that, you click on create option here. Test the configuration details. When you scroll down, you can see the execution results here. It says that my instance has been successfully stopped. Let's go and check in the EC2 dashboard. Here on the EC2 dashboard, I'm going to refresh it. And you can see that my Windows 2 instance has successfully stopped. Now we'll create another Lambda function which will restart this function. Again the same, search for Lambda function in the search tab and click on create function option. It asks for a name, so let's say start instance, and choose the role which you have previously created and click on create function. Again, you'll have to paste the code to start the instances over here and click on save option. Let's try to configure this. Let's name it as start instance. And again, it asks for 2 attributes which are instance region and ID. Now all we have to do is copy the instance region and ID here, like we did earlier. Let's go to EC2 dashboard and copy the instance ID and region. Well, you guys can see that here my Windows 2 instance has been successfully stopped. Now I'll copy this and paste it over there. Similarly, instance region as well. And click on create option. Now test the configuration. And when you scroll down, you can see that my instance has successfully restarted. In the EC2 dashboard, I'm going to refresh this. Well, my Windows 2 instance is on its way to get restarted. Till now, I've used Lambda function to start and stop my instances. But now I'm going to automate this process with help of Amazon CloudWatch. So let's go to CloudWatch dashboard here. Well, it's taking a while to load. Then choose events option and click on create rule. So here we're going to schedule to stop my instances every day at 6:30 p.m. and to restart this instances every day at 6:30 a.m. So click on schedule. If you want to know more about cron expressions, you can visit Amazon documentation. So let me show you. It has 6 fields. Firstly, it's minutes, then you have hours, then day of month, day of week, and year. We're concerned only with minutes and hours because we want our instances to be start and stopped every day, every month. So let's give the details. So if you're going to create a rule to stop the instance, let's say 6:30 in the evening, 30 minutes and 18, which is nothing but 6 p.m. And then rest all, you don't have to mention anything. When you give a proper cron expression, sample timings will be provided to you. You can see here the rest of the sample timings. And now let's add a target function, which is Lambda function in our case, and select on stop instance function and click on configure details. Give your rule a name. Let's say stop my EC2 instance, and description to stop my EC2 instance at 6:30 p.m. every day, and click on create rule here. You can see that I've successfully created a rule to stop my instance every day at 6:30 p.m. Now let's create another rule to restart this instance every day at 6 a.m. in the morning. Again the same, choose the schedule here and cron expression, which will be 6 a.m. in the morning. Again the sample timings are shown here. Then let's add target function, again Lambda function, and select the function that is to start instance and click on configure details. Let's name it as start my EC2 instance, and description as to start my EC2 instance every day at 6 a.m. and click on create rule. So now we have successfully created 2 rules to start and stop the EC2 instances at 6:30 p.m. and 6:30 a.m. respectively. So what we have done is we have saved our time here. We have automated the process of stopping and starting EC2 instances. So try it on yourself. It'll be easier for you to understand. So guys, now let's discuss our next topic, which is Amazon CloudWatch logs. Have you guys heard of log files? Well, log files are nothing but detailed record of events that occur when you're using your AWS environment. You can view your log files on your on-premise server as well. Search for an app called Event Viewer. Select the app and click on Windows Logs and select Systems. A list of log files will be shown to you. When you choose a particular log file, all the details regarding that log files will be shown, like the number of keywords, the login time, number of hours the file has been logged onto, and various other details. Similarly, you have log files created when you use AWS environment as well. So you can consider these log files as a data repository. Most of the metrics are generated from these log data. So whenever a metric is generated, a part of data is extracted from this log data. So you're designing metrics according to your like by choosing a part of data from this log data. So basically these log files are what you call a primary data storage place. And Amazon CloudWatch logs is used to monitor, store and access log files from AWS resources like EC2 instances, CloudTrail, Route 53, etc. Let's try to understand CloudWatch logs better with help of some features. Firstly, you can use Amazon CloudWatch logs to monitor your application and system log files. Let's say you have made a lot of errors but trying to deploy your application on cloud. In this scenario, you can use CloudWatch logs to keep track of your errors and send a notification to you when the error rate increases certain threshold so that you can make avoiding errors again. Then you have log retention. By default, logs are kept indefinitely. But CloudWatch provides you with an option where you can set the period between 10 years to 1 day. Then you have log storage. You can use CloudWatch logs to store your log data in highly durable storage. And in case of system errors, you can access raw log data from this storage space. And then you have DNS queries. You can use CloudWatch logs to log information about the DNS queries that Route 53 receives. Now let's have a look at few concepts regarding CloudWatch logs. Firstly, we have something called log event. So log event is just a record of activity that has occurred in AWS environment. It's straightforward. Then you have log stream. A log stream is a sequence of log events that have same source. Then you have something called log group. Log group defines group of log streams that has same monitoring and access control settings. By default, you have to make sure that each log stream belongs to one or the other log group. Guys, now let's try to understand CloudWatch logs better with help of this use case. In this use case, we are going to use Amazon CloudWatch logs to troubleshoot the system errors. You can see that I have 3 instances here and a CloudWatch agent which is monitoring all these 3 instances. So what CloudWatch agent does is it collects custom level metrics from all these EC2 instances, and then all these metrics and logs collected by the agent are processed and stored in this Amazon CloudWatch logs. Amazon CloudWatch logs then continuously monitors these metrics, as you can see here. By then, you can set an alarm which will send you notification when some sort of error occurs in the system. So whenever you receive a notification saying that some sort of error is there in your system, you can access the original log data which is stored in CloudWatch logs to find the error. So this is how you can use Amazon CloudWatch logs to troubleshoot the system errors. So basically, you are having a look at original data so you can solve your problems faster and quicker.
So what exactly is AWS Config? Now, as we all know, if you talk about AWS, we know that we would be creating quite a few services, resources, and we would be deleting, modifying, and continuously work or play with those services, isn't it? I mean, that is how architectures work. There would be some change or the other. So what happens is when these changes happen, the problem is it becomes difficult to keep track of all the things that is happening around you. And at times that might affect your decision making. So if there is something that lets us do all these things, that is keep track of everything that is happening around, we would be in a much better position to actually go ahead and manage our business and our infrastructure. So this is where AWS Config steps in. What it does is it lets you assess your data, it lets you evaluate it, and also audit it. That means it ensures that there is continuous monitoring of your data. And since you can continuously monitor your data, you can keep track of everything that is happening around you. Plus, if there is some change that takes place in your infrastructure or in your resources, what happens is Amazon Config, it basically throws in a notification by using something called as simple notification service. That means you would be notified of changes that are happening. So that means since you're getting notified about all the changes that are happening, you're in a much better position to go ahead and manage your resources. Plus, you can take a call as in whether you want to go ahead and automate certain configurations. And if you want to, AWS Config helps you in doing that as well. What it also does is, since you're monitoring everything, it's important that you keep a record of everything that is happening. And AWS configuration lets you record the changes or monitoring process or everything that is happening around you in a much better way. So this is what AWS Config is. Let's just move further and try to understand what else can it do. Well, if you talk about AWS Config, what it does is it lets you retrieve configuration information about your resources. As I've already mentioned, you'd be having more than one resource that is being used. Whether you talk about your virtual machines, you talk about your elastic block storage volumes, whatever it is. I mean, these are your entities, these are your resources, and you want to retrieve configurations or information about these resources. And your AWS config lets you do that. Whether you talk about historical data, again, your AWS config lets you collect that as well. It produces a snapshot. That means it captures the information of all the configuration items as one or as a combined unit. And it lets you evaluate various resource configurations as well, because you'll be knowing what is changing, what is not, what needs to be updated, and all those things. As I've already mentioned, you have something called as SNS that lets you send notifications in case if any change has happened. And it also shows you relevant relationships between your resources. Now, this is important because you're talking about complete architecture and you need to know how your resources are related to each other. And again, whether there's any change between these relationships as well. So this was about what AWS Config can do. Now let's move further and try to understand what are some of the terminologies that AWS Config has to offer to you. Now, AWS resources. When you talk about resources, these can be anything, right? I mean, I just talked about quite a few services that AWS has to offer to you. If you talk about AWS Config, it manages or it controls or it can actually look into quite a few services like your compute services. When you talk about EC2, it is a compute service. Your AWS Config can actually monitor those resources as well. It can monitor resources like the ones that are provided by your VPC, your storages and all those things. It can monitor all these services. And the resources or the items that are created using these services are nothing but your AWS resources, your configuration items. Now, when you talk about configuration items, think of it as the information about your configurations. Say, for example, the metadata of your configuration items or your resources is called as your configuration item rather. Configuration snapshot. As I've already mentioned, since you have so many items, what snapshot does is it lets you get a grouped picture of all these resources together. Resource relationship. Now, as I've already mentioned, if you're looking at a bigger picture, you need to understand how resources are related to each other. Say, for example, your EC2 instance might have some volume attached to it, right? So what volume is attached to it? What is the instance that you're using? All this information. This can be predicted or depicted by using your resource relationship. And the relationship between these entities or resources is called as basically a relationship, as in how everything happens between two or more resources, or how do they exactly communicate with each other. Configuration stream. Since we are talking about monitoring your data, now there would be a track kept of everything that is happening. Suppose some resource gets deleted, something gets added, right? So this needs to get added in the flow that you have. Like, okay, at this time a resource was created, at this time this was deleted, and this was added to it. So these items that get added into a particular stream or a particular flow, this flow is called as your configuration stream or a configuration flow rather. Configuration recorder. As I've already mentioned, since you're talking about monitoring, it's important that all the events or actions that are happening around you, those get recorded. And your AWS config or your AWS config recorder lets you record all those things. So this was about AWS config, the terminologies, and some of the basics that I wanted to talk about. What I'm going to do is I'm quickly going to switch into my AWS console and let's just go ahead and take a look at a demo and understand what AWS config is and how does it actually look when you do go ahead and implement those things practically. So stay tuned and let me just switch into the demo part, guys. So yes, guys, what I've done is I've gone ahead and I've switched into my AWS console and this is how it looks like. For people who are completely new, they should have a free tier account in order to use AWS services. Now, what is a free tier account? Let me give you a quick overview of it. If you just search for AWS free tier, you would be redirected to this page and you can see AWS free tier. You can click on it and this is what you'd have. Now, what this page indicates is you can use certain services provided by AWS for free. You can see them here. These are some of the popular services. You have your EC2, which is a compute service, QuickSight, an analytics service. Basically, it is for data visualization. You have your RDS, which again is a database service. For storage, you have Amazon S3, that is simple storage service, and their capacities and their stretches are also given, as in you can use Amazon S3 where you can store 5 GB of data. And if you talk about AWS Lambda, you can have free requests, that is 1 million in number. So depending upon the service, you have different types of usages that are made available to you for free. And this free tier, it actually extends for 1 complete year. So you can use these services in that course of time. If you do exceed these services, as in the limits that are specified, you might be charged. But do not worry, AWS would actually go ahead and notify you as in, okay, this is the amount that you've used and this is what you're supposed to pay. That is if you exceed it. You can also go ahead and set alarms so that you would be notified if you exceed a particular limit. Suppose you have X amount of limit. Probably when you reach the 80% of limit, you can set an alarm for it saying that, okay, if I reach this limit, give me a notification. So you would be notified and you won't be charged anything. Yeah, to create an account, you need your card details, maybe your credit card and even debit card. I've tried debit card. Debit card also works. you have to go ahead, sign into the console, and certain details would be asked as in, okay, why do you need to use this account? What is your email ID and the card details? And you'd be good to go. So I would suggest that you do go ahead and create this free tier account. And once you do that, you would be having this console made available to you, and you can use the services that are mentioned here. So now let's get started with the demo part where we left off in the theory part. That is, we talked about Amazon Config. I'm going to give you a quick overview as in how does config works and what all can it do. The thing is, when you talk about getting the notifications or getting notified for certain things, it actually takes a longer while than normal. So I'm not sure that if I do go ahead and implement some of the changes, would those be reflected right away? Meanwhile, what I'll do is I'll just put forth a change quickly and we'll see that by the time this session ends, do we get that change reflected or not? Okay. To start with, let's go to this thing, EC2 instance. Now I have one running instance here. As you can see, this is the one and it is in running state right now, isn't it? So if I just go ahead and maybe change its state to stop, it takes somewhere around 25 to 26 minutes for these changes to get reflected in the log that we have. That is what I've noticed till time. So there might be a possibility that if we are making this change, we might not see the reflection right away. So meanwhile, this thing gets shut or stopped. Let's just go ahead and try something else. So let me just quickly switch into the AWS config. There you go. So once I switch into AWS config, I actually get the dashboard directly, isn't it? For people who are new to AWS config and they haven't used this service, this is not what you'd get here. You'd get a page that says get started. And once you click on get started, you would be redirected to a page and that page would look something like this. Yeah. So note one thing, right now we are in the North Virginia region. When the service started, basically all the config services were mostly available in this region, but that has changed with time and now we can have it in other regions as well. So yep, by default I've selected this region. You can choose other regions as well. So if you do get started, you'd be getting that page, and once you click on get started, this is where you would be redirected. Now this is what we have here, dashboard, which gives me details about all the services that are there. Now in my case, the recording has started already. Might not be the case in your situation. So when you do start the recording, whatever changes that happen with the resources in this region would be reflected by your config service, and your services would be like given here or shown here in this dashboard itself. So let's just go ahead and see what you have to do exactly. As you can see, the recording is turned on for me. So my state is getting recorded right now, whatever is happening here with my resources. So what you have to do is you have to come here and you have to select this, as in what resources do you want to monitor? Record all the resources that are supported in this region. I've said yes. And also include global resources. I've said yes to that as well. So it would be giving me details about all the services and resources that are there in this so-called region. We won't play with this data retention. S3 bucket. Now guys, S3 bucket, as I've already mentioned, S3 is a storage service. It is a simple storage service and it stores data in the form of objects, and these objects, they get stored in containers called as buckets. So everything, even when you do go ahead and create this simple notifications, when you go ahead and create a notification service which would give you notification or notify you with the changes, those have to be put somewhere, right? So those changes would be put in a bucket. You need a bucket for that as well. So we'd be creating a bucket here. So as you can see, there's a bucket which I'm already using. I have something CF demo bucket. I've actually have quite a few buckets here. So I can just go ahead and pick any one of these buckets if I want to. As far as you're concerned, if you're creating a new bucket, I would suggest that you go ahead and create one. Creating one is very simple. You can click on this thing and you can specify a name and that bucket would be created for you. Now bucket is nothing but a simple storage container. I've already shown you that, but still for people who I believe are completely new might wonder as in what this bucket is. So guys, if you go to S3, see, this is my S3 service and I have certain buckets here. Some of the ones that I've used, if you open those, you might have some data. As you can see, AWS logs. Now these are the logs that actually got collected the last time I made some changes here. It's somewhere around 12:26 p.m. is when the changes happened, and those are here in the form of a file here. So SNS puts in the data in your bucket each time there is a change that has happened. So yeah, that is why we just go ahead and create a bucket here. Now I have a bucket, as you can see, and the bucket that I've used here is this one, bucket for demo, right? I also have one more bucket, which is this. It too has some logs. So if changes happen, these buckets get updated. Permissions, as you've seen, I've set it to public because I want my config to interact directly with the buckets. Now, depending upon your applications, there might be certain restrictions on the buckets that you use. But in my case, I wanted it to be, as I've already mentioned, public because it is a simple demo and I do not have too much concerns about security right now. So I've given all the access to everyone as in public access so that if something gets dumped, they are allowed to dump it in my bucket. Going back, so once you create a bucket, you choose one. So I've selected this one. Do I want an SNS topic? Yes, I want an SNS topic. I've created an SNS topic called a sample topic for today. So, and I've gone ahead and selected that only. So you can just go ahead and create one more if you want. You can put in a name that you want, but I would be choosing an existing one. And then what about a rule? Do you want to select one or use the one that is existing? I would say just go ahead and use an existing AWS config service linked role. And then I would say save. If your bucket permission policy isn't approved, I mean, if it does not have write access or rights, there would be an error here saying that you do not have actual bucket rights or the required bucket rights. In that case, you need to come here and change the permissions here. Once you do that, you'd have this thing would get approved, as simple as that. So there you go. This has been saved. And if I come to dashboards, in that case, my recording has also started. And if I go to some instance or some resource, suppose I selected EC2 right now, this is the config timeline. I click on it. As you can see, all the changes are reflected here. There was one change that was made at this time duration and it got reflected. This was the other. Probably there are 5 changes is what they're saying. So these were the changes that happened and the log got updated accordingly. This was the time when it got created. This was the time when some changes took place. This was the other time when some changes took place, and same was with this. If you just stop it and start it again, in that case too, the changes would be reflected. I just stopped the instance, right? But that isn't reflected here. Why? Because it takes a while for the log to get updated. Now, if you click on this thing, you can see the changes that are there. There are changes. 5 of those are configuration changes. The details are given as in what are the changes that have happened. You can check through the log as well. Are there any relationship changes? No, not for now. So if I do go ahead and attach a security group or something like that, or maybe attach a volume to it, the change would reflect as in, okay, this is a relationship change that has happened. So even that is possible if you want to. So this is what your AWS config does. It gives you details about everything that has happened and all the changes that have taken place till time. Apart from that, you can just go ahead and pick other services as well. Now I've come to the dashboard. If I click on this icon, now these are some of the options that you might want to consider, as in, can you just go ahead and search for something directly? If you have the ID, you can put the ID here and search for it as well. This would help you look up. So when you click on lookup, the list is shown down here. And this is the bucket that we have, right? You can see there's a log for this as well. And there was one change that happened at this time of the day. This was the time when I changed the permissions of the bucket. So that is why this change is reflected here. Whatever changes that are there, that would be given here. Plus, one more important point that you need to know is when you do go ahead and make certain changes, not all the changes would be monitored directly. For some changes, you have to set up certain policies as well, or have to configure some other things as well. For example, if I come to my EC2 instance, if I click on this icon, what you can see here is, if I scroll down, I have monitoring enabled, right? So I need my monitoring to be enabled for this instance to get monitored. In my case, what happened was when I started using AWS and AWS Config Service in particular, when I created an instance, monitoring wasn't enabled by default. So I did go ahead and make some changes, but those were not notified and I was wondering why is that the case. For that, I had to go ahead and enable monitoring as well. So I did that. And how do you do it? You go back to services, say EC2. It would give me a list of my instances here. Okay, this is the stopped instance. You can just click on it and this is the option here, monitoring. You have to say enable. Once you do it, it's good. You can just go ahead and look for tags as well. Now, if I go back to my config, the internet is a little slow for some reason. So yes, that is a little irritating at times. There you go. Yeah, I open my EC2 instance. Yeah, this is what it is. Now, while looking for it, I can search it in different ways as well, based on the compliance status, tag, and resources. So that is what happens. And once you do go ahead and create an instance, and if you put in all these properties, monitoring would be enabled. But then again, to reflect some other changes. Now, if I open this instance, I get all the changes shown here, right? As in this is what has happened. But for that, I also need to create an inventory first. If you click on it, it says manage instance inventory is unavailable. To configure an instance for an inventory collection, go to this console. Now, this is where you'd get all the information, as in why do you need an inventory and how do you create one. It's very simple. You can just come here and say AWS management. Sorry, it's AWS systems management. So you have the systems manager here. If you scroll downwards, go to insights, you actually have the option of inventory, and you can just say set up an inventory. It would ask certain details, as in what is the name and by when do you need to get notified. Schedule 30 minutes. After every 30 minutes, data would be collected in your inventory and that would be reflected on your config service. That is why it takes a little longer than normal time, is what I've told you. So when you do make changes after this duration, the changes would be reflected in your so-called config service for each individual resource. So once you do that, come here and set up an inventory and the inventory would be created. And once you do that, you can come here and view all the changes, that is in your AWS config service. One more thing, guys, if you want to get notified in the form of emails, we've actually gone ahead and set up a SNS topic, right? So you can actually go ahead and subscribe for that thing as well. For that, you have to search for simple notification service and this dashboard would appear. So if you click on topics, it gives you an option. Do you want to create a new topic? You can say yes if you want to, or you can use the existing one as well if you have any. Now in our case, we had created one, right? There you go. This is the one we had. So I have a subscription to this topic. You can just click on it and say actions. You can say subscribe to this topic. And to do that, it would give you an option. How do you want to subscribe? You can just click on email here and enter some email ID and put in that email ID here and just say subscribe. Now you have your topic ARN, you have your protocol, and you have the endpoint. And once you click on create, I'm canceling it right now. Once you click on create, you'd be given a notification in your email ID or in your email account basically. Subscription confirmation. You have to click on this link and your account would be created. So you'd be getting notifications each time there's an update, like it is in my case. As you can see, these are following updates and I've been notified with the updates, whatever have happened. This is the latest one, guys. See, it's 3:21, the time duration. I updated the account details is what it is saying. What I did was I actually stopped my instance, right? So that is what it notified me for, as in, okay, this is the change that has happened. So that is what your SNS does. It sends in messages saying that these are the changes that have happened. So if you go back to config, I just want to see whether that change gets reflected or not. I'm not sure that it would happen this soon. If it does, well and good, I would be able to show that change to you people as well. Let's hope it does. There you go, guys. There's a change here, right? And 7 changes happened in total. So 3:21. This is the change it is reflecting. And the change was we actually did go ahead and we stopped it. So that is the change that is reflected here. So if I just go back and start the instance again, in some time, the change would be reflected here. So this is how it works. It basically does go ahead and do all these things, as in you can monitor all the services, you can assign certain rules, policies, you can take care of all the relations that are there. Now, if you scroll down here, you can see there are relationships as well, as in how is this instance connected to other things and what are the other things that it is connected to. It has a volume that is attached to it and all those things. So you get all these informations and you get notified continuously. And my AWS is currently recording all the information that is going here. I mean, all the changes that are happening here. So it's your option as well, as in whether you want to get it recorded or you don't want to get it recorded. So yes, guys, this is more or less the demo part, and this is what I wanted to talk about.
How you can secure your AWS account using the AWS IAM services. Alright, so we're going to start with why do we need access management and then move on to what is IAM. After that, we're going to see what are the components, what are the different components of IAM, and move on to discuss the multi-factor authentication service offered by IAM. And towards the end, we'll be doing a hands-on wherein we'll be creating, or I'll be demonstrating to you an application which will upload your files to S3 using the IAM policies. Alright, so let's go ahead and start with today's session with the first topic, which is why do we need access management? Alright, so to discuss this topic, let's understand it using an example. Say you have a company in which you have a server And this server has everything in it. It has all the modules in it, and it gives you it gives different users the permission to use the different servers, right? Now, in your company, first of all, you should have an administrator which will have all the rights to access the server, right? So nobody in the today's IT world works on the root account, right? So there has to be an administrator account. So first, we will create an administrator account with all the permissions. Now, tomorrow, say a UI developer comes into your company, right? Now, a UI developer will only work on the graphical tools, right? So he should only be allowed the graphical tools and not some other tools. Maybe he shall not be given the internet access or something like that, right? Maybe he's not giving the PowerPoint access. Maybe he's not given some folders access, some drives access, anything like that. So all of that can be defined in the server by the administrator, and specific rights will be given to a UI developer, right? Similarly, if after that a business analyst comes in, so he should only be able to access the analytics module which is there in your server, right? He should not be able to get into the UI development part, or he should not be able to see the other aspects of what is there in your server, right? So each and every user or each every role will have specific rights assigned to them, right? And this is done by policies which are in turn given by administrators, right? So this is what access management is, that giving each role the specific rights that they deserve. And this is what we are going to accomplish today in AWS, right? So this is why we need access management. Let's go ahead and understand how can we accomplish this in AWS, right? So to accomplish this in AWS, you need a service called IAM. You have a service called IAM which uses this concept of access management and allows you to give it to your users who are going to use your account, right? So what is IAM? So IAM is basically a service from AWS using which you can give permissions to different users who are using the same AWS account that you have created, right? So in a company in any company, be it, you don't have to have 2 or 3 AWS accounts. You can have one AWS account on which a number of people can work, right? For example, you can define that maybe a developer would like to work on your AWS account, and he should only have the EC2 instances, or he should only work on the EC2 instances. You decide that, right? So you can define a policy like that, that only the developers will only be able to access the EC2 instances on your AWS account. Similarly, if say a database administrator comes in, so he should be only able to access the DB instances on your AWS account, and so on, right? So all of that is possible using IAM. But IAM is not only about creating users and creating policies. It's more, there is more to IAM, right? And hence we'll be discussing the different components of IAM now. So let's go on and see what are the different components. So there are basically 4 different components in the IAM service. So the first service is user, then we have groups, then we have roles, and then we have policies. Right? So the way we are going to go about these are, first I'm going to explain you each role or each service in IAM, each component in IAM, and then we're going to see how we can execute them or create them in the AWS console. Right? So let's start with the users. So the very first time you actually create a AWS account, that is basically the root account that you have created, right? So there is no user inside it. So why do we basically need a user? You need a user because you are supposed to give permissions to someone, right? So say I first of all want to give administrator rights to a user. Right? So you understand, you have to have an entity first to which you can assign permissions, right? So these entities are called users on AWS. So any person who wants to access your AWS account has to be added as a user in IAM, and then you can attach different policies onto that user. Right, so this is what user is all about. Let me go to my AWS management console and show you how you can create a user in IAM. All right, so give me a second. Alright guys, so this is my AWS sign-in page. Alright, so this email ID, when you log in through your email ID and your password, that is basically your root account. So what I'm going to do right now is I'm going to log in using my root account and first create a admin account for myself. All right, guys. So you should never work in your root account. You should always have an administrator account to work in. The root account should only be used when there is an emergency. Say you have been logged out of your administrator account, only then you should be using your root account. So the first thing that you should do when you enter your root account is go to IAM, which is just right here. Go to IAM and then you will have this dashboard thing, right? Over here you can see there is a thing called users. You will click on users and you will click on add user. All right, so now it will ask you for the username, so you can provide a username. Say I'll add my name first, so that be Hemant, right? And what kind of access do I want to give to this particular user? So there are basically two kinds of access that I can give. First is the AWS Management Console access, and then we have the programmatic access, right? So what is these two? If you want to, so there are basically two ways you can access the AWS resources, right? You can either access them using APIs, that is using your code. Say you have created an application which is interacting with your AWS resources, right? So in that case, if you're interacting with the APIs, using the APIs, that is called the programmatic access. Right. Secondly is the AWS Management Console access. That is when you are using the AWS website to actually deploy resources or create or remove policies or whatever. Right. So that is called the AWS Management Console access. So for my user, I'd be giving it both the accesses, that is programmatic access and the management console access. Also guys, when you enable the programmatic access, basically you get the access key and the secret key as well. What are these? I will be explaining you in a bit. Alright, so we have selected both of these options and then move ahead to choose the password. So do you want an auto-generated password or a custom password? I'll choose a custom password since I'm creating account for myself, right? So I'll choose a custom password. And do I want to reset the password on my first login? No, I don't want that. So I'll click on next permissions. All right, so what kind of permissions do I want my account to have? I will be configuring that over here. So as of now, there are no groups. There is no existing user that I can copy from. So I'll attach existing policies, and since I want to attach the administrator access, that is the first policy over here, I'll select that and click on next. Alright, so you can review all the settings that you did over here and click on create user. This will create a new user in your AWS account. So as you can see, I have got my access key ID and a secret access key. Now guys, the secret access key, you only get it to see one time, only one time when you have created your account. So it is essential that you store your access key and your secret access key once you get this page. All right, so let me store it quickly. So this is my access key ID. Why we are copying it, you'll get to know during the session. Don't worry. And my secret access key, which is this. So let me copy this and paste it in the notepad. Alright, so don't worry, you might be thinking that I've exposed my secret key to you, so I'll be deleting this account afterwards, so you don't have to worry about that. Alright, so I've got my access key ID and my secret access key, so that is done. Now what I'll be doing is I'll be logging out from my root account and logging in this user account that I just created. Alright, so one more thing that you have to be very careful of, that you will not be logging in through the same login page that you just saw, right? So you'll have to log in through a different login page now, and the URL for that is this, right? So you'll be logging in through this link as of from now on. So whenever you create a user, if you want them to log into your account, you have to give them this link to log into, right? So let us copy this link over here and log out from our root account. Alright, so I've logged out. I'll close this and I'll come here and go to this particular link. Alright, so once you reach this particular link, it will be asking you the account name, which will be self-filled by your link, right? So you have to give your username now, which is Hemant, and then the password. So I'll type in the password that I've given it and click on sign in. So now I have basically signed in to the user that I've just created on my root account, right? So I no longer have to use my root account. I can basically lock away my root account for emergency purposes. I'll be using my administrator account from now on. I can do everything from my administrator account that could be done from my root account as well. But there are cases wherein you get locked out from your administrator account. In that cases, you will be needing your root access. All right. So moving on, guys. So I'll go to IAM now. So as you can see, we have created a user and we have logged into that user. And if I go to IAM now, you can see that it will show that one user has been created. That is here. All right. So let's get back to our slide and discuss the next component. All right, so we've discussed what are users. Let's move on to the second component, which are groups. All right, so whenever you create users, they can also be combined into groups. Now, why do we need groups? We need groups because say, let's take an example. So say you have 5 users and these 5 users have to be given identical access, right? Say these 5 users belong to the development team and the development team has to have some common access that they all will have, right? Now, one way of doing this would be that I would go to each and every user and attach a policy that they need, right? The smart way to do this would be to include them inside one group, and to that group I will only once I will attach the policy and it will apply to all these 5 users, right? So these are why groups are very important. Now, how we can create groups, let me shed a light on that. So you will go to you can see you can click on groups over here, and what you'll do basically is you'll click on create new group. All right, so let me give the group name as live demo. All right, and I'll click on next step. Now it will ask me the policy that I want to attach to this particular group. All right, so say for example, I just want this group to be able to access the S3 service from AWS. So what I'll do is I will select the policy which says Amazon S3 full access, and I'll click on next step. Now this policy basically tells you that you're going to only use the S3 service in the management console and no other service. All right, so I'll click on create group, and now whichever user I will be putting inside this group will have this property. All right, so I don't have to configure the policy for any user now. So what I'll do is I'll create a new user now. So say I create a new user saying test. All right, and then I'm not giving him the programmatic access, I'm just giving him the management console access. All right, I'll click on this and I'll give it a custom password, and then I don't want him to reset his password. I'll click on next. Right, and now it is asking me whether I want to include it inside a group. So yes, I do. I want to include it inside the group that I've just created, and I'll click on next and review all the settings that I've just did and click on create user. All right, so the test account has just been created. Now, as you can see, guys, in the case of my account which I created, I got an access key and a secret access key, right? So in this case, I'm not getting any because I didn't select the programmatic access. Only when you select the programmatic access, it will give you the key so that your application can actually interact with the services that you have launched. All right, so I've created a test user successfully. Let's log into this test user. So I will type in the URL that has been given to me. Right, now when I reach this page, I'll enter the username as test and the password as what I have entered, right? And I'll click on sign in. Now with this, you can see that I will now be able to see the management console. The management console will exactly look like how it was used to see, how I used to see it in my root account or my administrator account. But when you will try to access, say, a service which you have not been assigned to, say, for example, I only have access to S3 right now because I've deployed it in the group where it has only the access to S3. If I try to go inside EC2, let's see what will happen. Right, so it says you're not authorized to describe running instances. As a matter of fact, I'm not authorized to see anything on my EC2 page. All right, so that is because I don't have access to the EC2 dashboard. But let's see if I can see the S3 dashboard. So I'll quickly go to S3. And if I have the S3 access, I'll be able to see all the buckets which are there in my S3. And yes, I do. So let me go inside a bucket and delete something so that, all right, so let me delete an object from this particular bucket. So yes, I can delete it. All right, so let me check if what happens if I delete or I detach this particular policy from that group. All right, let's see what happens. So I'll go to IAM and I'll go to groups. I'll go to this particular group and I can see that the policy is listed over there. What I'll do is I'll click on detach policy and let's see what happens now. Right, so I'll go to management console. So if now I try to access S3, it will show me that access is denied. Right, so I no longer have access to the S3 service on my AWS console. So this is how you can control access to different users. You can revoke access, you can include access, right? You can do all of that in IAM. All right, so let us come back to our slide to discuss our next component. All right, so we've discussed what are users, we've discussed what are groups. Now let's come down to roles. All right, so roles are similar to users, but roles are actually assigned to applications. All right, so users are actually assigned to people, right? So whenever you have a developer in the company, you will assign him the developer roles, right? But when you have roles are basically assigned to applications. How? Let me explain you. Say you create an EC2 instance, and inside that EC2 instance, you're hosting your web application. Now that web application has been designed in such a way that it has to interact with your S3 services, for example, that we'll be doing today. I'll be showing you the demonstration today for this, right? So say that application has to interact with the S3 service. Now, if I want that application to interact with the S3 service, I have to give it permissions. And to give it permissions, I will use role. So I will create a role wherein I will specify that this role can access the S3 service, and I will attach this particular role to that particular EC2 instance in which my application is hosted. And in that case, my application will be able to interact with the S3 service, right? It might sound complicated, guys, but it is very easy to implement. Let me show you how. So what I'll do now is I'll go back to my management console, which is here. All right, I'll go to the dashboard and say I'll go to roles now. All right, so I'll create a new role. Now roles can be assigned to any AWS service which is listed here. What I'll do is I'll assign it to I'll create a role type of EC2. All right, so I'll select Amazon EC2. And what type of role do I want to apply it to? I want to say have the access to S3, right? So I'll select Amazon S3 full access over here and I'll click on next step. So it'll ask me the role name. So let me specify the role name as Edureka_1, right? And I'll click on create role. So with this, a role has now been created, but mind you guys, I've not attached this role to any EC2 instance, right? So what I'll do now is I'll go to my EC2 console. So over there, I already have built an EC2 instance. It is stopped, so I'll start it and attach this particular policy to that EC2 instance. All right, so my EC2 instance name is Hemant_1. So here it is. I'll go to actions, I'll start this particular instance, right? And what I can do is I can attach the policy using instance settings, it says attach or replace IAM role. I'll go here. I will go to the drop down and select the role that I've just created, which is Edureka_1. I'll select that and I'll click on apply. Now with this, what will happen is my role is now my EC2 instance is now configured to interact with the S3 service in this particular account. Alright, so any application that I deploy in this EC2 instance will be able to interact with the S3. Okay, so I don't have to specify any access key, any secret access key. If you're still confused with that, be patient. We are getting on to where do we actually use these keys and where do we not. Alright, so this is what your roles are all about, right? So roles, like I said, they are for resources in AWS. Users are for people. Roles and users are similar things. You attach policies onto them and they basically identify a particular instance or a particular person as the owner of that particular service, right? So I've discussed what roles are. Let's move on and discuss policies. So if you think about it, guys, we've actually been dealing with policies, right? So policies are nothing but permissions that you give to your with whatever role or user or group that you have created, right? So for example, I want to give the EC2 instance access, right? So that EC2 instance access is basically a policy that I'll be attaching to the user or to the roles. All right, let's see how we can create policies, guys. So I'll go to my management console. I'll go to IAM. Right, so you can either create policies or you can actually use the already existing ones. So there are a couple of policies that have already been created in your AWS account, but you can go ahead and create your own policy as well. All right, so let me show you how. So say for my test account, what I'll do is I will go inside test account. Alright, and I will add permissions and I will attach existing policies directly, and here I am, guys. So now you can create policies as well. So you see the tab over here, guys, it says create policy. So if you feel the kind of policy that you want to create is not listed over here in the default policies, you can actually create one. And creating a policy is very easy, guys. You'll just click on create policy and you will see this page. Alright, so you'll have three options. You can either copy an AWS managed policy, that is a default policy. You can create your own policy by just typing in the JSON code. And if you're not comfortable with coding, what you can do is you can use the policy generator. Now, what is policy generator? Let me explain you. So with policy generator, you just have to select what effect do you want. Do you want it to allow it or do you want it to deny it? Right? So say I want to allow the EC2 service to this particular test account. All right, so I'll go to EC2. All right, here it is. I selected EC2. What kind of actions can he perform? Say I want to give him all the actions. You can do anything with EC2, and resource name is basically a particular resource. So with ARN you can identify a particular resource. So I don't want a particular resource to be assigned to him. I want he can access every resource in EC2, right? So I just add star for all of them, right, and click on next step. So with this, as you can see, it has automatically created a policy document for you. All you have to do now is click on create policy, and it will create the policy for you. So as you can see, there were 18 customer managed policies. There are now 19. So I can go here and select the policy over here. All right. So if I go to my user now, which is test, and go to permissions, I will just click on add inline policy, click on select, again go to EC2, select actions, all actions, right, and put it to star. So I'll Click on add statement, click on next step, and click on apply policy. So a policy has been applied on the test user that it can actually access the EC2 instances now. So if I go to my test user now, in which I was not allowed to access the EC2 instances, I can actually use the EC2 instances now. So if I go to EC2, you can see it will not give me the access denied thing, right? So I can access all the instances over here as if I was using the root account, but only for the EC2 service, right? If I go to S3, you can see I will still have the access denied page because I've not been assigned the access to this particular service. All right. One more thing, guys. What if you add an allow and a deny policy together inside a group? What will happen then? So in that case, so since I have allowed EC2 access, what I'll do is I'll deny EC2 access as well in this particular user. So I'll create one more policy and I'll say deny. I'll select EC2. Right, I'll select the actions as all actions. I'll give the resources all, add the statement, and click on next step, apply the policy. So now I have denied EC2 instances as well and created and allowed EC2 instances as well. What do you think will happen now? So if now I try to go to EC2, let's see what will happen. So it will say you're not authorized to use EC2 anymore, because whenever you're creating policy, guys, you either get the allow option or the deny option. If you have selected both of them, it will always prefer the least permission that you have given. So in our case, that is the deny option, right? So it will always deny the case even if you have allowed it in the same user, right? If you have mentioned that that particular service has to be denied to that particular user. All right, so this was about policies, guys. Let me come back to my slide. So we have discussed what are users, what are groups, what are roles, and what are policies. Let's go ahead and discuss the very important part of authentication, which is called the multi-factor authentication. So what is multi-factor authentication, guys? So multi-factor authentication is basically something like OTP that you get when you're logging into your Gmail account, right? So you enter your Gmail email ID, you enter your password, and when you click on continue, it will ask you for your OTP, right? So same is the case here as well. You can configure your AWS account in such a way that you will enter your username, you will enter your password, and when you click on login, it will also ask you for a code that has to be given to it. Now that code is basically the multi-factor authentication thing that we're talking about. So there are basically two layers of security now. One layer is a password and second layer becomes the code that you'll be entering, right? Now with AWS, there is an application called the Google Authenticator, right, which you can use to create a virtual multi-factor authentication device. Now, for those of you who already are using multi-factor authentication in your companies, so there's a thing called Gemalto, right? So people who work from home and they have to connect to their company's network, the way you connect it is using a Gemalto token, right? And so those of you who are from the IT background, you can relate to it, right? But if you want to go through a simpler way, you can actually create a virtual multi-factor authentication device. And to create that in your AWS is pretty simple. You just have to download an application called Google Authenticator on your phone, and you have to connect that application to your AWS account, and that is it. Now it might sound tough, but it's very simple. Let me show you how. So you will basically go to your AWS management console, and you will go to the particular user that you want that multi-factor authentication to be assigned to. All right. So for example, I want it to be assigned to the test user, right? So what I'll do is I'll go to users, I'll go to test, right? And in the security credentials tab, I will have this page which says assigned MFA device. So it says no as of now. So I'll assign it a device. I'll click on edit. And now it'll give me an option between a virtual MFA device and a hardware MFA device. Now I have to choose among the two. So since I said you can create a virtual MFA device very easily, so I'll select the virtual MFA device. And now it is basically asking you to install the application on your phone. So we have already done that. Let's click on next step, and now you'll be presented with the screen. So basically now what you have to do is you will be logging into your Google Authenticator app, and you will be scanning this barcode from your phone. So let me show you how. Let me connect my phone to the computer so that you can see the screen. Give me a second. Alright, so this is a screen to my phone, guys. So what I have to do now is I'll have to go to the Google Authenticator app, and it'll ask me to create an account. So I'll click on begin, and once I have that, basically now I'll have to scan the barcode from my mobile. So the way to do that is I'll click on scan a barcode, and then I'll scan this barcode over here. Right, it might take some time, so be patient. Yeah, so it's done. Now you're all set, right? So you'll just click on done, and now you have to enter two codes that you will be receiving on your Google Authenticator. So basically these codes change from every 30 seconds, right? So I have to enter these codes over here. So it's 204 and then 020 and 353. 020-353, and I have to enter the next code as well. So let's wait for the next code, and it's 127891. So I'll enter that over here as well. So it's 127891, and that is it, guys. So now I'll click on activate virtual MFA, and it says the MFA device was successfully associated. So I'll click on finish, and that is it, guys. You're done. Right, so now if I log out from my test account, that is from here, right? This is my test account. So if I log out from here right now, and try to log in again using test, so I'll come to my normal login page, right? So I'll enter my username and my password, which is this, and now I'll click on sign in. So now it'll ask me for the MFA code. So let's see what is our MFA code as of now. So it has changed to 734552. So let us enter that, 734552, and click on submit. So with this, I'll now be able to log in to my AWS console using the test account, which I configured using the administrator account in IAM. Alright, so it's very simple, guys. You can actually get world-class security with a click of a button using IAM. Alright, so we have seen how we can do multi-factor authentication. Let's move on to the hands-on part now. So this is what you guys have been waiting for. So just give me a second so that I can configure everything on my end. Alright, so what we'll be doing now is I have created an application which can interact with the S3 service. Alright, so using that S3 service now, we'll be uploading files to our S3 console. And how we are going to do that? First, we are going to do that using localhost, and that is where our secret keys and my access key comes in. And then we have assigned a role to our EC2 instance, right? So we'll be accessing that website using EC2 without the access key and the secret access key, and we'll see, do we get the access to our S3 service or not? All right, so let us do that. So now what I'll do is I will go to my localhost application. So guys, this is basically my application. What I have to do is I'll choose a file, I'll upload a picture from any sample pictures, and then it'll upload it to a particular bucket that I've defined in S3, and that the bucket looks something like this. Right, so that bucket's name is quarantine demo. So let me show you the bucket. So as of now, I think there are some objects. So let's delete those objects. So here it is. This is the bucket quarantine demo. So I have like 3 objects over here as of now. So let's delete these objects. All right. So now what I'll be doing is, this is the code for my application, guys. All right. So in this code, as you can see, I have not specified the key and the secret key as of now. So I'll get the key and the secret key from here, right? So let me show you without the secret key and access key, how is this localhost website functioning. So if I try to upload a file as of now, say this is the file that I want to upload, I'll click on upload image and I'll get an error, right? Because it is not authenticating itself to the service that I want to go to. So now I'll add the credentials, that is the key and the secret key. Now the way to do that is like this. So I'll copy it and I'll paste it here. I'll delete this and this as well, not required. And now I'll paste my key and my secret key, which is this, right? So I'll copy the key over here and then my secret key as well over here. And now I'll save it. And if I try to access my localhost website now, I should be able to upload a file, right? So if I try to upload the file now, it says well done, S3 upload complete. So these credentials that I've just entered are basically credentials for my Hemant account. So if you want to see where did I get these credentials from again, you can basically go to users, you can go to your user and you can go at security credentials, and over here it will list you the access key ID. It will not list you the secret access key because it is only available once. You can only use it once, copy it once, you will not be able to see it again. And if I make this particular key inactive from over here, and if I try to upload anything again, I will again get an error because without the keys my account will not be authenticated to the S3 service. So as you can see, it says invalid access key because it is not valid anymore. All right, so I can make it active again, but that is not required as of now. So what I'll do now is I've already configured this website on the EC2 console. All right, so let me go to my EC2. Right, here it is. So remember in the starting of the session, we created a role for S3 full access, right? So that role has been attached to my EC2 instance. So let me show you the website. Here it is. All right, so I can access the website on my EC2. Now, if I choose a file as of now and I try to upload the file, I'll be able to do so because my policy has been attached. Now, let's see what happens if I detach the policy, right? So I'll go to this and I'll select no role, click on apply, yes, detach. And now if I try to upload a file again, as you can see, I see a blank page, which basically means that an error has occurred. All right, so I am not able to upload any file because my role has been detached from my EC2 instance. So if I want it to be working again, I'll just simply go here, go to actions, settings, attach the role, that is this, click on apply, and it'll again work. Right, I'll choose a file, say this file, upload the image, and it'll work again. Works like a charm, right? So that is it, guys. You don't have to configure much. You just have to have the knowledge of IAM, and with that you can do complex procedures with the click of a button, and you don't have to swear about it. All right, you might be wondering, did I change anything in the code when I uploaded it to EC2? So you don't have to do anything, guys. You just have to delete the credentials, key, and secret, and you will upload the code as it is. You don't have to change anything. If it doesn't have the key mentioned in this particular function, it'll basically get those keys from the metadata of EC2, and metadata is the place where your role is actually assigned, or your role is actually attached, right? So if it doesn't find the key in the code, it basically goes to the metadata and picks the key from over there.
We will start by explaining you what a VPC is and why is it required. We will then move on and discuss about subnets and its various types. Later, we will do a hands-on wherein we will create a VPC using the AWS console. While creating the VPC, we will also discuss the critical components of VPC. Post that, we shall discuss about the important topics, that is VPN and direct connect. End of this session, we will give you the recommendation for the VPC best practices. Meanwhile, kindly subscribe to us and don't forget to hit that bell icon to never miss an update from the Edureka YouTube channel. Also, to learn more about AWS and cloud computing, do check out our AWS training program, the link to which is given in the description box below. Let's start with the basic question, what is a VPC? In order to understand, let us think about today's scenario. Today, we are facing a pandemic situation. In this situation, the utmost priority for all of us is to maintain a private sanitized space, even when we are visiting a public space. We need to take care that the social distancing norms are being followed. Similar to this, enterprise want to use all the services available in AWS, but they want to do it in their own private sanitized space. This space is provided by a service in AWS known as VPC. VPC provides us the private space that is required inside AWS, wherein we can define our own network and also use all the services of AWS as per our requirements. So the technical definition of a VPC is, as can be seen from the illustration, let us try to understand it. A VPC is defined in a region of AWS. As we all know, there are various availability zones within the region. It should be noted here that the VPC can be spread within a region in all the availability zones. In this illustration, there is shown a region with two availability zones. The VPC is spread among both these availability zones. The other point to be taken into consideration is a VPC is generally a large network. In order to have better control over the network, the large network of a VPC is further divided into smaller groups or smaller chunks. These smaller chunks within VPC are known as subnets. So now let us discuss why a VPC is required. For an enterprise using the cloud or migrating to a cloud, the most important concern is privacy, security, and the security of their proprietary data. They are not comfortable when they need to use a public network of a cloud service like AWS in order to use their services. Therefore, a VPC provides them an extra layer of security wherein they can define their own network. It not only gives them security, but it also gives them ease of connecting to their instances or services. When we create our AWS credential, a default VPC is created, but in industry or at a production level, we need to customize our VPC. The tools required to customize our VPC is provided by AWS, wherein we can explicitly create subnets, NAT, security groups, internet gateway, etc. All these terms shall be explained with the hands-on in this session. Before we move and understand the components of what makes a VPC, let us first spend some time and understand what is an IP address. The IP address or the Internet Protocol address is a logical numerical label assigned as a unique identity to each device in a network. In more lay terms, it can be understood as every human being has a fingerprint. It is unique to each of us. Similarly, every device which is connected to a network has an IP address which is unique to itself. It's like a fingerprint for that device. Let us get more deeper into understanding of an IP address. Take for illustration the computer's IP address 155.67.35.0. It consists of 4 parts. These 4 parts are known as octets. Each octet contains 8 bits. So in all, the IP address consists of 32 bits. 4 octets, each octet consisting of 8 bits. Therefore, 4 into 8, 32 bits. Let us now understand another important topic or important definition, that is CIDR, classless inter-domain routing. CIDR is basically a methodology to represent an IP address. Let's take an illustration. 172.31.0.0/16. The /16 part here represents the number of bits present in the network ID. Let us understand it a little deeper. As explained earlier, the IP address consists of 4 octets and each octet consists of 8 bits. The 16 here denotes the number of first 16 bits out of this 32 bits which are locked. So in short, in this IP address, the /16 denotes that in this network, this 16 bits are locked. So what does it signify? It signifies that the remaining 16 bits out of this 32 bits are available for use in the network. Therefore, the total bits which are available to be used in the network are 32 minus 16 is equal to 16. Therefore, the total number of IP addresses which can be generated from this 16 bits would be 2 raised to 16. Let us take, for better understanding, one more illustration. Suppose 172.31.0.0/28. This is a little tricky as 28 is not a multiple of 8, but let us understand. So this denotes that in this IP address, out of 32, 28 bits are locked. The number of bits which can be changed in this IP address are the last 4 bits. Therefore, the total number of IP addresses which can be generated from this CIDR are 2 raised to 4 or 16 IP address. What does this denote? It denotes that this IP address is a much larger network wherein you have provisioned it with the larger number of IP addresses which can be assigned within this network. Whereas in this IP address, the number of IP addresses available to be used within this network are very small. Therefore, classless inter-domain routing reduces the wastage of IP addresses by providing the exact required number of IP address to the users. It is also a methodology by which we can gauge the vastness or the largeness of the network it has been assigned to. Now that we have understood the basics of IP address and CIDR, let us see what are the key components of VPC. The key components of VPC that we would be talking and also discussing and doing hands-on on are the following. 1. Internet Gateway and NAT. It logically enables routing of traffic in the public network. That is, it gives us the gateway like a firewall from which our VPC can connect to the internet. DNS, standard which resolve names used over the internet into IP address. Elastic IP. It is a static IP which never changes. VPC endpoints. Private connection between your VPC and other AWS services without using internet. This is one of the key features of VPC, wherein we will be discussing that in detail during this session. Network interface. A point of connection between a public and private network. Egress only IG allows only outbound communication from EC2 over IPv6. Route tables, another important feature to understand VPC. It defines how a traffic is routed between each subnet. VPC peering, connection between VPCs. We will be discussing about each of these components during the course of this session. Now that we have understood what is an IP, what is CIDR, and what are the key components of a VPC, let us understand what are subnets. As explained earlier, a VPC may consist of a large network. In order to have better architecture within this large network, we may divide it into smaller networks. So it is a concept of network within a network. It may also be understood that the large network of VPC has been divided into smaller networks. These smaller networks are known as subnets. Therefore, a subnet is a logical subdivision of a larger network. Here comes a picture of CIDR. IP addresses with common prefix are used in the same subnet. As can be seen in this illustration, 172.31.0.0/16 is the IP address of this VPC. We have two subnets here. One is known as a private subnet and the other public subnet. We have assigned a common prefix of 172.31 to both these subnets, and the IP addresses have been divided. The various types of subnets are private subnet and public subnet. Why is this a requirement? Let us understand it, maybe with the example of a website like Facebook. There are certain parts of Facebook which we require access to, or which Facebook wants us to access. But there are other parts of Facebook which Facebook wouldn't want us to get access to. That is their database. This bifurcations can be done using private subnet and public subnet. When we do hands-on, we will understand how do we categorize a subnet which has been created inside a VPC as private or public. So let us now start our hands-on in order to better understand the concepts which we have understood till now. That is VPC, region, availability zone, and subnets. Let us start our hands-on and reiterate what we have learned. In this hands-on, we would be creating an architecture similar to the illustration as seen in the image. Within the AWS, we will be creating in one of the region a VPC. In that VPC, we will be creating two subnets. One is the public subnet and the other is a private subnet. We will then provide an internet gateway which will give access to the subnet to the public network or the internet. Also, we will understand how we shall create a router or a route table. We will be creating a route table for each of the subnets that we are creating and understand how important it is for VPC. So let us start this session. So let us now log in to our AWS console. We are signing in to our AWS console. So this is the dashboard which reach into when we start our AWS management console. The point to be taken into consideration here are: 1. This is the region wherein we are going to create our VPC. It should be noted there are various regions. We have chosen this region in which we are going to create our VPC. Now, how do we access VPC as a service? We can do it either by searching on the search bar, or we may go and click on the VPC service inside networking and content delivery section of AWS. We have launched into the VPC service of AWS inside North Virginia region. Now, we need to create our VPC. AWS provides us one of the wizards by which we can launch a VPC, but we shall be creating our VPC by clicking on this link. Let us first, as you may see, there is already a VPC residing here. This is the default VPC which I am talking about. This default VPC comes packaged whenever we create our AWS credential. We are now going to create our own custom VPC. Let us name the VPC as Edureka Demo. Before we discuss about a topic known as CIDR, herein comes its use. We need to allocate an IP address to this VPC in the form of a CIDR block. We are just providing it 10.0.0.0/16. So basically we are creating a VPC in which we can assign, as explained before, 2 raised to 16 IP addresses. Let us create this VPC with the default settings. The VPC has been created. The next thing which we discussed about was subnet. Let us understand what we did till now again. We created a VPC inside the AWS region, North Virginia. Now, we are going to create inside this VPC smaller networks or smaller chunks of this network known as subnets. We go into the subnet module. There is already one default subnet available. We are going to create our own subnet. The first subnet which we will create is the private subnet. Let us name it as private subnet. The VPC inside which this subnet will reside, we need to select it. So we are going to select the one which we created, that is Edureka demo. The availability zone. This is what I was talking about. We created a VPC inside the region North Virginia. In North Virginia, there are 6 availability zones. In the illustration which we had discussed, it had 2 availability zones. In North Virginia, there are 6 availability zones. What we are going to do is, we are going to create a private subnet in one of the availability zones. Let us select this one. The other thing to be noted here is, as soon as we associated this subnet with the VPC, the corresponding CIDR of the VPC has been mentioned here. Now we need to mention a CIDR block for the subnet which we are creating. It needs to be mentioned here. We need to give a CIDR block here, which is a part of this network. So 10.0 will remain fixed. As explained earlier, the first 16 bits of this network or IP address is blocked. So 10.0 cannot be changed. So we change the third digit or the third octet as 10/24. So we are blocking in this subnet the first 24 bits 10.0.1. So it has to its dispose 2⁸ IP addresses which can be assigned within this subnet. Let us create this subnet. Herein, the first subnet, that is private subnet, has been created. Now let us create another subnet which is our public subnet. Public subnet. We assign this subnet again inside the VPC Edureka demo. We can assign this public subnet in the same availability zone which we did for private subnet, or we can have it in other availability zone. For this demo, let us create this subnet, that is our public subnet, in a different availability zone. As explained, we can now assign IPv4 CIDR block to this subnet by fixing 10.0 and assigning it a different IP address. This is the subnet which we are going to create. Perfect. Till now, whatever we have done is what we have discussed. We have created a VPC inside the region North Virginia of AWS services. In the VPC, we have created 2 subnets. One is the private subnet and the other is the public subnet. It can be noted here that these 2 subnets have been assigned to these 2 VPC. So within this VPC, we have these 2 subnets. We have also assigned the IP address, or we have defined the IP addresses for our VPC, and accordingly we have assigned a IP address to our subnet. The next part after creating subnet is creating route table. So what is the route table? Let us understand that. Route tables are the set of rules which are used to determine where the network traffic has to be routed. It specifies the destination subnet and the gateway router to reach it. So basically, a route table is a log wherein we maintain all the rules, or we specify all the rules by which we say which subnet will communicate with internet in what way. Let us better understand it with the hands-on. Herein, there are default route tables created. One of the route table you can see has already been created for Edureka demo. This is the route table which is created by default, but it is a standard that we need to create a route table for the subnets which we have created. So let us create for the 2 subnets which we have created in our VPC 2 route tables. The first route table, we will name it as public RT. The VPC is Edureka demo. So now we are creating this route table. Similarly, let us create another route table, that is private RT, for the VPC Edureka demo. Now we have created the two route tables, but now we need to assign the subnets which we have created to the respective route tables. That can be done by clicking on the created route table and going into this tab of subnet association. So now we will associate our subnet with the respective route tables. So we click on edit subnet association. We see that there are two subnets which we have created, that is private subnet and public subnet. The name of this route table is private RT, that is private route table. Let us assign the private subnet to this route table. This basically means all the rules, all the conditions of how this subnet communicates with the router will be logged into this table, that is private RT. Similarly, let us associate the subnet with public RT route table. If we click on edit subnet association, we see again that the two subnets which we had created for our VPC Edureka demo are listed here. Now it can be noted here that it shows one of the subnet, that is private subnet, has already been associated with this route table. Therefore, we shall now associate the subnet, that is public subnet, to public RT. Done. So the other thing it needs to be noted is this is the default or the main route table which has been created as we created our VPC. These two are the route tables which we have created, one for the public subnet and the other for private subnet. Now let us understand what an internet gateway is. As can be seen in this illustration, we have our public and private. So one of the public subnet needs to communicate with the internet. How do we do that? How will we provide that gateway to public subnet so that it can communicate with the public network or the internet? For that, there is a service provided by AWS within VPC that is known as Internet Gateway. This Internet Gateway shall be assigned or shall be linked to the subnets which we want to be connected to the internet. Thus, the Internet Gateway is a VPC component that helps instances to communicate over the internet using targets provided in the route table. Let us now understand how we can create this Internet Gateway. I'm going to create a new Internet Gateway. Let us name it as Edureka Demo IG. And with the default settings, we will create this Internet Gateway. This Internet Gateway has been created, but it is right now in detached state. Therefore, we need to attach it to one of the VPCs. So here we click on attach to VPC. We select the VPC to which we want this Internet Gateway to be associated. And we create the attached Internet Gateway. Now, if you see, the status has changed from attached to detached, and it has been attached to this VPC. So let us understand or summarize what we have done till here. We created our VPC in a region North Virginia. We created two subnets within that VPC, private and public. We created for each subnet a route table, and now we have assigned or we have created an internet gateway for our VPC Edureka Demo IG. Now in the route table, we need to update the table by the rules or by the log that which subnet can connect to the internet gateway. Remember, as explained earlier, internet gateway provides us the access to internet. So here the public RT needs to be provided that access. How do we do that? We go to the tab routes, we edit routes, we add a route 0.0.0/0 and we select in this tab the internet gateway. Once we do that, we can see in the drop down the gateway which we have created. We select that and we save the route. So basically what we have done is we have created a route for our subnet to connect to the internet. For that we have provided the information in the route table. Thus till now we have created our VPC, we have created two subnets, we have created an internet gateway, and we have updated our route table by mentioning that the public subnet can connect to the internet using internet gateway, and we have assigned the respective gateway which we had created. Now, let us create two instances within our subnet. Let us go here, click on EC2. We shall now create one instance each for the two subnets which we had created. We go to instances and we launch an instance. We need to select a machine or an instance. We select the default one and we configure our instance. So now we are going to create our EC2 instance within one of the subnets. Here you can see that the VPC which we have created, one is the default VPC and the other is a custom VPC. We can select our custom VPC from this drop down. Within that VPC, we have two subnets, private subnet and public subnet. This instance we are going to create for our private subnet. So we select the private subnet. Auto assign public IP. We all know that the instances which we want to create in our private subnet need not be exposed to the internet. Therefore, we will not assign any IP address to it. To do that, we will disable auto assign public IP. We will next look into storage. We will keep it as default. Add text, we will keep it as default. For configure security group, this is another important aspect of a VPC. Now, AWS provides us security group, which is at the instance level. So at the instance level, I can mention who all can connect to this instance. Suppose I mention that apart from SSH, I would want HTTP and HTTPS to be included in the protocol wherein we can communicate with the instance. These details at instance level can be mentioned in this section. We have just done that and we launch our instance. We will now need to create a key pair to communicate with this instance. I will use a key pair which I have already created. You may also download a new one by clicking a create new key pair, or you can click on choose an existing key pair. I shall use one of the existing key pair. Should be noted here, you can also create a new key pair. You can just name the key pair and download it. For now, we will use a already existing key pair. So the instance has now been created. Let us go and have a look at it. As can be noted here that an instance has been created and the key name is Edureka. There is no public IP address assigned to it. Let us name this instance as the private instance. Now let us launch another instance for our public subnet. Select. Next, let us follow it. Here in configure state instance, let us have a look. Herein, for the network, we use our private network, VPC network that we created, Edureka demo. In the subnet, we need to now create this instance for our public subnet. We need to assign a public IP to it so that we can communicate to this instance. So for auto assign public IP, we will click on enable. Next, we will keep it as default. The tag section will be kept as default. In configure security group, again, we may add more rules such as HTTP, HTTPS, and let us launch this instance. Again, let us use an existing key pair, that is Edureka demo. Let us look at the instances which we have created. As you may see, the status for the newly created instance is still in pending status. Let us, in the meantime, name the instance as public. The instance state has changed from pending to running. The other thing to be noted here is we had requested AWS to assign a public IP to it. It has done this. So now we can communicate with this instance using this public IP address. Let us go to our command terminal now and try to communicate with this instance. So now I open the terminal in which I have our key pair, that is Edureka demo. How do I connect? What is the command to connect to my instance? I can go here. I want to connect to my public instance. I can click on connect, and here in the SSH client tab, this is the command provided by which I can connect to this instance. I shall pass this command in my command terminal. And here I have now entered into my instance, that is my public instance. Let me now use the internet from this instance. Let me ping google.com. As you can see, it has started communicating with Google and is exchanging packets. Similarly, let us now connect to the other instance which we have created, which is the private instance. It needs to be noted here that the private instance has no IP address. So we cannot connect to this, but let us try doing that. We use again the SSH client provided, exit out of our public instance, and we paste for our private instance. As you may note now, it is trying to make a connection with the instance, but it is being refused, so it is not able to connect. Yes, so you can see this error now. Connect to host 10.0.1.85 port 22 connection timed out. It was not able to connect to that instance. It is obvious because there was no IP address assigned to that instance. Now that we have seen that we are not able to connect to our private instance, we can try connecting to our private instance through our public instance. So what we'll do now is we'll access our public instance. In that public instance, we will give a certificate which is required to access private instance. So we will use the network within our private cloud, wherein we will try to connect our public instance with our private instance. So let us do that now. I connect to my public instance. So now we have connected to our public instance. So now let us connect to our private instance from our public instance. So we take the sudo access of our private instance by writing this command. Let us create a blank PEM file which will contain the key to connect to our private instance. So we have created a new file, that is my.pem file, in which we will now insert the key required to connect to our private instance. I will copy paste this. I go to my command terminal. I connect to my public instance. Yes, so I have connected to my public instance. Let us now take a sudo access to this machine or to this instance. We now create a Vim file access.pem to connect to our, in which we will pass the security key required to connect to our private instance. I will copy paste the key which is there in Edureka demo to my access.pem file which I am creating. I will save this. I will now give it the read write access. And now I will attempt to connect to my private instance. Let me modify the key name before passing it on the command line. Yes. Okay, I misspelled the name of access. It should be ACC. Let us do that. Yeah. As you may now see that I have changed the IP address. I am now logged into my private instance from my public instance within the VPC. Let us now ping Google from my private instance. So I am telling my private instance to connect to Google. As you may see now that it is not able to exchange any packets. It means that my private instance doesn't have any connection with the internet, which is what we want our private instance to be. Many of our private instances inside our private subnet needs access to the internet. It may be because of practical reasons like updating our database or updating our security patch, etc. So how do we do that? For that, VPC provides us a concept of NAT gateways. NAT gateway is created so that our private subnets or the instances within our private subnet can get access to the internet. It needs to be noted here that private NAT gateways are one-way access. The full form of NAT is Network Address Translation. NAT devices enables instances in the private subnet to access the internet or other AWS resources. But it prevents the internet from initiating connections into the instances. So it's a one-way communication wherein our private subnet can connect to the internet using this device or using this NAT concept. How do we do that? We need to create a NAT. We create a NAT gateway. It needs to be noted here, or it can be seen from this illustration that the NAT gateway is created in the public subnet. We need to create Edureka demo NAT gateway in the public subnet, the public subnet of Edureka demo. We select that. We allocate to it a IP address by using the concept of allocate elastic IP address, and we create this NAT. Let us go and look whether in what state it is. As you can see, we have created a NAT gateway. It has been assigned inside VPC Edureka demo under the public subnet, and it has been assigned a private IP address. Now we need to go to the route table and update our route table for the private subnet or private RT. What we need to do is we need to give it a route 0.0.0/0 and connect it to the NAT gateway. You may see here that in the drop down the NAT gateway which we have created. Therefore, what we have done now is we have created a NAT gateway inside our public subnet. We are now connecting or providing a route for our private subnet to connect to this NAT gateway. This NAT gateway now will be connected to our IG or internet gateway and can access the internet. Let us do it. We have created our routes and updated our route table. Let us see whether our private subnet can get access to internet as it has been routed via the NAT. I am in my private instance right now. I tried pinging google.com before NAT gateway. It did not receive any information back from Google because it couldn't connect to or it couldn't ping that website. Now let us do it again. Before that, let us check whether NAT gateway has become live. It is still in pending mode. Let us wait before its status changes. Yes, so now the NAT gateway is available. Let us try pinging google.com. Perfect. As you can see now, the private subnet is able to access google.com. Why? Because we have created a NAT gateway. This NAT gateway is connected to the internet gateway. For now, the private subnet or the instances within the private subnet can access the internet via NAT gateway. This gives us the practical gateway wherein we can update our private instances. Also, it is very important to let you all know that once we have done or completed our demo, it is prudent to delete all the instances, otherwise you may be charged for the same. Let us do that so that we can repeat whatever we have done. The first thing which we need to do is delete our instances. So we have created 2 instances. Let us delete them. I am doing this so that we can repeat whatever we have done. We had created 2 instances, one instance in our private subnet, that is private instance, and the other instance, that is public instance, in our public subnet. Let us delete one by one. We go to instance state and we terminate the instance. Let us do it similarly for our public instance. Instance state and terminate our instance. So what we have done now is we have terminated our instances within the public and private subnet. Now the whole thing is we need to delete our whole VPC. So the first thing which we need to do is we need to delete our NAT gateway. Let us delete the NAT gateway which we created. We go to actions and we click on delete gateway and we type in delete. It has been deleting. It will get into delete stage. Once we delete our NAT gateway, which was used to access internet by the private subnet, let us go and delete our internet gateway. Before we delete our internet gateway, we need to delete it from our route tables. Otherwise, it may not allow us to delete it. We go here, we go to our routes, we edit our routes, and we delete our internet gateway. Edit routes, and this has already been deleted, the NAT gateway. So it is giving us the error. We delete that part also. Once the internet gateways have been detached, let us now delete the first, detach it from our VPC. It has detached from our VPC. Now we can go to our VPC. We need not delete our subnets one by one. What we can do is we can now delete our whole VPC. So we delete our VPC. We need to type in delete and delete. Herein the VPC is being deleted. With this, we have deleted all our instances within our subnets and we have deleted the VPC which we have created. As we did in our hands-on, we had given to each of the instances a security group. We had mentioned SSH, HTTP and HTTPS. Therefore, security groups are working at an instance level. Security group is required to control the inbound and outbound traffic of your EC2 instance. It acts as a firewall at the instance level and not at the subnet level. So basically we are assigning the security groups, or we are assigning in layman terms, who all can access our EC2 instances. AWS also provides us with an extra layer of security by the name Network ACL. Network Access Control List. It is one of the features in AWS. As you can see here, this is the default ACL list or NACL list which has been created. We can assign Network ACL to each of the subnet which we created. It is an additional security layer, controls the inbound and outbound traffic rules at a subnet level. So it means that at a subnet level, we can have one more layer of security, which will then overpower the rules which we had for our instances, or the security groups which we have assigned for our instances. It allows us both allow and deny rules. Therefore, the basic difference between network ACL and security groups is network ACL are stateless. It responds to the allowed outbound traffic and are subjected to the rules of inbound traffic. Security groups, on the other hand, are stateful. They respond to the allowed outbound traffic and can flow regardless of inbound rules. Importantly, NACL are defined per subnet. It is an extra layer of security. Security group have to be defined at an instance level, and every instance can have a different set of security groups. Lastly, a subnet can be assigned only one NACL, and if not associated explicitly, it can be associated implicitly with the default NACL. Whereas in security group, an instance can be assigned 5 security groups, and each security group has 50 rules. Now let us understand about another important concept, that is VPC peering. This is one of the ways by which we can connect different VPCs. As you may all understand, in enterprise, there will not be only a single VPC. Different groups within the same enterprise, for example, the data analytics group and say the data science group, may have different VPCs. They may want to communicate between each other. AWS provides us a service known as VPC peering, by which we can connect one-to-one all the VPCs within the AWS. It may be in the same region or it may be in different regions. We can define the rules by which VPC peering can connect within different VPCs. This has an advantage wherein we don't need to connect two VPCs through a public network. It can be done using VPC peering. VPC peering allows us to connect one VPC to another VPC via direct network route using private IP address. You could peer with VPCs with other AWS account. It can be paired with other AWS account as well as with other VPCs in the same account. It has to be noted here, there is another service which is known as transit gateway, which can also be used in order to connect various VPCs. But that is a different topic of discussion. So now in this diagram, we illustrate how a VPC peering typically occurs. Here you may see that there are two VPC with two different IP addresses assigned. We need to have a connection between them. VPC peering is the service which we are opting for. We update the security groups to ensure that the traffic to and fro from the VPC peer is not restricted. As can be seen in this illustration, the peering request has been accepted by the blue group. Now there is a two-way connection between these two groups or these two VPC. To activate the VPC peering connection, the acceptor must accept the peering request as has been accepted by the blue group here. The request expires after 7 days if there is no action taken on the request. Once this peering request has been accepted, then we can create routes to connect the various instances between these two groups. Now we can update our route table once the peering request has been accepted. Update the route table of both the VPCs to enable the flow of traffic between them. Now that we have understood how a VPC is created, what is VPC peering, the other most important service of VPC is VPN and Direct Connect. At enterprise level, as can be seen in the illustration, the enterprise may have a data center which needs to communicate to a VPC. The existing data center may be keeping a copy of their data in their VPC or may have additional space in the VPC. In short, the existing data centers of the enterprise needs to connect with the virtual private cloud of that enterprise. So how do we do that? We can do it in two ways. One is virtual private network, wherein the concept of virtual gateway exists. This virtual gateway and the customer gateway can connect with each other. The two tunnels, the blue lines here, shows the two tunnels or the internet connection by which the existing data center has been connected to our VPC. VPN is a service that helps to connect your VPC to your data center through IPsec, Internet Protocol Security Protocol. So as we may all know, in layman, The transfer here takes place with Internet Protocol security, or rather it takes place in an encrypted form. The security here is much more higher than connecting with the VPC via a public network. It is a secure connection between your on-premise equipment and your VPCs. It needs to be noted here, the blue lines here denote internet. Now, what if this internet connection is patchy or the speed is not up to the mark? Also, there is still some level of breach of security which may take place on these connections. To avoid this, AWS is providing with a service within VPC known as Direct Connect. So what is Direct Connect Gateway? Direct Connect is a network service that provides a dedicated network connection from your premises to AWS without using the internet. So how does it happen? It happens in such way that there are vendors who provide for each region Direct Connect hub. Now the customer's data center can connect to this Direct Connect gateway. There are third-party vendors who can lay down these lines. In short, the Direct Connect gateway are connected to the endpoints of the region with high quality fiber. Their speed can go up to 100 Gbps, and these are connected directly to the customers' data centers. It provides us the advantage wherein we have higher speed of connectivity between the customer data center and the VPC on the cloud. It provides us with a dedicated line which gives us higher speed of connectivity between the customer data center and the VPC. So what are the features, Direct Connect features? Private connectivity to Amazon VPC. The speed is having high elasticity from 1 Gbps to 10 Gbps connections. Connections and virtual interfaces are managed easily. Enhanced security through 802.IQ VLANs. It reduces the bandwidth cost and consistent network performance. All of the major larger enterprises go with this feature of VPC. It is compatible with all AWS services. Let us summarize the difference between VPN and Direct Connect. VPN, it can be connected via the internet in a secure way. In Direct Connect, we connect it via dedicated lines without the internet. VPN is suitable for small workloads. Direct Connect are suitable for large and medium workloads. In VPN, we have the bandwidth constraints. In Direct Connect, we have virtually no bandwidth constraints. In VPN, only resources inside VPC can be used, while in Direct Connect, all resources of AWS such as S3, DynamoDB and VPC can be used. In VPN, the connectivity and speed is not stable, while in Direct Connect, the connectivity and speed is stable. Let us end this session by recommending you 4 best VPC practices. Certain best practices are: we need to design or architect our VPC thinking about mid to long-term horizon. We need to maintain proper logs of what is the outflow and the inflow of connections with our VPC. We can monitor our VPC using services like Amazon CloudWatch. We need to have proper use of all the availability zones of our VPC. This acts as a backup in case one of the availability zones are not available due to certain issues. Also, importantly, we need to study more in details about the security aspects such as security groups and NACL. The network addresses which we assign to our VPC should also be looked into in details so that it supports the growth of our VPC from mid to long-term horizon. With this, we recommend you to go through these official documentation from AWS on VPC.
AWS DevOps, and today we are going to talk about everything that you need to get started with it. But before we begin, let's look at our agenda for today. So first of all, we're going to start out by introducing you to the concept of DevOps. Then we are going to move on to an important component of DevOps methodology, which is a CI/CD pipeline. We are going to talk about continuous integration, continuous delivery, continuous deployment, and a series of steps that must be performed in order to deliver a new version of software, which is, of course, the pipeline. Then we're going to discuss a very important feature from the AWS suite, which highly simplifies the way you manage your CI/CD toolset, which is the AWS code pipeline, which basically helps you integrate with tools like GitHub, Jenkins, and Code Deploy, and enables you to visually control the flow of your app updates from build to production. Then we're going to move on to discuss some other AWS DevOps components, which will help you through the way in constructing your pipeline before we move on to the demonstration where we build a CI/CD pipeline on AWS. So first of all, let's talk about DevOps. So what is DevOps? Now, as most of you all might know by now, DevOps is basically a methodology. It's a set of practices to ensure faster delivery of software deployment. To stay relevant in the market these days, companies are expected to deploy quality software in defined timelines. Hence, the roles of software developers and system admins, or the dev and the ops team, have become extremely important, and a lot of juggling of responsibilities happen between the two teams. Programmer or software developer is responsible for developing the software. So basically, he's supposed to develop a software which has new features, new security patches or upgrades, and bug fixes from the previous installment. But a developer may have to wait for several weeks for the product to get deployed, which is also known as time to market in business terms. So this delay may actually put pressure on the developer because he or she is forced to readjust his dependent activities like pending or old code, new features, and products. Also, when the product is put into production environment, the product may or may not exhibit some unforeseen errors. This is because the developer writes code in a certain development environment which might be different from the ones of the product environment. So from the point of view of an ops person or the operations team, who are basically responsible for maintaining and assuring the uptime of production environment, something that has been sent to them to test, which has been confirmed runs, is not running on their systems. When the code is deployed, the operations team is also responsible to handle these minor changes or minor errors on the code. At times, the ops team may feel pressured, and it may seem like the developers have pushed their set of responsibilities to the operation side of the responsibility wall. But as we all know, it's all happening due to the inconsistencies in the environment, and no team is actually up to blame. Now, as the company keeps investing more time and money into products and services, the number of servers admins have to take care of also keep growing, and this gives rise to even more challenges because the tools that were used to manage the earlier amount of servers may not be sufficient to cater to the needs of the upcoming and growing number of servers. So we all are in a fix, right? But what if these two teams could work together? They could break down the silos, share responsibilities, erase inconsistencies in the environments, start thinking alike, and work as a team. Well, this is exactly what DevOps does. It helps you get software developers and operations teams in sync to improve productivity. And if I pull out an official definition, DevOps is the process of integrating developers and operations team in order to improve collaboration and productivity. And all of this is achieved through automation of workflows and productivity, and basically continuous everything starting from development to delivery to deployment, as well as monitoring of an application. DevOps focuses on automating everything and lets developers write small chunks of code that can be tested, monitored, and deployed in hours, which is different from writing large chunks of codes that takes weeks to test and deploy. Now, that was all about DevOps. Now, let's talk a little bit about DevOps and cloud, or DevOps on cloud. Why do we need DevOps on cloud? Now, understand that DevOps and cloud go hand in hand. They can be implemented individually, of course, but DevOps becomes twice as much efficient and beneficial when clubbed with the cloud. It can help an organization deliver new software features much faster in a more effective manner. Many organizations try to fix their application development processes by shifting from waterfall to DevOps. Now, they have this understanding that DevOps alone won't be that effective. So public and private cloud solutions are now evolving together with DevOps. This brings in products at a faster rate to the market through quick access to development environment and streamlined developer processes. Infrastructure as code and automation together reduces the cloud complexity and maintenance of servers and resources, which our ops team previously was very concerned about. The security also highly increases with automated repeatable processes that serve to eliminate error that can cause further issues. And even more importantly, it builds security controls from the very beginning to the very end of the process. Now, because you don't have any servers and your continuous operations are cloud-based, it also eliminates a lot of downtime. And last but not the least, scalability, which is one of the most important factors for applications as they are developed. When DevOps and cloud are clubbed together, it reduces the cost of infrastructure, and global reach also increases with this. Now that you know why you need a cloud platform, let's go ahead and look at our CI/CD pipeline. Now, what is a pipeline or CI/CD pipeline? It's nothing but a series of steps that must be performed in order to deliver a new version of the software. At its bare bones, at its most basic, you have your build, test, and deploy stage. The CI/CD basically stands for continuous integration and continuous deployment. So CI is basically continuous integration, which basically means bringing together all the developers' working copies to a shared mainline. All the developers working on parallel branches of a certain upgrade of an application merge their changes into one main branch. And CD stands for continuous delivery and deployment. Now, while the CI includes building and testing of your application, continuous deployment is about the processes that have to happen after the code is integrated for the app to be delivered to the users. These processes involve testing, staging, and deploying the code. So at the end of this session, what we aim to do is build a CI/CD pipeline for our demo app on AWS. So for that, we will have to look at a few components of AWS. So DevOps, when implemented on AWS, becomes a lot more efficient and effective for a productive lifecycle. And the steps that are involved in AWS DevOps are code commit, code pipeline, code build, code deploy, and optionally code start. So first of all, we have AWS Code Commit, which is a fully managed source control service, somewhat like GitHub, that hosts secure and highly scalable Git-based repository without the need of operating the system. It's mainly designed for developers who are supposed to store and version their code securely and reliably. For example, you have your IT administrators that store their scripts and configurations, and your web designers who can store their HTML pages and images, etc. The code commit is fully managed, has great availability, is secure, scalable, and pacens up your development lifecycle. For people not aware of code commit, think of it as versioning in your S3. But how it's different is that S3 supports versioning, but not collaborative file tracking features, which code commit obviously does. It manages batches of changes across numerous files made by multiple developers parallelly. How it works is that you create a repository in AWS Code Commit service via the console or CLI, and later using Git from the development machine, you can run git clone to connect the local repository and the AWS Code Commit repo. You can then modify your files on your development machine via the local repository and then run git add, git commit, and push it to the AWS Code Commit repository as you do with GitHub. Again, like Git, even Git pull can be used here to synchronize the files in AWS Code Commit repository with your local repo, which ensures that you're working with the latest version of the files. Next on our list, we have AWS Code Pipeline, which is a combination of continuous integration and continuous delivery services for a quicker and more reliable infrastructure and application updates. It automatically builds, tests, and deploys a user code whenever there is a code change, and it is completely based on user-defined release process models. It also integrates with AWS services like AWS Code Commit, Amazon S3, Code Deploy, Elastic Beanstalk, OpsWorks, and AWS Lambda. You can configure the pipeline either with your CLI or your graphical user interface. And like most services on AWS, Even with pipeline, you only have to pay for what you use. All of this is great and all, but why should you use code pipeline? Simple. By automating your software build, test, and release processes, AWS Code Pipeline enables you to increase the speed and quality of your software updates by running all new changes through a consistent set of quality checks. It automates your release process, it speeds up your delivery with quality, it allows you to choose your tools of choice, establish consistent release processes, and provide a pipeline history detail as your source of truth. Code pipeline basically breaks up your workflow into a series of stages like your source, build, test, and deploy, and gives you a revision option as a deployable content. Each stage can process only one revision at a time, even though multiple revisions can be processed in the same pipeline. And each stage will have at least one action to be performed, which is some kind of task performed on the artifact. Once all of the actions that are configured in a stage is complete, the stage is considered as complete. After a stage is complete, it transitions the artifacts created in that stage to the next stage of the pipeline, where you can manually enable or disable it, so it prevents changes from running through an entire pipeline. An approval action is granted only by the IAM user, and if an action fails, it does not transition to the next action or stage at all. So when a developer completes working on his code, he or she commits it to the source repository, and Code Pipeline automatically detects the changes and builds those changes. After that, the build code is deployed to the staging server for testing, and then additional tests such as integration or load tests are run by the Code Pipeline. Once all of the tests are run, if the code receives manual approval, then AWS Code Pipeline deploys the tested and approved code to the production instances. Also, every time when a user creates a pipeline, the Code Pipeline creates a folder for that pipeline in an S3 artifact bucket in that particular region to store input and output artifacts. Next on our list, we have AWS Code Build. Now, this is a fully managed build service in the cloud, which compiles your source code, runs unit tests, and produces artifacts that are ready to deploy. It eliminates the need to provision, manage, and scale your own build servers. It provides pre-packaged build environments for the most popular programming languages and build tools, and scales automatically to meet your peak build requests. Now, one prerequisite is that you must provide the AWS Code Build with a build project, which should include information as to where to get the source code from, build environment, build commands, and where to store the build output. How it works is that the code build will use the build project to create a build environment. AWS Code Build then downloads the source code from the build environment and performs tasks that you would specify in the build specifications. If there is any build output, the build environment uploads its output to the S3 bucket, and while the build is running, the build environment sends information to Code Build and CloudWatch logs. You can use the Code Build console, AWS CLI, or AWS SDKs to get summarized build information from Code Build and detailed build information from CloudWatch logs as well. Now that was all about Code Build. Now finally, let's talk about Code Deploy. Now, AWS Code Deploy is a service that coordinates your application deployment and updates across the fleet of AWS EC2 of any size. It automates your code deployment to any instance, handles the complexity of updating them. It also avoids downtime during application development and rolls back automatically if failure is detected. Apart from that, it also integrates with third-party tools and AWS to make your job easier. It has 6 primary components to be specific. You have application revision, compute platform, deployment group, deployment configuration, and the code deploy agent. Now, the basic skeleton of how your deployment workflow pursues is as you can see on your screen. You basically create an application with a unique name and set up a deployment group by specifying the instances to which you want to deploy your application and the deployment type. If you're using the Lambda platform, you just deploy your deployment group's name, followed by which in your deployment configuration, you specify the success or failure condition of deployment and to how many instances you want to deploy parallelly. Then you upload the application specification file to the S3 and deploy your application as specified with the help of your code deploy agent, which is running on each instance on an EC2 platform, or as specified in your specification file to the deployment group when you're using a Lambda platform. And finally, you check your deployment results. And if you face any bugs or issues, you can always roll back and redeploy. Finally, let's discuss a little bit about CodeStar, which is basically a cloud-based development service that provides tools that you need to quickly develop, build, and deploy applications on AWS. It's basically a very templatized format where you start developing on AWS in certain minutes and you could choose from a variety of project templates. All of the software delivery is easily managed and you can work across your team very securely using the CodeStar. And apart from all of this, you also are provided with a project management dashboard to monitor your application continuously. All you have to do as an AWS CodeStar admin is create a project and add users. Your users or team members will commit changes, which in turn will be built and deployed. And through consistent monitoring of the application, if there are any updates required or any bugs, the developers take a decision, make updates, fix bugs, and then the loop closes back in on the team, and that's about it. The development process takes little to no time using CodeStar. Now that we have spoken about all of these different components of AWS DevOps, I hope building the CI/CD pipeline would seem a tad more tangible to you. If you're new learners, you can always sign up for a free tier, which is free for the entire year. Obviously, there are limitations to all of the services beyond which you shall be charged, but that rarely happens. So if you're starting out with AWS and want to try out all of its features and services, the free tier is a pretty good idea. We already have a video on how to create a free tier on the AWS console. If any of you want to know how to create a free account, you can just go ahead and check that out. So we're going to be building a CI/CD pipeline using AWS, using Code Pipeline. And I'll try to be as slow and verbose as possible, as comprehensive as possible, so as to help you guys to follow me each step of the way. So what we'll be doing here is that we'll be creating a demo application, platform as a service application, and we shall be deploying it using the Code Pipeline. So let's go ahead and create our application first. So to create an app, we will be using the Amazon Elastic Beanstalk, which basically has a bunch of templates ready for you. Now, since this is a demo about Code Pipeline and not web development, we'll be creating a pretty rudimentary app. So let's go ahead and type Elastic Beanstalk. Using Elastic Beanstalk, we can make simple apps very, very quickly. And if you have already created an application, created a few applications, they are going to appear right here on your screen. But since we have created no applications using this particular account, this is a screen that will greet you. So we're going to go ahead and click on Create Application. So let's call this Deployment App. We're not very original, are we? We're not going to put in any application tags. You could put them if you like, but currently they're completely unnecessary. On platform, let's pick PHP. And it automatically fills up the platform branch and version with the latest ones available. Then I'm just going to be using the sample application code and click on Create Application. Now this is a platform as a service app. So basically, once I click on Create Application, I wouldn't have to worry about any background processes or creating the infrastructure. Elastic Beanstalk is going to do that for me on its own. And here it's going to show you all of the steps that are taking place, like create environment is starting, using Elastic Beanstalk as Amazon S3 storage bucket for environment data, so on and so forth. Now this will take some time, so let's go ahead and parallelly do something else. I'm going to open another tab. Now the AWS console. Okay, thankfully it did not ask me to sign in again. So while my app gets created, what I'm going to do is I'm going to create the pipeline. So I'm going to type in Code Pipeline. And the funda is simple even here, guys. You're just going to put in certain details and your pipeline will be created for you. Now, this is your dashboard. This is where all of your recent pipelines will appear. Since in this free tier, we have no pipelines created, hence you have no results to display. So first things first, I'm going to create a pipeline. So click on this big orange button which says create pipeline. I'm going to give the pipeline a name. Let's just call it demo pipeline. So as a default, I'm just going to fill in a role name, AWS Code Pipeline, service role, US East, demo pipeline. Then click on next. So for source provider, I'm going to use GitHub. And for that, I'll have to connect to GitHub. And it'll ask me to authorize the code suite. Okay. Okay, once you have successfully authenticated the account, you can go ahead and search for the repository. Here, I'm going to choose the demo-code deploy app, which is actually a sample app I have forked from the AWS code pipeline repository. You can go ahead and look for it as well. It will be available in the AWS code pipeline's GitHub account. Yeah. And in the branch, let's select master branch and click on next. Now we move on to the build stage. Because I have nothing major to build, I'm just going to go ahead and pick skip build stage. Then you will be prompted with a notification which will ask you if you're sure to skip your build stage. Now, since I have nothing major to build, yes, I am going to skip this build stage. And for deployment, here we are going to choose a deploy provider. So here I'm going to use Elastic Beanstalk and put in my application name and my environment name. Now our application name was deployment app and our environment name would be deployment app environment. This is something which gets created automatically. So we're going to go ahead and click on next. And finally, we are at the review stage where you can go ahead and review all of the details that you have just put in for your code pipeline. And I'm just going to create this pipeline. It's pretty simple to do. Now this might take a few moments, so kindly be patient. And then you are greeted with a notification which says, success, congratulations, your pipeline has been created. Now here you can go ahead and release changes if you want. Our IAM role is in place that we had created earlier. Our pipeline is a success. Now all we have to do is wait for our application to get created, and then we can go ahead and deploy our application. All right, with that, our application has been created. It has OK health, and you can see the platform here. You can see the running version. You can see all the details, all the recent information regarding the app. Now, this is a platform as a service. It basically runs all of your processes in the background. Now, if you would have gone ahead, created this app, configured your IAM user, configured everything else that was needed, this would have taken you a lot of time. But because you are using a platform as a service feature of AWS, this entire process is automated and your work is simplified. So if you go down and look at the recent events, one thing you can see is your instance deployment is completed successfully. Just in the line above that, you can see that your new application was deployed to running EC2 instances. So basically an instance is running on EC2. So let's go ahead and go to EC2, click on instances running. There is one instance running, obviously, we all know which one that is. And this is your deployment app. Now, if we go ahead and click on it, here you can see the instance state, it's running, and your pipeline, your source has succeeded, your deployment has succeeded. You go here, you can go down, take a look at your IAM role, your subnet ID. So with that, your instance has been deployed and you realize that your demo pipeline has worked. All in all, I would like to say that AWS provides a set of flexible services designed to enable companies big and small to rapidly and reliably build and deliver products using the AWS suite and DevOps practices. These services simplify provisioning and managing infrastructure, deploying application code, automating software release processes, and monitoring your application and infrastructure performance. DevOps is a lethal combination of cultural philosophies, practices, tools, and technologies that increase your organization's ability to deliver applications and services at a very high velocity, which is consistently evolving and improving products at a faster pace than organizations would have using traditional software development and infrastructure management processes. This speed enables organizations to better serve their customers and compete more effectively in the market. I would like to leave you with that thought. My name is Upasna. Thank you and have a great day.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!